Welcome to the IBM Technical Support Professional Certificate. Did you know that industries worldwide depend more on technology now than ever before? That's because more people are using technology in their everyday lives, including working remotely, taking online classes, and even having health checkups with a doctor via webcam. With a worldwide increase in demand for technology comes an increase in need for user support for all technology-related needs. Who will provide technical support to individuals, companies, and organizations? Professionals who are knowledgeable in the fundamentals of computer hardware, operating systems, software, networking, storage, cybersecurity, and cloud computing. According to the most recent U.S. Bureau of Labor Statistics report, about 70,400 computer support jobs are posted annually in the U.S. alone, and job growth in the computer support industry is projected to increase 9% through 2030. At the time of this course publication, the median U.S. computer support specialist salary is $57,910 US annually, and per hour pay is almost $28 US. Technical support jobs are also a great way to start on your path to a high-paying career in information technology. This certificate consists of several engaging and informative courses designed to introduce you to the fundamentals of technical support as well as information technology fundamentals. Additionally, this professional certificate can help you prepare for the CompTIA IT Fundamentals Certification exam. This is a beginner-level certificate, which means that anyone, even if you're new to IT, can take this course. You don't need prior experience in IT or technical support. No college degree is required. All you need to get started with this certificate is a willingness to learn and a basic computer literacy to take online courses through your web browser or mobile app. The courses in this certificate will introduce you to the essential parts of IT. You will learn about hardware, software, networking and cybersecurity, cloud computing, ticketing systems, and careers and pathways in IT. Throughout the courses, you'll hear from IT insiders as they share their experiences and what they've learned as they've progressed through their careers. Some of the experts you'll hear from are Aditya Pundir, an IT manager, Michelle Sanchez, an instructional designer who started in help desk, Mike Schwartz, who works in IT support, and Amy Taylor, an enterprise support technician. You will learn in this course through guided instructional videos that walk you through key concepts with essential need-to-know facts. Interactive exercises will reinforce what you've learned in videos. Insider viewpoints allow you to learn from professionals working in many fields of IT. And practice assessments and graded assessments will help you gauge your knowledge and prove what you've learned. Upon completing all of the courses, you'll earn a shareable badge and the IBM Technical Support Professional Certificate. Why do you need a professional certificate? A professional certificate is beneficial for you because it's proof of your knowledge and accomplishments. The IBM Technical Support Professional Certificate has been specifically created to focus on the core knowledge you will need to possess to succeed in technical support and beyond. The courses work together to familiarize you with the elements of IT, introduce you to hardware and software, help you build your IT skills, and provide you with hands-on labs to practice using what you've learned in the course. When you've completed the courses in the certificate, you will receive a professional certificate so that you can share your hard work and accomplishment with potential employers and your professional network. One of the many benefits of the IBM Technical Support Professional Certificate is that all of the courses are online and ready to start when you're ready to take them. The courses have flexible schedules, meaning you can complete the course at whatever time is most convenient for you and at your own pace, even if you have only 2 to 3 hours a week to spare. Or you could even complete the entire professional certificate in as little as 3 months if you spend 5 or more hours per week on the courses. Financial aid is available for those who qualify. So, if you are not sure this program is right for you, you can try a free 7-day trial, or you can audit the courses. These options give you the opportunity to sample the content and determine if the courses are right for you. And remember that we're here for your success. If you have any questions about the courses or the professional certificate, just ask. So, what are you waiting for? Let's get started. Welcome to the IBM Technical Support Professional Certificate Overview of Courses. This certificate includes introductory courses on technical support, hardware and operating systems, software, programming and databases, networking and storage, cybersecurity essentials, and cloud computing. The certificate also includes the final course, Technical Support Case Studies and Capstone, to apply your knowledge and skills. The course, Introduction to Technical Support, describes many support essentials, including the roles and responsibilities of technical support professionals, career pathways and progressions in information technology or IT, support tools, ticketing systems, technical skills, and soft skills, all of which are needed to succeed in IT support. In Introduction to Hardware and Operating Systems, you'll learn about internal hardware computer components, including motherboard components, central processing units or CPUs, hard drives, and expansion slots. You'll also learn the essentials of basic workstation setup, commonly used operating system settings, screen capture commands, and effective troubleshooting practices. In the Introduction to Software Programming and Databases course, you'll learn about software, web browsers, software development, programming languages, and database management. In Introduction to Networking and Storage, you'll learn how to diagnose and repair basic networking and security problems. You'll also learn about network types and standards, wired and wireless connections, and common network storage and network sharing options. In Introduction to Cybersecurity Essentials, you'll learn about the fundamentals of cybersecurity. You'll also learn how to recognize common security threats and risks, examine the characteristics of cyber attacks, and explore methods for securing and managing confidential information. In the course Introduction to Cloud Computing, you'll discover the many elements of cloud computing and how cloud computing is changing the world of technology. You will identify various cloud service models, deployment models, and key components of cloud infrastructure. You'll also learn about cloud security, monitoring, emerging trends, and job roles in the cloud industry. And finally, in the Technical Support Case Studies and Capstone, you will apply your knowledge and skills to practical IT support scenarios. You will also complete a final exam designed to prepare you for the CompTIA IT Fundamentals Certification exam. Are you ready to begin your journey toward becoming a technical support professional? Start on your first course today. Welcome to the course Introduction for Technical Support. Did you know that worldwide demand for technology is increasing? This means that support for technology is also increasing. In order to keep up, organizations and their clients must have fast, accurate resolutions for technical issues. And they will need people like you for jobs in technical support. According to the most recent U.S. Bureau of Labor Statistics report, over 70,000 computer support jobs are posted annually in the U.S. alone. And job growth in the computer support industry is projected to increase 9% through 2030. At the time of this course publication, the median U.S. computer support specialist salary is almost $60,000 annually, and per hour pay is almost $28. Technical support jobs are also a great way to start on your path to a high-paying career in information technology. Many others, like you, start in entry-level positions in technical support and then find careers in IT that are just right for them. Michelle Sanchez started her career in technical support as a help desk technician. That path led her to where she is now, an instructional designer for an information technology company. Rav Ahuja spent the early part of his career in technical support for database software. Now he's a program director for technical content and strategy at IBM. Whether you're looking to start in IT or thinking about switching to a new career in IT, technical support is a great place to start, regardless of whether you have a college degree or not. Technical support can offer a career with flexible work options like remote and hybrid work and alternative schedules. And it offers multiple career paths, both within technical support and in IT-related jobs. If you enjoy making a positive difference for others, technical support can be a rewarding career. This course is the first in a series of IBM courses intended to help you develop IT fundamental skills and knowledge. When you complete this course, you'll be able to describe technical support and its roles and responsibilities, develop a customer support mindset, recognize technical support career paths and progression, identify support tools and systems in technical support, and explore the features and benefits of ticketing systems. Additionally, this course can help you prepare for the CompTIA IT Fundamentals Certification exam. In this course, you will learn with guided instructional videos that walk you through key concepts with essential need-to-know facts, interactive exercises to reinforce what you've learned in videos, insider viewpoints that enrich your understanding of IT support work, practice assessments to help you gauge your knowledge, and finally, graded assessments to prove what you've learned. Upon successful completion of this course, you'll earn a shareable badge and certificate that you can show to prospective employers. During this course, you'll be hearing from several professionals who have worked in technical support. Let's meet them.
Hi, this is Mike Schwartz. I retired 39 years ago from IBM as an IT specialist. Currently, I'm the office manager in IT support for Rosa & Rosa Law Office.
Michelle Sanchez, instructional designer at SkillUp Technologies.
Hello everyone, myself Aditya Pundir. I take care of IT support and operations globally in SkillUp Technologies.
Hi, my name is Amy Taylor. I am an enterprise support technician for Meta.
Hi, I'm Rab Ahuja, and I'm a global program director at IBM. I started off my early career in technical support.
We're here to support your success. If you have any questions for the course staff, or if you want to connect with your peers in the course, please feel free to post on the course discussion forums. We're excited that you're here, so let's get started. Welcome to Becoming a Technical Support Professional. After watching this video, you will be able to define technical support, discuss the importance of technical support, and list reasons for choosing technical support as a career. So, what is technical support? Technical support professionals have many names for the same or similar roles. Sometimes they are referred to as tech support, IT support, or computer support professionals, just to name a few. In this course, we'll use the name technical support. Professionals in technical support discuss technology-related topics and problems with clients and customers ranging from computer networking issues to reading emails. They might also be responsible for installing and configuring hardware and software. Technical support professionals also troubleshoot, diagnose, and then resolve technology-related issues, usually with people who have less knowledge about technology and need assistance. Successful technical support professionals are good at listening to problems and offering support, answering questions about technical issues, understanding technical terms and concepts, and resolving issues for others using non-technical terms. What is the difference between a customer service representative and a technical support professional? A customer service representative is trained to listen to customers with empathy while attempting to understand the customer's confusion or frustration. They deal with general product experience, payment, delivery, and customer account-based queries. They also focus on friendliness and customer experience as they are assisting the customer. They may focus more on making the customer feel better about a problem. Technical support professionals may need to do all that a customer service representative does, plus more. While they listen to understand a problem, they also work to solve and resolve an issue. They focus on resolving technical issues quickly and effectively. Sometimes they provide steps for customers to take, or they deliver bad news, like a piece of technology might be beyond repair. Why do companies use technical support? Businesses use technical support in the following ways: troubleshooting and fixing technical issues, setting up accounts for new users and employees, repairing and replacing computers and tools, assisting companies with network security and firewalls, training users on how to use hardware and software, logging and tracking reported problems and actions taken, and fostering positive relationships with clients and potential customers. Who uses technical support services? Different kinds of companies, from large to small, use technical support to assist their customers. Businesses that offer technology and telecommunication services, professional associations like medical offices, financial groups, and legal organizations, and retailers and manufacturing companies. Why is technical support important? It is important because it allows companies to provide helpful solutions to their customers. When companies provide support to customers, they are viewed more positively, which can mean an increase in business. Additionally, companies with helpful technical support are viewed as trustworthy by customers. As a result, these customers are more likely to stay with the company. Technical support also helps companies track and troubleshoot their technology. This can, in turn, lead to product improvement, which results in helping companies develop more desirable products. Technical support is a good profession for people who like problem solving, enjoy helping resolve technology issues, like working towards solutions with others, and want to make a positive impact on others. A technical support career might be right for all the following reasons. You'll learn a lot about technology, especially technology specific to your company. You will learn effective techniques for solving problems, or you'll refine the skills you already have. You will develop your professional skills using technology like phones, email, live chat, social media, and online community forums. You might also build transferable skills like sales, marketing, and product development. You will learn how to network in your company and how to seek out the help you need. And you will open the door to many other opportunities and paths in technology-related careers. In this video, you learned that technical support is working with clients and customers to solve technology-related issues. Technical support professionals resolve issues while making a positive impact on customers and clients. And a career in technical support can help you learn more about technology, develop your professional skills, and open the door to many other opportunities. Can someone with no IT experience start a career in technical support? What is your advice to someone with no IT experience and wanting to start a career in technical support? How do they get started?
Oh, absolutely. Anyone can get started in technical support. What you have to have is a natural curiosity for how things work. I've always had that trait ever since I was a kid, wondering how things worked and why they worked the way they did, and going around the house and trying to fix things that were broken.
Yes, I think you can have a position in IT support without prior experience. My suggestion would be to learn all you can about the products that you'll be supporting. Some products will be easier with less experience, some more difficult. Hardware generally will be more difficult, especially large systems, which I have a background in.
So technology support or tech support is a great career, whether you have any prior degree or IT experience in the field. You essentially require two sets of skills: the information technology skills as well as customer support skills. And you can, if you already have some background in either of these, that's great.
You can become a technical support worker with any degree. Employers prefer applicants to have an IT-related qualifications. But apart from that, I personally feel that a technical support executive must do the certifications in the domain they are into.
And my background was originally in finance, and a friend of mine suggested, why don't you try getting a job as a help desk technician or an entry-level technical support job, and that'll help you get your foot in the door and get some hands-on experience working with IT.
So I think the best way to sort of get into this career and kind of do that is if you can fiddle around with computers in general and just learn what you can about them, that was a great start. But like the very basics of learning what you can about them via the web or books, reading, that kind of stuff. For just starting out, trying to get a CompTIA is a very, very big start. So studying for that and getting that experience under your belt.
You can develop these skills by taking courses, by getting certifications or completing diplomas. And I think, an entry into technical support is a great way to start any type of IT or tech-related career.
I had no experience, no technical experience at all, other than, the machines that we use at the bank to accept customer deposits and, run reports and that type of thing. And if I can make it with, no skills, and I started in IT when I was 30. So I'm a lot older than some people that are just, getting out there, and trying to figure out what they want to do in their career. So I think if I can do it, anybody can do it.
Welcome to Career Opportunities in Technical Support. After watching this video, you will be able to identify opportunities in technical support careers and discover technical support career paths and advantages. So, why is a career in technical support a good idea? More technical support professionals are needed to support the rising use of technology. When demand increases, compensation increases too. Median wages for technology occupations are 89% higher than median national wages. Healthcare and social assistance industries are increasing their need for technology. And more remote work opportunities for all kinds of occupations means more companies need more technical support. Maybe you're wondering, what is the technical support work environment like? Technical support professionals work in many different environments. They may work on-site at a call center, answering calls and resolving technical issues. Entry-level technical support professionals could also work in business offices and professional spaces. Some companies may even offer remote work, allowing employees to work from home. Technical support professionals may support clients and customers by answering questions on the phone or through email. Or they may provide support by resolving technical issues through live chat, social media, or discussion forums. Depending on the company you work for, your work environment may be formal, casual, or somewhere in between. What does the future of jobs in technical support look like? According to the U.S. Bureau of Labor Statistics Employment Projections Program, there will be significant increase in technical support jobs over the next 10 years. Demand for computer user support specialists is projected to go from 650,000 to more than 700,000 in the United States alone. And demand will increase for computer support specialists by over 72,000 jobs, increasing from 2020's total of 840,000 jobs to over 916,000 jobs in the United States. Jobs for computer network support specialists are projected to increase by over 7% by 2030. Jobs for computer support specialists are projected to increase by 8.5%. And computer user support specialist jobs are projected to increase by almost 9%. Collectively, demand for computer occupations are projected to go up 13% in the United States by 2030. Someone with little to no experience might start a technical support job at an entry level. However, on-the-job training allows workers to specialize in technical support roles. With experience, more opportunities lead to advancement in various roles. A lot of companies use a tiered approach for job roles in technical support. A lower tier employee would be at the entry level as a technical support representative. A lower tier to mid-tier employee could be a technician. Mid-tier specialists might earn more than lower tiers, and mid-tier engineers have more experience and usually focus on a specific path in technical support. And upper-tier employees are usually the managers or analysts. Current jobs in technical support vary slightly in title and salary, but most have similar titles. According to CompTIA, technical support representatives and specialists made a median salary of $33,500 with almost 8,000 job postings for 2020. Help desk or desktop support technicians earned a median salary of $42,900 with almost 15,000 job postings in 2020. And IT support technicians and specialists had a median salary of $46,900, and there were almost 10,000 job postings for 2020. Additionally, PC support associates earned a median salary of $38,000 with almost 2,700 job posts for 2020. Field service technicians had a median salary of $40,000 and almost 2,500 jobs available in 2020. And service desk technicians and analysts earned a median salary of $42,000 with almost 3,000 job postings for 2020. Now, what are the advantages of a technical support career? Well, you do not need a college degree to get started. Many entry-level positions are available. Workers are in demand to fill technical support jobs, and on-the-job training allows professionals to acquire skills for the job while being paid. And finally, a technical support career offers a path forward to many other information technology professions. In this video, you learned that demand for technical support professionals is increasing. Technical support professionals can work in many different environments, remotely or in offices. Many jobs are available in different areas of technical support with varying pay ranges. And a technical support career offers a path forward to many other professions in technology. In this video, we will listen to several data professionals discuss how they started in technical support and what you should consider if that is your goal.
I didn't plan on being a technical support engineer when I started my career in IT. What I really wanted to do was be a network engineer and, design and deploy enterprise type networks and so forth.
I studied computer science in university, and I was offered a position working in a systems application support group. In addition to supporting the actual application code, I had to help the clients use the system. From there, I moved into systems programming, but I was still supporting clients on various tasks, various applications. Next, I became a webmaster in a small organization, so once again, I was still providing client support when needed. And finally, as a project manager, I still always had my hand in either desk-side support, helping people build or fix problems on their workstations.
Basically, it started out when I was little. I just like to take things apart. I like to fiddle around, and then we finally got our first computer, and it was really cool, and I just liked playing with it. And it started out as just like video games, stuff like that. But the more I played with it, the more I found all these cool little things you could do, stuff like that. And then eventually I went to college for programming, which I ended up not liking, but I really like the sysadmin side of stuff.
So I started off in technical support because I wanted to develop customer skills and experience working with customers, where I already had some technical background and technical skills doing software development. But for me, what was really important for me was to develop the human skills, the interpersonal skills. And that is the opportunity that customer support gave to me in order for me to be able to grow my career. My journey essentially was initially in online technical support. And gradually, as I got comfortable working with and dealing with people, I started doing live technical support as well.
Welcome to Technical Support Roles and Responsibilities. After watching this video, you will be able to discuss technical support roles, identify various technical support careers, and describe technical support responsibilities. Technical support roles go by many different names. One company might identify a role as a technical support representative. Another company might call the same role computer support representative. Or the terms for technical support technicians and IT support technicians might be used interchangeably. There are also different levels and tiers for technical support roles, such as desktop support technician, IT help desk support specialist, and desktop or IT support analyst. When considering the role you are interested in, look closely at the descriptions, responsibilities, and qualifications. The primary role of a technical support professional is to help clients and teammates. People who succeed have good customer service skills, strong critical thinking skills, a deep interest in new and developing technology, the ability to get to the root of customers' problems quickly, and the patience to help customers through a series of actions to resolve a problem. There are many career paths in technical support, even if they begin in the same place. You might not know what path you want to be on until you've started your journey, and that's okay. But keep in mind that each job in technical support can be a gateway to a variety of other jobs. So, where do people start? Many start at the help desk and desktop support. These technicians specialize in diagnosing and resolving computer and software issues, installing new technologies and training users on how to effectively use the technology, providing remote and on-site technical support to clients, customers, and even coworkers, backing up and restoring database files, and maintaining and updating operating systems. Technical support specialists and engineers are often responsible for testing and maintaining equipment and software, trying out new systems and programs, communicating with clients about technology use, training users on how to use new hardware and applications, and using ticketing systems to document hardware and software changes and solutions. IT support analysts and specialists offer higher-level support by providing IT assistance to staff and customers, developing procedures for reoccurring problems, evaluating and resolving complex problems, troubleshooting more complicated hardware and software issues, and maintaining databases and ensuring system security. Service desk technicians and analysts perform some of the following: answering IT support requests, resolving IT issues and concerns, communicating with clients on updates and resolutions, documenting and maintaining service desk processes, and performing system installations and updates. So, what would your day look like in a technical support role? You start your workday by signing in to work and starting all applications and programs that you support. You read messages and notifications and check for issues or critical problems. You learn about new technology, updates, and any possible changes. You help customers through phone, email, live chat, discussion forums, or social media. You assist with password resets, walkthroughs, installations or reinstallations, and escalations if needed. And you use your company's ticketing system to log and track your solutions. In this video, you learned that technical support roles provide valuable technical support to clients and customers. Some technical support careers are help desk, desktop support, IT support, and service desk. Technical support responsibilities include diagnosing and resolving issues, providing IT assistance to clients, and documenting and maintaining processes. And finally, technical support professionals complete daily tasks like checking messages and assisting customers. Welcome to Introduction to IT Infrastructure. After watching this video, you will be able to define IT infrastructure and describe the essential elements of IT infrastructure, Technical support professionals spend a lot of time working within what is called the information technology or IT infrastructure. The phrase IT infrastructure refers to the parts needed to run and manage an IT organization. IT infrastructure contains both physical and virtual spaces for transferring, storing, managing, and analyzing information. It also provides critical services or resources to customers. IT infrastructures also allow businesses to reduce issues related to connectivity, cyber safety, and productivity. The essential components of a solid IT infrastructure are hardware, software, and network. Hardware refers to the physical machines and devices that help the infrastructure run correctly. Hardware includes personal computers, mobile devices, servers, data centers, hubs, and routers, and switches. Software refers to the applications and programs used by a company both for the company and for its customers. Software includes content management systems, or CMS, customer relationship management, or CRM, enterprise resource planning, or ERP, additional collaboration, productivity, and business-specific apps, web servers, and operating systems, which are critical for connecting a company's hardware to the network. Now, the network refers to everything needed for the company to communicate both within and outside of the company. It is the system that links all information technology elements and the connected devices. The network includes routers, servers, data centers, hubs, and switches. And these work together with security software to reduce the threat of data breaches or damage to company information. Two main types of IT infrastructure are traditional and cloud. Traditional infrastructure is located on site and is designed to be used by a company or private organization. It is made up of hardware like computers, data centers, and software. Traditional infrastructures usually require more resources like power and physical space. Cloud infrastructure contains components that are accessed in the cloud and are not stored in one physical location. It is similar to traditional infrastructure, but it allows users to access services over the internet. Understanding the IT infrastructure will help you, as a technical support specialist, troubleshoot issues. You may encounter any of the following issues that need quick solutions. A customer's computer isn't working, and you need to identify why. The client needs a password reset, so the next step is to go through the process of setting a new password. Customers are unable to access their data, and you must get their network back up and running. Or a cyber threat comes to your attention, so you isolate the threat to protect the company's IT infrastructure. An effective IT infrastructure allows technical support to communicate within the company to quickly identify issues and implement solutions. In this video, you learned that hardware refers to the physical elements of IT infrastructure. Software consists of the apps used by companies both internally and externally. The network is the system that links all information technology elements and the connected devices. Two types of IT infrastructure are traditional, like data centers, computers, and business software solutions, and cloud, like cloud computing. And finally, effective IT infrastructure systems allow technical support to work more quickly to identify issues and implement solutions. Welcome to Technical Support Soft Skills. After watching this video, you will be able to define technical support soft skills and discuss how to improve your soft skills. What are soft skills? They are positive behaviors and attitudes that you use every day, and they enable you to communicate and collaborate effectively with your team and with clients to avoid conflicts. Why are soft skills important? When used well, these skills can enable you to actively listen to clients, work with others to resolve problems, and diffuse stressful situations. When you have strong soft skills, you have a customer service mindset. Your top priority is providing customers with a positive experience with your company. You also use strong communication skills to share information clearly, ask the right questions, and be concise. And your strong written communication skills will help as you take notes and document interactions with clients. You can get organized by using notes, messages, emails, and by developing a system to organize your work and access it quickly. You have leadership skills, even if you're not a manager. You motivate, encourage, and resolve conflicts within your team. And you can solve problems. You are the type of person who uses critical thinking skills to figure out a problem, and you explore the problem until a resolution is found. You can be flexible and adaptable by being open to new ideas, changing direction quickly, and learning new strategies. So, how does it all add up? Knowledge of technology is only one part of the equation in technical support. Another part is being able to work with others and manage social situations. Add to that positive behaviors and attitudes, and you can communicate, collaborate, and manage conflict with confidence. How do you set yourself up for success in technical support? Use your soft skills. Start by asking questions of your peers and supervisors. Take good notes and write down directions that are repeated and ideas that are important. Stay organized. Know where your notes are and discover what organizational style works best for you. And remember that it's okay to say, "I don't know," but follow it with, "I'll find out." Then be ready to find the answers and add them to your notes. How do you build a customer support mindset? Be empathetic and emotionally connect with your customer. Be customer-centered by encouraging interaction and remaining positive even if you have to deliver bad news. And be patient by actively listening. After a negative experience, reset and start over again with the next client. You can learn how to improve your soft skills on the job. The best way to learn is to document your notes on everything as you work so you can learn what went right and what didn't. Next, read suggestions and notes from your supervisors to get better. You will have times when you're under pressure and stressed. Try to learn new techniques to withstand pressure and reduce stress. You might question whether your experience is enough. Lack of work experience does not mean that you lack interest or passion in technology. Use your passion for technology to boost your self-confidence. Remember that success in technical support isn't just based on knowledge of technology. Your positive behaviors and attitudes can help you succeed, so be ready to level up your soft skills. Where do you learn to fine-tune your soft skills? Well, you can learn from additional online courses, search for podcasts and audiobooks about developing soft skills, and reach out to your peers and social groups to practice and refine your soft skills. In this video, you learned that soft skills are positive behaviors and attitudes that are used to effectively communicate, collaborate, and manage conflict. Soft skills include having a customer service mindset, communicating, being organized, leading, solving problems, and being flexible and adaptable. A customer service mindset is being empathetic, customer-centered, and patient. And finally, learning to improve soft skills is important to succeeding in technical support. In this video, technical support professionals will discuss the importance of a customer support mindset. Why is a customer support mindset so important to have in technical support?
For me, customer support mindset is something that I didn't really consciously thought about when I started off in technical support. But that is something that I came to a realization that it is crucial to have a customer support mindset. At one point early on in my job, we were all given customer t-shirts that had customer success, those two words on it. And I think it's only after wearing that t-shirt and realizing what those words meant and why they were important that I really start developing the customer support mindset. The customer support mindset is so crucial because, put yourself in the shoes of someone who's calling you, is having a problem, is, you have a particular problem and you call a technical support helpline or you open up a ticket. How would you like to be treated? So that is the attitude that you want to have as a technical support specialist.
Patience is critical to being an effective technical support professional. Most clients are frustrated when they first contact you. It's important to present a calm approach while doing problem determination so they're able to give you the details you need and not feel rushed or overwhelmed by the problem.
It is extremely important to be empathetic, customer-centered, and patient when you're working as a technical support engineer. Because if you think about it, technical support is the image of your company. When people are calling your company, they're not calling to talk to the CEO or to sales and marketing or QA or anything like that. They're calling customer support or technical support for a reason. They need help, and that's why they're calling you. And all it takes is for one customer to have a bad experience with a support organization to potentially tarnish the image of your company, no matter how good your company's products are.
So it is very important for a technical support worker to understand the client's customer situation, as they would be working on various IT, ERP business softwares and apps, which are crucial and has productivity and financial revenue implications too. Thus, ideally, tech support must develop the mindset to think beyond the technology and understand user pain and the intensity of the incident a user is experiencing. It helps a lot to establish a healthy support environment between a support agent and a customer, which ultimately enhance agent performance and customer relation too, resulting a good customer satisfaction, which is an end goal for a technical support executive.
Welcome to Basics of Technical Skills. After watching this video, you will be able to define technical skills and discuss the importance of technical skills in technical support. Imagine this scenario. You have a job interview, and one of the first things you're asked is what your technical skills include. You panic because you're not quite sure what they mean by technical skills. You're able to talk your way through the question, but you're not clear and direct about what your technical skills include. At the end of the interview, you're told they'll get back to you, which doesn't sound promising. What do you wish you could have done differently? Well, next time, you will be ready to discuss your technical skills. What's your strategy to improve your technical skills? If you're taking this course, then you've already taken the first step in your plan. You are interested in technical support and you're interested in technology. So let's turn that into an asset that you can add to your resume for your next job interview. First of all, what are technical skills? Technical skills are the abilities and aptitudes needed for you to successfully work in a technical support environment. And technical skills need training and experience. Let's break down the technical skills needed for technical support roles. As we do, think about what skills you already have and think about the skills you can build up. You don't need to have a deep knowledge of technology at first, but you do need some basic technical skills. Acquiring more technical skills is something you can do on the job. What should you know about basic programming and coding? Know that machine code is the computer's language, and developers speak to computers using source code. Source code includes compiled programming languages and interpreted programming languages. Basic programming skills include knowing the foundations of compiled languages like Java and the C languages, and interpreted languages like HTML, Python, and JavaScript. Being able to code even at a basic level will give you more of an advantage over other job applicants. Technical skills also include familiarity with both PC and Mac computers. Know how to identify the different computers and know the hardware. And be familiar with operating systems too, like Windows, Mac OS, Android, and Linux. If you don't have a lot of experience with these operating systems, use virtual machines and sandboxes to learn about them and improve your skills. You can also use free resources like your library to learn about different computers. Beginner-level knowledge of SQL basics and NoSQL basics is important. Be familiar with the differences between them. SQL databases are relational databases with rows and tables of data, and we use SQL queries to retrieve information from the databases. NoSQL databases are non-relational databases with unstructured data. As a technical support professional, you may need to provide support services for databases. Your responsibilities will include database application and deployment services, user management, security and access, scheduling database backups, updates and monitoring, database optimization, and running batch jobs in a database. Application logs provide information about events that have occurred in a software application. You should also be able to read and analyze application logs, read tracking information about the application, find timestamps to track any issues, and know where to find application logs that display levels of issues with labels such as information, warning, or error. You also need to understand what servers are and how they work. You should be comfortable with setting up and configuring a server and the software that runs on it, updating the server software, monitoring the server and maintaining it, maximizing server uptime, and managing virtual servers. Knowing about servers and showing that you are willing to learn more goes a long way in demonstrating your technical skill. And you should also know about support ticket workflow. Support tickets allow a company to create, track, manage, and resolve client queries. Some popular support ticket systems are Zendesk, Jira Service Management, and LiveAgent. Most systems will have similar workflow processes. A simplified example of the support ticket workflow is: a ticket is created. Next, technical support starts work on the issue, noting important details in the ticketing system. Then, necessary steps are taken to resolve the issue, and finally, when the issue is resolved, the ticket is marked as closed. Knowing how a support ticket moves through the system is more important than being a master of a single support ticketing system. Another technical skill you need is being able to use a knowledge base. A knowledge base is a collection of a group's knowledge about topics, like technical information, for example. Being able to search a knowledge base is an important skill that you already have. When you researched career opportunities in technology, you probably searched the internet and read about technical support. By doing so, you used a knowledge base to understand more about this topic. Do you enjoy trying out new hardware and applications? Your passion and interest in new and emerging hardware and applications goes a long way to demonstrate your technical skills and abilities. However, be aware that you'll also need a broad knowledge of these additional tools. Virtual machines, or VMs, are virtual computer systems within a physical computer, and multiple VMs can exist on one computer. A virtual private network, or VPN, allows a computer or device to establish a secure connection to the network in order to access sensitive data stored on servers. Network security protects networks and data from breaches, intrusions, and other threats. Network security includes access control, security software, network analytics, and more. IT infrastructure monitoring software collects and analyzes data from the IT infrastructure, systems, and processes, and it uses that data to provide information about availability, performance, and efficiency. And enterprise hardware refers to the servers, data storage devices, networking equipment, and other hardware that are part of a company's IT hardware resources. In this video, you learned that technical skills are abilities and aptitudes that are needed for professionals to successfully work in a technical support environment. Technical skills include familiarity with programming, operating system basics, application logs, servers, support ticket workflow, knowledge bases, and more. And lastly, additional skills include familiarity with virtual machines, VPNs, network security, enterprise hardware, and monitoring software. Welcome to Performance Evaluations of Technical Support Professionals. After watching this video, you will be able to identify the purpose of performance evaluations, describe technical support evaluation parameters, and explain the benefits of technical support evaluations. What is the purpose of a performance evaluation? A performance evaluation is a chance for your supervisor to review how you, the employee, are doing on the job. It defines what the company's expectations are for you. Your supervisor will make notes to record your performance. Then your supervisor will evaluate you. After the evaluation, you will receive feedback about your job performance. Once complete, the evaluation cycle will repeat itself. Your performance evaluation will then be used to define or redefine the company's expectations of you. So, what should you expect? Your managers will most likely be looking at your ability to accomplish your responsibilities, your decision-making abilities, your productivity, including your strengths and weaknesses, customer service abilities, work attitude, communication skills, and goals you have set and achieved. Let's start by looking at your work responsibilities. Your supervisor will evaluate if you possess the technical knowledge and skills necessary to perform your job, understand company policies and procedures, and complete required records, documents, and tickets. Your evaluator will also be looking to see that you have good decision-making skills. You can effectively evaluate technical issues and make the right decisions. You work on your own effectively, and when you encounter problems, you recognize them and that you are willing to make decisions about them. Your evaluator will also measure your productivity, meaning how much work you're getting done. It should show that you complete tasks in a timely and efficient manner, and it shows how long it takes you to resolve tickets. It will show that you work according to instructions, and your evaluator will note that you ask for help when you need it. Your performance evaluation will most likely include how you provide customer service. It will measure that you show a strong commitment to customers and that you are eager to assist customers and work towards a solution with them. Your supervisors might also look at and review call recordings, customer ratings, time to resolve measurements, first contact resolution and how many contacts per customer, and the average number of tickets handled. You may also be evaluated on your work ethics. Your supervisor might check that you display a positive, collaborative team attitude toward work assignments and responsibilities. You establish effective working relationships with coworkers, clients, and supervisors, and that you display a positive attitude toward criticism and suggestions. Your communication skills will also be reviewed. You should be able to write clearly and effectively, and show you understand written and spoken communication. Goal achievements will also be measured in your performance review. If your supervisor doesn't mention them, you should include your certifications and any new skills you've acquired. Your evaluation should show that you have set professional goals for yourself and that you are striving to achieve them. And in your next performance evaluation, be prepared to show how you have improved since your first review. Performance evaluations can be a benefit to you. They are an opportunity for you to know how you're performing in your role, ask questions, and make any corrections if there was a misunderstanding about the role. It's also your chance for recognition. Be ready to advocate for yourself and share your accomplishments. You can also use performance evaluations as a chance to share with your supervisor good job emails or messages from clients and coworkers. And you also have a chance to talk about your goals and discuss what you're doing to meet those goals. Ultimately, a good performance evaluation will provide opportunities for advancement in your career. In this video, you learned that performance evaluations provide valuable feedback to you, the employee, about how you are meeting your role expectations. Your managers will most likely be evaluating you on your ability to accomplish your responsibilities, serve customers, have a positive work attitude, and set goals for yourself. And performance evaluations benefit you by showing you how you are performing in your role, by providing an opportunity for recognition of your accomplishments, and by setting you up for opportunities for advancement in your career. In this video, technical support professionals will discuss how feedback from customers encouraged them and helped them improve. What feedback did you receive after making a positive impact on customers? And how did it help you improve or encourage you to keep working hard?
So there was this one time I was working in the technical support department for a company that did online backup and recovery, and also disaster recovery planning. And I was on call one weekend, and I got a call from a lady who was absolutely frantic. She worked at a small jewelry store chain down in Atlanta, Georgia, in the United States, and their Exchange server had gone down. They weren't able to send or receive email at any of their stores internally or externally. And they had a small IT department, but their main IT person who was familiar with Exchange was on vacation, and I had to walk this lady through reinstalling the operating system on the server. The disk had been completely corrupted, reinstalling Exchange, and anybody who's worked with Exchange knows how complicated it is, and to restore from a backup. I kept in touch with her. I'd call her every couple hours just to see if the restore was still running, and it was. And eventually the server was fully restored. We rebooted it and we tested it. We sent internal and external email, and it was functional again. The whole company was very pleased with that. And 2 weeks later, I received a delivery of fresh flowers from this company. It just kind of reinforced, my belief in what I was doing was right, and the way that I was helping customers, and, having patience, explaining an Exchange server recovery to somebody who had no technical skills whatsoever made me feel pretty good.
A few weeks into my tech support job, my manager came to my desk and said he wanted to see me in the office. And I went there and a bit scared. But he sat me down and showed me an email that he had received from one of the clients that I had been working with. And that email had a lot of positive things to say about the support that they received from me and how I helped solve a problem that had been nagging them for several weeks. So to me, it was a great encouragement. I was just doing my job, and I helped resolve an issue. And that encouraged me to work, better, help other customers more, develop deeper skills in technology and in support. And I continue to get similar feedback from other customers. And I think that really helps you and encourages you to move forward and continue to grow in your technical support role.
Almost every time you help a client with an issue, it's a positive impact. When you hear the excitement and joy in their voice when the issue is resolved, oftentimes quickly, it's very satisfying. They often say things like, "What will we ever do if you leave?" Makes it all worthwhile in the end. At the very beginning of the web, the World Wide Web, I ran a project to convert our hard copy how-to manuals into PDFs and make them available to our customers on the web. At the time, many web professionals were anti-PDFs because they were big and slow to download. They called them evil. I showed them that when properly built, they performed very well and customers absolutely loved them.
Can you tell us about a project that you were proud of completing, and why are you so proud of it?
My favorite project I've done was at my previous job. It all had to deal with our ESET internet security system. Basically, prior to this project, we just use a typical, we use a hardware that was for firewall for stuff, but then every computer just ran Windows firewall, and that was basic. And then we also had just plain ESET security, or antivirus. Talking with the CTO, he really wanted to upgrade it. So I started working with him on trying to look at implementing an entire internet security suite, taking over the whole firewall and antivirus stuff. So from there, he started just kind of like having me investigate stuff. And then from there, I kind of just took over the whole thing and just ended up finding out everything I could about it, different ways to implement it. And then going from there, I was just ended up being the lead on the project. And so it became, we got the entire thing set up. I created all the rules for it. And so we had different subsets for everything. It was really, really fun. And I learned very much about the internet security and firewalls and stuff. And so from then on, if anyone ever had a question with it, they came directly to me. The CTO would just kind of refer them over to me. It was really fun overall.
Welcome to Career Paths and Progressions in Technical Support. After watching this video, you will be able to identify various career paths in technical support and discuss career progression in technical support. So where does your technical support career path start? You might start as an IT support specialist, IT technician, help desk technician, or desktop support specialist, or you could start as a field service technician. You might also be wondering what skills you should have for these entry-level roles. You need to know how to access data and share with those who need it, actively listen to clients and their descriptions of computer-related issues, ask questions to determine the problem, guide customers through steps to resolve problems, train users on new computers and software, document changes, updates, and issues, and share information with other team members and managers. While some companies don't require any IT experience or a degree to start, some will require basic customer service experience and knowledge of technology. You can increase your chances of getting a better job with professional certificates and a computer science or related degree. Some mid-tier technical support roles are help desk analyst, technical support specialist, and Tier 2 support. But what skills are you expected to have in a mid-level role? Testing and maintaining equipment and software, trying out new systems and programs, communicating with clients about technology use, training users on how to use new hardware and applications, communicating on proper use of technology, and training new technical support team members. For a mid-level role like a Level 2 technical support specialist, you will need at least 1 to 3 years of experience with on-the-job training. Also, you might be required to have certifications from Cisco, Microsoft, and CompTIA, like A+, Network+, and Security+. Once you've gained experience in Level 2, you might advance to Technical Support Level 3, which usually requires 3 to 5 years of experience, advanced on-the-job training, and certifications similar to Level 2. In upper-level roles, you'll find Technical Support Leads and Managers, IT support team leads, and field engineer supervisors. Similar to the mid-level role, upper-level roles will manage systems and capabilities, research and explore new systems, software, and processes, train users on standard usage practices for hardware and software, manage ongoing issues in projects, communicate changes in policies to organization management, and manage and train teams. For upper-level roles, you'll need on-the-job training in leadership and more than 5 years of experience. And certifications needed include ITIL, Six Sigma, and other relevant certifications related to your role. A career starting in technical support does not need to end in technical support. Experience within one area of the information technology field can be used in other areas of information technology. Some roles develop cross skills, meaning what you've learned and practiced in one role can be used in another role you're more interested in or more passionate about. Think about the required tasks you enjoy doing and look at other positions that require similar skills. Interview for roles that fit your strengths and require skills you wish to learn more about. You can also use your cross skills to advance to better roles that allow for more responsibilities and offer more pay and benefits. You can also level up your skills to help you reach higher level roles in technical support. Roles that are related to technical support that you could move into are Network Administrator, Network Security Analyst, Database Administrator, Cloud Developer, QA Engineer, and Software Developer. In this video, you learned that career paths start at the entry-level technical support roles, move to mid-level roles, and then progress to upper-level roles. Technical support skills required for most roles are setting up and managing computers and devices, testing and researching new hardware and software, managing issues in projects, working with teams and clients, and troubleshooting and resolving technology-related issues. You can develop your cross skills to move to other roles you're more passionate about. And you can level up your skills to move up to more opportunities in the IT field. In this video, technical support professionals will discuss areas of tech support and how they found their niche. What career paths were available to you as a technical support professional, and how did you find your niche?
For me, I had a background in databases and working with databases. So the field in technical support that I chose was become a level 2 specialist for a database product. And so I was able to leverage my prior background and skills, and at the same time grow in technical support by developing some interpersonal and customer support skills.
After I graduated, I ended up getting just a basic call center job doing tech support for Subway. And for the most part, I ended up really liking a lot of what I was doing, stuff like that. And so when I moved out here to Bellevue, I tried to jump really hard into it. And I ended up getting a job at a nonprofit where I started out as a low-tier just IT technician. I would help the people in the company. It was great. But over time, I was there for almost 6 years, and it ended up being just I did everything. And so I took over like the servers. I would run specific programs. I was our NetSec or security person. I would go to different sites to install hardware and basically just kind of did everything. And so at this point, I moved over here to Facebook, and it's been great doing a lot more of that stuff, and I interact with customers a lot, and I still do all the hardware and stuff too.
So I started my career in technical support as a contractor working at a help desk for a really large credit card company in the United States. And I stayed there for a couple years, learning how everything worked. And after a couple of years, I decided to broaden my, horizons. And so I applied for and accepted a position at a company that specializes in virtualization and virtual server clusters and things like that. And I found it fascinating. I stayed there for 7 years and, increased my skill set and so forth. And then I made another move to another technology company that manufactures laptops and desktop computers and servers and so forth. And I worked as a tier 3 tech support engineer for that company for 1 year, and then was recruited into a technical training position for their enterprise customers, which I did for about 10 years. And that was really fascinating. I really enjoyed doing that. And then I left that company and went to work for a company that manufactured storage as an enterprise or tier 3 senior technical support engineer. And so that's a little bit about my journey in my career as a technical support engineer.
Welcome to Industry Certifications for Technical Support. After watching this video, you will be able to define technical support industry certifications, describe the benefits of technical support certifications, and identify industry-specific certifications. Okay, so what are industry certifications? They are awarded after a person passes an exam that certifies he or she meets industry standards for skills and knowledge. Certifications prove that an individual has learned strategies and concepts that are essential in the technical support field. Certifications also validate an individual's knowledge about information technology, or IT. They also certify that the individual has the skills required. And a certification shows that someone has a specialization in the field, even if he or she doesn't have on-the-job experience. Some benefits of certifications to you and your employer are more effective customer service. You will be able to troubleshoot more quickly and effectively because you have a broader understanding about various technologies and methods of working through problems. Increased productivity and resource management. You will be able to maintain your computer and understand more about security, networking, and software troubleshooting. And improved quality of support. You will be more familiar with common issues, customer situations, and ways to resolve those problems. For those interested in a career in technical support, a certification is a great way to get started. Some beginner-level certificates are available through CompTIA, Microsoft, Apple, the ITIL Foundation, and Cisco. So, if you want to work in technical support, the CompTIA IT Fundamentals, or ITF Plus certification, is one of the first certifications you should consider. It is for those who are trying to decide if an IT career is right for them, or for those who are just starting out. If you want to progress your career further in IT, CompTIA A+ is the next certification you should consider. Getting your A+ certification demonstrates that you've mastered hardware, software troubleshooting, networking, operating systems, device and network troubleshooting, security for devices and networks, mobile devices, virtualization and cloud computing, and operational procedures. Another certificate is the CompTIA Network Plus. If you're interested in the networking path, then getting the Network Plus certificate shows that you have the essential skills required for troubleshooting, configuring, and managing networks. Microsoft certifications, like Microsoft 365 Certified Fundamentals, is an introduction to Microsoft 365 and cloud services. Microsoft also offers role-based and specialty-based certifications and exams that professionals starting out their career can take to enhance their resume. The Apple Certified Support Professional, or ACSP certification, is for technical support and related IT roles for Mac users. The certificate shows that you understand Mac OS, can troubleshoot issues, and are able to support Mac users. Next, the ITIL Foundation certifications range from beginner levels to advanced levels, but you can start at a support center course and develop your skills in supporting customers, in IT role functions, and in troubleshooting methods. And the Cisco Certified Network Associate, or CCNA certificate, is for those wishing to further their knowledge of networking. The CCNA helps professionals highlight their skills in administering network maintenance, creating secure network access, and improving network connectivity. But you do not need to gain all of these certifications before starting in technical support. Begin by studying for just one of the certifications. Once you start in technical support, you can continue your learning by getting certified in more areas. And sometimes, employers are willing to offer some financial assistance or incentives to employees who wish to earn more certificates in their field. In an interview or at your job, be sure to ask what certification opportunities are available for you. In this video, you learned that certifications show that you have learned strategies and concepts that are essential in the technical support field. Some benefits of certifications are improvement in customer assistance, in productivity, and in support quality. Many beginner-level certifications are available through CompTIA, Cisco, Microsoft, Apple, the ITIL Foundation, and finally, certifications can be gained before you start in technical support and as you work in the field. In this video, technical support professionals will discuss skills critical for success in technical support. What skills are critical for success in technical support?
I think the most important skill is patience. It's not always easy to explain over the phone what the client should be seeing and then interpret what they are seeing. They are often embarrassed at their lack of skill, and you need to assure them that all is well and you'll help them work out all of the issues. Next is the ability to do problem determination and work out solutions.
Proficiency in the technical domain is must, but apart from that, experience in the help desk software is which is needed. They should have strong problem solving skills plus interpersonal skills. Of course, they should be creative thinker too. They must have previous experience in tech support or a similar job. A technical support executive should be very attentive towards the detail, and of course a good team worker too. Although you can become a technical support worker with any degree, employers prefer applicants to have an IT related qualifications. But apart from that, I personally feel that a technical support executive must do the certifications in the domain they are into. For example, if somebody is security professional or data information security professional, they should be certified with information system security certifications.
The skills that I needed, or that anyone needs to be a good technical support engineer, or to be successful in a role as a technical support engineer, number one is listening. You have to listen to the customer. Listen to what they're saying, repeat it back to them so you have a solid understanding of the problem that they're trying to describe to you, so you can take the appropriate steps to get it resolved. The second skill that you need is a soft skill, but not everyone has it, and that is patience. I always think that you can be taught the technical skill, but what you can't teach some people is solid customer support skills. Empathy, patience, being a good listener, being able to listen to what they're saying, how to calm down an irate customer. Those are some of the things that are critical to being successful in technical support and enjoying your position and being really good at what you do.
You can work with a customer. So like customer service skills are really fantastic because you got to be able to engage with the person, find out exactly what they're meaning, because you'll meet very many different people of high skill, low skill. And so sometimes they'll give you a very generic thing of this doesn't work, fix it. And you have to ask the right questions to figure out exactly what they're asking, what's actually wrong.
Welcome to Overview of Support Channels. After watching this video, you will be able to list various types of channels available to perform technical support, discuss factors that influence choice of support channels, and identify the most appropriate support channels for a given problem or scenario. Alright, imagine it's 30 minutes before your assignment is due and you're ready to submit your file to your online course. However, you keep getting an error message you can't sign in. What do? Don't freak out yet. You have support channels that you can use to help resolve your issue. After troubleshooting a few things on your own, you try searching online and your school's website support pages. You've just used one of the channels of technical support. Support pages are designed for self-help, and you can often find information like FAQs, documentation about services or products, wikis, and a knowledge base. You can also browse discussion forums for posts from other users who have experienced similar problems. But for your problem, your school's support pages make no mention of it. Now, email is for issues that might not need immediate resolution. Usually, companies provide their email addresses for support on their websites or in product emails and documents sent to their customers. If you have a question or an issue that isn't time-sensitive, you can email support and they can respond to you when they get to your email in their queue. This is one kind of asynchronous support. Organizations can also provide asynchronous support on social media platforms like Twitter, Facebook, YouTube, and Instagram. People who have an issue with a larger organization may choose to post on social media to get the company's attention. Public posts on social media allow customers to identify or tag the company and share their issue. Social media allows an asynchronous interaction between customers and companies. Customers can have their issues resolved, and companies can show they care about supporting their product. Now, phone support is synchronous, meaning the support happens live and in real time. It's good for those with urgent issues, like they can't submit their assignment online. Phone support is also for those who need to discuss sensitive information, like details about finances or health. And the phone is ideal for customers who prefer live, real-time conversations with someone who can assist them with their technical issue. Live chat also gives you access to technical support in real time through an app on a device or through a website. Through live chat, technical support can walk you through your issue to resolution. And some live chat tools will even indicate where you are on the company's website, so support can better assist you. If your device or hardware is the problem, video chat is helpful because it allows technical support to see what you are seeing. You can show the support person through video chat the steps you are taking to sign in to your college's website. Video chat can also be helpful if you have a hardware issue. Say, if you have a problem with your printer not working, you can show through video chat what's going on. Video chat can provide virtual hands-on help. And remote support is another form of synchronous support. Using remote software, a host device for technical support connects to a customer's device. Both need to be connected to a program for remote support, and both need to be connected to the internet to connect remotely. Remote support is also helpful if there is a setting on your device or if an update is needed and you need someone else to make those changes on your computer for you. And when all else fails, you can always use in-person support. This is when you need hands-on troubleshooting, preventative maintenance services, and hardware-related support. So, now you're down to only 15 minutes until your paper is due. This is urgent, so you decide to call the technical support phone number. After only a few minutes of chatting with someone on the phone, you discover the problem. The site hosting your online course was offline, but it's back up again. Your issue is now resolved, and you are able to log in and submit your assignment. Congratulations! You probably didn't realize that a lot was going on with your school's technical support while you were trying to submit your assignment. Before you realized you couldn't sign in, another user encountered the same issue and connected to technical support through one of the school's many support channels. Once technical support was notified, a ticket was created and support began working through the issue. Ticketing systems are also essential support tools, and they document, track, and manage customer issues to resolution. Organizations can convert incoming emails into tickets, log phone sessions like yours, or provide an interface where users can submit tickets directly. For your issue, the organization used internal support channels to identify and resolve the issue. All of this is so the school's many students can submit their assignments on time. But you're not the only one who has benefited from having many different support channels available. A Zendesk survey of its customers found the following. For simple service requests, customers surveyed preferred email over phone support, live chat, SMS text, and social media. But for complicated service requests, more of the customers surveyed preferred phone over live chat, email, SMS text, and social media. The results show that customers use a broad mix of channels to contact customer support. In this video, you learned that businesses and organizations often need to provide multiple support channels to address different problems and customer needs. Technical support can be provided through many channels using self-help, synchronous, and asynchronous tools. Ticketing systems are support tools that document, track, and manage customer issues to resolution. And customers use a broad mix of channels to contact customer support. Welcome to Remote Support Tools. After watching this video, you will be able to define remote support tools, identify the types of remote support, and discuss features and benefits of using remote support. Remote support software in technical support is a tool that allows technical support to access and control another computer that is in another location. Remote support software enables technical support to troubleshoot, install software, and provide instant support remotely. Why is remote support necessary? It can save a lot of time for both a customer and technical support. Instead of spending a lot of time with emails and trying to determine what a user's issue is, a remote support technician can access a user's computer and identify problems faster, which means that issues are resolved sooner. Remote support also means that technical support is available immediately when customers need help. Some common issues that technical support resolves using remote tools are connectivity or software issues with email, Internet, Wi-Fi, and virtual private network or VPN connections, slow computer operations, printer connections, necessary programs that are not working correctly or not at all, video conferencing issues, and security issues including unwanted adware and malware. There are two main types of remote support, attended and unattended. Attended remote support is when a customer is at a device and needs support. The problem needs to be solved as soon as possible. Attended support allows for hands-on support. This expedites resolution times and increases customer satisfaction. Now, unattended remote support is for maintenance support of groups of users and servers. The software does not require permission from users to access their computers, and users do not need to be at their computers for support to provide maintenance and support devices. Unattended remote support is ideal for installing updates, managing the IT infrastructure, and troubleshooting issues on many devices. So, how does remote support software work? Remote support needs two devices, a host device for technical support and a customer device. Both need to be connected to a program for remote support, and both need to be connected to the Internet in order to connect remotely. Technical support shares a passcode or identifier to the customer, who will then enter the code in the application on their device. This grants technical support access to be in control of the customer's display, pointer, and all functions. Technical support can install and uninstall programs, modify settings, and troubleshoot issues. Some examples of commonly used remote software are ConnectWise, TeamViewer, Dameware, Beyond Trust, and Zoho Assist. And some applications, like Windows Remote Assistance, come pre-installed with the computer's operating system. Some common features and benefits of remote support tools include the following. With remote control and screen sharing, technical support can remotely view and fully control a user's computer. File sharing is a feature that allows technical support to resolve issues that relate to bad files on a user's device. File sharing through remote support ensures that files are kept secure, which keeps the user's device secure. Technical support can also transfer support sessions to another person in technical support if the first technician is unable to resolve an issue. And multiple monitor navigation and support allows technical support to view and navigate multiple screens and monitors for customers. In this video, you learned that remote support software allows technical support to access, control, and provide support to another computer. Attended remote support software is used by technical support when a customer is at a device. Unattended remote support does not require users to be at their computers. And some features of remote support software are remote control, file sharing, transfer support sessions, and multiple monitor support. In this video, technical support professionals will discuss how they provide remote support to clients. What are some steps you go through when preparing to remote into a client's computer, and how do you prepare them and talk them through the steps you're taking to help solve their issues?
So here at Meta, the main thing we do as that is we connect in a lot of the time. We're moving away from the way we interact with people on a certain level, but basically we try to let them know, like, hey, is it all right if we share your screen? And for some places it's not as easy, but we can just click a button after they say yes, and we just kind of take over, and they're happy with it. At previous places, we have to request an entire number to enter in the system to remotely connect. And typically we will want to ask them to like, hey, close anything you don't want me to see, and then I will take over.
Gaining remote access into a customer system can be very difficult at times. Sometimes they're just looking for a quick answer, a quick fix, and they think that getting into a remote session is just going to prolong, their call, and they don't have time to do that. Oftentimes, too, it depends on who the customer is. If it's somebody, if your company is making products that are consumed by, other companies, and you're used to dealing with folks that work in IT, it's a lot easier because they understand remote access and are often quick to allow you into their system because they know that they can get their resolution potentially that much faster. But if it's, let's say it's a consumer product, it's a USB drive or, replacing a hard drive or a camera that they purchased and it's not connecting to their laptop, they can be really hesitant to allow you to connect to their machine, which is completely understandable. They may have things like their tax returns stored on there or other sensitive types of information. And they also seem to think that after we hang up the call that somehow magically we can just get back into their machine whenever we want to. So the first thing that you want to do is allay any fears that your customer might have with a remote connection. You want to explain to them why you would like to access their machine remotely and how much time it could save them, and that they'll be able to see everything that you're doing while the remote session is in progress, and that you won't do anything without their permission. So if you're patient and you gently explain these things to them, you'll probably have a better experience.
Remote technical support is both a great benefit as well as it can be pressurizing for the agents. It can be helpful because a lot of times you're trying to walk a customer into a particular, walk through a particular solution, and they might be doing something different from what you're telling them. So being able to try things out yourself makes it a lot easier with access to the desktop. But at the same time, the customer is watching you do certain things. So you need to be good at what you're doing. You need to really understand and make sure you have good skills in the system or the application that you're trying to debug or resolve a problem for remotely.
Welcome to Levels of Technical Support. After watching this video, you will be able to describe the need for tiered support, recognize the different levels of technical support, and identify support procedures and skills required at each level. What is the need for tiered or leveled support? Having tiered support has the following advantages. Strategically route issues to different levels of support based on the product, issue complexity, and severity. Having a timeline and protocol for solving issues helps the organization as it grows. For a growing organization, tiered support helps handle a large volume of issues effectively by using resources appropriately. Customer satisfaction is improved by reducing their wait time. And tiered support provides an opportunity for training tech support professionals and gives them a chance to broaden their skill sets. There are 5 levels of technical support, ranging from levels 0 to 4. Level 0 support is the self-service level where users can find help with FAQs or a knowledge base. Level 1 support is usually basic help desk service. Level 2 support is more in-depth troubleshooting of issues. Level 3 support includes support specialists and skilled engineers. And Level 4 is support provided by third-party businesses that might supply some parts of the components that are not directly supported by the organization. Let's look at the levels a little closer. Level 0 contains self-service support like FAQs on a web page or product documentation that users can retrieve online for themselves. It also includes chatbots for simple queries, discussion forums for help from other users, and knowledge bases for support. The next level is Level 1 support, which includes help desk. Common issues may involve support helping users navigate new applications and menus. Using phone, email, or social media support, Level 1 generally involves basic user and password issues, hardware and software installation, and setup issues. If unable to address the issues, Level 1 support escalates the issue to Level 2. Level 2 support deals with harder and more specific tasks than Level 1. They review the steps documented by Level 1 technicians and start troubleshooting issues escalated to them. They have in-depth product knowledge, technical skills, and excellent communication skills to help resolve issues and communicate the same to customers. If an issue isn't resolved by them, customers are escalated to the Level 3 support tier. Next is Level 3 support. Level 3 technicians are skilled specialists and analysts with a wide range of experience and wide access to resources needed to recreate the issue in a lab environment. The technicians attempt to determine the root cause of the issue, and this may lead to product changes and solutions passed down to Level 1 and 2 technicians. And the last level of support is Level 4 support, though it exists outside the organization. It includes contracted support for products sourced from other manufacturers. This may consist of support for printers, computers, software, machine maintenance, and other outsourced hardware and software. Level 3 or Level 2 support may forward some queries for review by Level 4 support. Now, IT support levels usually describe the skills and access levels the IT support personnel have. This table shows the skills required at each support level. At Level 0, users can browse and retrieve support information from the web or app-based platforms, including product details, FAQs, technical information, manuals, and search functions. Level 1 requires staff to have a basic level of technical knowledge. They are trained to resolve known problems and fulfill service requests by following documented standard operating procedures, SOP, or scripts. Level 2 requires support personnel having deep knowledge and a good understanding of the product or service. They may or may not be the programmers or engineers who designed and created the service or product, but they should have adequate knowledge and experience of the specified product or service. At Level 3, subject matter experts or SMEs and specialists typically have the highest level of skills and are often called product specialists. This group must have experience in solving complex problems and may include the actual creators, engineers, programmers, or chief architects who designed and developed the product or service. And the final level, that is, Level 4, prefers suppliers and business partners providing support and services for products or components that are not directly supported by an organization, but are essential for customer service. In this video, you learned that tiered support is needed to route technical support issues correctly based on product complexity and severity, and to improve technical support training and upskilling opportunities for tech support professionals. Tech support levels range from 0 to 4, of which levels 1, 2, and 3 are the main levels of tech support. And level 0 is a self-service tool for customers, while level 4 is usually provided from outside the company. Welcome to Service Level Agreements, or SLAs. After watching this video, you will be able to define Service Level Agreements, or SLAs, in technical support, discuss the key differences between response and resolution SLAs, and identify how priority levels with SLAs are interconnected. So, what are Service Level Agreements, or SLAs, in technical support? SLAs are legal agreements or contracts between businesses and customers. SLAs ensure quality, timeliness, and availability of technical support. They enable businesses to manage and meet customer expectations. And they can be time-based, especially in technical support when a customer might need rapid resolution to an issue. Okay, imagine this scenario. You downloaded and installed free software for an e-book reader. You find on the FAQ page for the company some information about the help offered by their team if you run into problems using the software. They also detail how to contact them. Additionally, they state how fast their support can handle your queries based on whether you are using the free version of the software or the paid version. So, when you installed and used their software, you accepted their contract and agreed to the business's SLA. SLA contracts will include the following: an agreement summary with definitions, SLA measurements, and metrics used, goals of the business and users, for example, what needs does the user have that the business can provide, consequences of violations, like financial penalties or incentives, so the business and the customer can continue to work together, and point of contact, so customers know who is involved, what their roles are, and the escalation of issues. There are 3 types of SLAs: customer-based SLAs, which are customized for different customers. Service-based SLAs are for groups of customers who use a service the same. Every customer receives the same service. And multiple SLAs for different types of customers, like premium or VIP, allow for variation within the SLA to meet different needs for different parts of a business. But how are SLAs and priority levels interconnected? SLA priority levels can be adjusted based on the impact that the issue has on the business. The higher the impact is on the business, then the more urgent the priority is. In the example shown here, Level 1 has a high priority and high impact. The issue has most likely resulted in stopping business. Level 2 means the business has been disrupted. Level 3 priority indicates that maybe the issue is an inconvenience for customers, but it doesn't stop the business from operating. And Level 4 is the lowest priority level in this example. It might represent routine services like updates or changes. SLAs will also include details about how long support has to respond to issues and resolve issues. Response times are how long technical support teams have to acknowledge and start work on an issue. For example, a low priority issue may have a response goal of 2 business days. However, an urgent issue that extensively impacts business may have an immediate response goal. Resolution SLAs state how long the team has to resolve the issue from start to finish. Resolution SLAs might also have priority levels, but the time to resolve the issue may be different from response SLAs. Whatever your role is in technical support, you will most likely be using some form of ticketing system to manage SLAs. Ticketing systems will help you track, monitor, prioritize, automate, and report on SLAs for your organization. In this video, you learned that ticketing systems help you and your organization manage SLAs. SLAs are legal agreements between businesses and their customers that ensure quality, timeliness, and availability of technical support. SLAs identify priority levels depending on the urgency of issues and establish response and resolution times. And finally, 3 types of SLAs are customer-based, service-based, and multiple SLAs, which can be a combination of customer and service-based SLAs. Service level agreements, or SLAs, are undeniably a huge part of technical support. What are SLAs? Why are meeting these contractual obligations important to the success of a tech support professional?
So another important tip is that you should always implement SLA or service level agreements. So most of today's ticketing software system comes equipped with service level agreements, tracking and management capabilities. SLAs lay out an agreement between you and your customers. This function defines a response and resolution times customer can expect. Moreover, it helps agent to deliver service targets. Setting SLAs ensures that your customer service team answers each ticket request, therefore handled within a reasonable time frame so customer never wait for too long.
The SLAs are important because not only they set an expectation for the customer on when they can expect a response or an issue to be addressed on, but also it helps the support team prioritize their workload and resources.
So a service level agreement is sort of an agreement with typically with contract stuff, but basically it's that you are going to, it's with like a ticketing system. So people will report that they have an issue, they create a ticket, it goes to you. Now there's different categories. There's low, medium, and high priority. Typically the higher priority means you will have to answer and respond to the issue within a certain amount of time. And so lower tier will end up having a much higher opening. So it'd be like 6 hours versus 15 minutes of both response time and sometimes fixing the entire issue.
There was a time when I was working in tech support where our level 1 team was short-staffed, and there was a risk that we might not meet our severity 1 SLA of response within 1 hour. So several of us from level 2 were asked to help out and go onto the help desk to help address any urgent issues, severity 1 issues that might be coming in.
Welcome to the escalation matrix. After watching this video, you will be able to identify escalation and its types, discuss the escalation matrix, and describe handoffs and their importance. Imagine you just received your new printer and you're excited to try it out, but it isn't connecting to your computer. You need help, so you immediately contact the company's technical support line. After trying a few things and not resolving the issue, support tells you they will need to escalate your case. But what does that mean? An escalation in technical support is when the first support person you contact is unable to offer an answer or solution to the problem. You must be transferred to the next point of contact in support. When an issue is escalated, it moves through the levels of support until it reaches resolution. So why do companies need escalation? Escalation is an effective method of building trust and support for an organization. It allows better communication between the organization and its customers. Escalation improves businesses because issues and problems can be identified and fixed. And escalation boosts customer satisfaction when an organization supports its products. Now, whether the escalation process goes through a service desk, through product engineers, or automatically through a tracking system, there are typically 3 paths escalation policies follow: functional escalation, hierarchical escalation, and automatic escalation. Functional escalation is when an issue is escalated to a team or person with the skills and knowledge to resolve the issue, not the person with the most seniority. For example, the first person to respond to the issue may be a senior developer from one team who isn't familiar with the problem. The incident then gets escalated to a junior developer on another team who has more knowledge of the issue. Through the functional escalation process, the issue gets identified and corrected more quickly. The second path is hierarchical escalation. When an issue does not have a clear path to resolution, support may escalate the issue until the customer is satisfied with the resolution, even if it's not the outcome they wanted. The issue is escalated through the support hierarchy. For example, the issue might start with a service desk technician, then be escalated to the team lead or manager, and then is escalated to a supervisor or a specialist. And the final path is automatic escalation. Ticketing systems can automatically escalate an incident. If, after the issue has been submitted, the primary on-call person doesn't respond in time to the ticket, or another similar issue occurs, the issue is automatically escalated to another level of support, like another person in support, or even a chatbot. So, what is an escalation matrix? An escalation matrix is made up of a series of increasing levels based on severity and priority. It includes whom to contact based on the specific problem the customer is experiencing. What an escalation matrix looks like and how it's used varies depending on the company. This is an example of one type. Typically, the escalation matrix will include contact information for support and what the contact's role is. It also states the timing of when issues should be escalated to the next level. Sometimes the technical support person you were talking to transfers you to someone else to resolve your issue. This is called a handoff. Handoffs are important because they help support teams resolve an issue. Additionally, they encourage support teams to share knowledge with each other. They prevent incomplete documentation about problems and fixes, and handoffs can lead to faster and more satisfactory resolution of issues. Okay, back to that scenario with your new printer. You've turned it on and off and checked all the cables, but it still isn't connecting to your computer, so you contact technical support. A first-level representative walks you through basic troubleshooting steps with no resolution. Your issue is escalated to a Level 2 technician who is more familiar with your printer. After more troubleshooting, the Level 2 technician mentions a possible software issue. The Level 2 technician hands off your issue to a Level 3 software engineer. You answer a few questions, and the software engineer suggests, of course, a software fix. And the fix is a success, and finally your printer is working properly. So, using the escalation matrix, technical support has resolved the problem. In this video, you learned that an escalation in technical support is when one support person is unable to offer an answer or solution to the problem and transfers the issue to a higher level for support. 3 paths followed by escalation policies are functional, hierarchical, and automatic escalation. An escalation matrix is made up of a series of increasing levels of support based on severity and priority. And a handoff is when one support person transfers an issue to another person to resolve the issue. Welcome to What Are Ticketing Systems? After watching this video, you will be able to indicate what a ticketing system is and what it's used for, describe how ticketing systems work, and identify the use of ticketing systems by IT professionals. A support ticket is an electronic document used to record the interaction between a customer and a service representative. It contains a record of communications and resolution efforts for a particular problem and is useful to manage issues, questions, requests, and problems your customers might have. A ticket may also be referred to using terms like issue, case, or incident. A support ticket is managed using a ticketing system. These systems may also be called help desk software, customer support software, ticketing software or app, and case management system or customer care management system. What is a ticketing system? A ticketing system is software used to systematically document, track, manage, and resolve customer issues. Functionally, a ticketing system facilitates the creation of tickets, allowing support agents to manage, collaborate, and coordinate resolution efforts. A ticketing system contains a central data hub designed to streamline communications between agents, team members, and customers. Most ticketing systems, in addition to basic ticket management, also provide the following capabilities. Some automation, for example, the routing of a web ticket to an appropriate resource. Collaboration, allowing all agents and resources to freely access information to increase efficiency. Easy integration with other or future IT management processes and applications. Multiple channels of customer access, such as by telephone or online forms. And reporting system performance of metrics, such as response time, volume, and customer satisfaction. Here is a typical life cycle of a ticket. The ticket is created when a customer walks in, calls an agent, enters relevant information in an online form, sends an email to a customer support email address, or posts on social media. The ticket is assigned to a customer support agent, or a queue, monitored by multiple agents. This agent categorizes the ticket and assesses priority and severity. The ticket is resolved by the resource, which may include validation, requests for further information, or escalation. And finally, once the issue is resolved, the ticket is closed by the agent or customer. However, if needed, the ticket can always be reopened. Tickets can be created from the customer online or using an app, as shown here, the customer's use of a text session, such as an SMS or email to contact the support agent, or a link in social media to contact the support agent. Initially, tickets contain basic information, such as the customer's name, the date of the request, the email address used to contact the customer, the category of the problem, and a brief description of the issue. Also, maybe some additional relevant details, such as a model number. The ticketing system may automatically assign a ticket to a specific agent based on some business rules or logic, like the time of day, who the customer is, problem category, agent availability, etc., or may be placed in a queue from which available agents can pick a ticket and assign it to themselves. In some cases, a supervisor may assign the tickets in a queue to specific agents manually. As the agent receiving the request, you open the ticket. Note that if an online source is used, the provided information automatically appears in the ticket. In the case of a phone call, you would obtain and enter this information yourself. Also note that each ticket will be assigned a ticket number. This number will identify this ticket through its life cycle. The agent working on the ticket communicates with the customer to resolve the issue. When reviewing the information provided, you, in some cases, may be allowed to reassign or forward it to a specialist or to a more appropriate queue. As part of this process, you may require additional details to troubleshoot the issue. For example, you may get into a live chat session with the customer. You verify the issue and instruct the customer how to resolve the problem. Once the issue is resolved, you close the ticket and change the status in the system. In this video, you learned that a ticketing system is software used to systematically manage and resolve customer issues. The life cycle of a ticket includes ticket creation, assigning and starting the ticket issue, resolving the ticket issue, and closing the ticket. And IT support agents create tickets, start the ticket process, and resolve issues using a variety of communication methods. Welcome to Insider's Viewpoints, Handling Difficult Situations. In this video, you will hear a technical support professional describe a real-world difficult situation and what strategies she uses to approach the problem.
Hi, my name is Michelle and I'm an instructional designer for SkillUp Technologies. But prior to joining SkillUp, I spent over 20 years of my career working as a Tier 3 technical support engineer for various different companies. So I became an expert at handling difficult situations and difficult customers alike, ranging from home users using retail products all the way up to Fortune 500 and Global 1000 customers too. So I'm here to share with you today a real-world example of a case I handled while working at one of my previous employers. We had an enterprise-level customer purchase several dozen very expensive enterprise-class products for use in his organization. However, after a period of time, they began failing one by one until eventually they all failed. So our customer reached out to us and filed a support ticket for technical assistance. However, due to various reasons, that ticket remained in a queue untouched for over 7 months. Now, during that 7 months, his organization experienced weeks of downtime. And they also had to go out and purchase several dozen more very expensive enterprise class products from one of our competitors to get their division operational again. So our inability or our failure to handle his case correctly resulted in a significant financial loss for his company. And he wanted to know what we plan to do about it. So not only was it a very difficult situation, it was also a very delicate one, and one that required me to walk a very fine line to try to get it resolved, which ultimately I did. So sometimes folks ask me, Michelle, how do you remain calm in situations like these? And how do you calm a customer down when they're calling you and they're very upset? So not much, really. I take a deep breath and I try not to let the situation impact my senses or my emotions. I try not to get caught up in the moment emotionally along with the customer, and that helps keep things calm. I know that angry customers aren't mad at me personally, so I try not to take things, personally ever. They're mad at what happened to them. They're mad at the situation, and they want somebody to help them to get it resolved. And, further to that, they may be experiencing additional pressure coming at them from, their daily lives, or perhaps it's pressure coming from upper management and breathing down this person's neck, regarding the case for which they're calling you about, right? So when I try to diffuse a situation like this, the first thing I do is let the customer speak. No matter how well versed I am with the history of the case, I let the customer get everything off their chest, because I have learned to realize that this is the first step in calming down the customer. Right? I speak in a very calm and reassuring and very respectful tone, using affirmations to let that customer know that I am paying attention and that I am listening to everything that they have to say. Right? And I think the second most important thing for de-escalating or diffusing an issue like this is gaining the customer's trust. If you can gain their trust and instill in them the confidence that you're the one that's ultimately going to resolve their issue, that is very helpful towards de-escalation and getting the case moving in a forward direction. You may not be able to resolve the issue, in terms of fixing things that are broken, but you may be able to take a very negative situation and turn it around so it will have a positive outcome. Okay? Some folks ask me, how do I get in the right mindset for handling difficult situations? So I always ask myself two questions. The first one is, does the customer have a legitimate reason for being this angry towards me? And so, if the answer is yes, then what that does is it raises my level of empathy towards the customer, which they can hear in my voice, which helps de-escalate the situation. And the second thing that I do to prepare is I ask myself, is the customer being unrealistic in the amount of anger that they're, displaying in this particular call? Because the truth about working in technical support is there are customers that will do that. They know that if they yell in the right ears for the right amount of time, they may walk away with something free or an appeasement item. And then, by the same token, sometimes you get folks who are just abusive. That's their nature, that's their personality, and no matter what you do, they're going to hang up that phone just as angry as they were when they called you in the first place. So let me leave you with some final tips if you're considering a career in technical support. And firstly, that's to remember that a difficult call is not the end of the world, whether you had a hand in it or not. If you've done the best that you can, you've done a good job. You've done all you can do, and the only thing that you can do is get through it, the best that you can. And also remember that difficult situations don't last forever, and that they can also be a very valuable learning experience, as it was for our company. Accept the fact that difficult situations and difficult customers come with the territory. It's part of working in the technical support industry. And finally, remember that time and experience will give you all the skills that you need to be able to successfully handle difficult situations and difficult customers, just like it has for me. So I wish you all the best in your career as a technical support engineer, and I hope that this information was helpful to you. Thank you.
Welcome to Features and Benefits of Ticketing Systems. After watching this video, you will be able to define common features of ticketing systems, describe how tickets are tagged and routed, and describe how automation is critical in a ticketing system. Comprehensive IT ticketing tools can include a number of features. Common features of ticketing systems include omni-channel support, the ability to generate tickets from different channels, ticket routing, the ability to assign tickets to agents or departments, ticket categorization and tagging, where the ticket can be classified and sorted by issue to enable routing to a particular specialist, tracking and management, where the ticket contains a processing trail, knowledge base management, where issues solved in past tickets can be used as a resource for addressing similar new tickets, and automation, the ability of the system to automatically perform tasks like route tickets, send emails, or create alerts. Customers can contact your help desk organization from many channels: email, social media, live chat, and phone. Many times, the resolution of a ticket can involve more than one channel, so consolidation of these communications in one place is important. This preserves issue specifics, customer conversations, and customer profiles in one ticket document. Requests can come from different sources and are collected in the ticketing system. John has a problem with a network setting. John calls and talks with the support agent who creates the ticket. Sarah emails customer support with a printer issue. A support agent receives the request and enters it into the ticketing system. And Marvin texts with a problem downloading software. A support agent receives the message and collects specific information about the problem. All these requests are consolidated into a common dashboard where agents can collaborate with team members all in one place. A ticketing system has specific capabilities to manage the lifecycle of the ticket. Tickets can be categorized based on date, ticket type, customer, and issue specifics. Tickets are then tagged with this information. This becomes part of the ticket and may trigger automatic processes such as routing and customer communication. Based on categorization, tickets are then routed to the appropriate agent. For example, if one agent is more knowledgeable about IBM authoring, the ticket is routed to that person. But if the agent that first receives the ticket can resolve the issue, they work to do so. As the ticket is worked, all customer and internal communication and other notes about the process resolution are captured by the ticket system. This will provide information about ticket status, which can be reviewed by agents or rolled up into a daily report. A well-organized ticket system can help provide good customer service by resolving issues quickly with minimum customer back and forth. As a ticket contains information about its management through the system, tracking the history of the ticket is as easy as looking at the ticket itself. A key for constant system improvement relies on analytics. The ticketing system provides analytics for the organization to see how the tickets are spread out, for example, by alert level, by ticket status, or by the group requesting the help desk support. With the ability to aggregate and report ticket information, you can also investigate what works and areas of improvement in process improvement, performance metrics, and resource management. Many customers are fully capable of serving themselves and may prefer to do so if that option is available to them. A knowledge-based system allows customers and agents to research issues. Knowledge-based systems help customers by summarizing and storing large amounts of information in searchable linked databases. Knowledge bases can also assist agents to find resources for customers. And knowledge bases require updates to keep content relevant. Knowledge base access can include questions to agents through messaging or chat, searching for answers to common questions without direct agent support, discussion groups for specific products or process types, and product documentation and demonstrations. Automation is a critical part of a ticketing system. It helps tickets get to the right person at the right time. The logistics of managing tickets can get complicated quickly. Automation can help in assigning tickets, sending responses to customers and team members, escalating issues based on severity, and pulling customer data to address specific needs. Automation reduces time spent on repetitive tasks and menial work, making agents more engaged and productive. In this video, you learned that common features of help desk ticketing systems include omni-channel support, ticket routing, tagging, and automation. Ticketing systems' knowledge bases contain large amounts of information and can be accessed by customers or help desk agents during issue resolution. And automation can manage ticket flow and reduce time spent on repetitive tasks. Welcome to Popular Ticketing Systems. After watching this video, you will be able to indicate what to look for in a ticketing system, describe types of ticketing systems, and list popular ticketing systems. What should companies look for in a ticketing system? The system should be straightforward to use to make the most of an agent's time, enrich the quality of customer interactions by providing customer information and history in the system, be available to provide reportable metrics you can use to evaluate customer service performance, provide tools for agents and managers to identify repeated problematic issues, and enable and foster internal team collaboration. Hosting types of ticketing systems include cloud-based systems, which are hosted on a vendor server, and self-hosted systems, which is licensed software that runs on your company's server. Licensing types include open source systems, which are basic code that is easily modified by your developers, and enterprise systems, which are generally used by large companies and offer many advanced features. Cloud-based systems are hosted on a vendor server, and the benefits are setting up and maintaining the system is easy as the vendor does most of the work. They are highly scalable, the vendor handles the required growth. And cloud-based systems are also available to anyone connected to the internet. Concerns about cloud-based systems include the following. You must rely on the vendor to address malfunctions or bugs. An internet connection is always required, and customization is limited and must be performed by the vendor. A self-hosted system is licensed software that runs on your company's server. The benefits include complete control of data and security, and in running your own instance of the software, it can be more flexible to meet business needs. The concerns include the initial investment in servers, infrastructure, and developers. Server maintenance is also an in-house cost. Your company's developers must perform system updates and fixes, and your company must back up the system. Open source systems are basic code that is easily modified by your company's developers. Their benefits include the cost of the software is free or mostly free, access to the code base makes it more customizable for your needs, and open source software often has a sizable developer community. The concerns include your company's developers need to be knowledgeable about setting up and maintaining the software. The timeline for initial development and rollout can be extended, and your company has total responsibility for updating and maintaining the system. Enterprise systems are the big guns used by large companies and offer managing system assets and advanced reporting capabilities, 24-hour availability of vendor support for your company or your customers, and a high level of customization by the vendor to meet the needs of larger enterprises. The concerns include cost. These systems can be very expensive, and a more capable system is necessarily more complex and may require additional operator training. Okay, now you will learn about 5 popular ticketing systems: Zendesk, Jira Service Desk, Freshdesk, LiveAgent, and ServiceNow. There are many other ticketing systems available, and the company you work for might be using a different one. Each of these products have common features meeting the basic requirements for a ticketing system. Omni-channel support, the ability to field requests from email, live chat, and call center agents. A degree of automation, including capturing, logging, and initial routing of incoming requests. a basic set of collaboration tools enabling support agents to work together, a basic knowledge base capability available to agents and customers. Each vendor charges monthly based on number of service agent users and product features, and all systems offer a free trial with limited use. Zendesk is a cloud-based ticketing system with pre-built integrations for a large number of popular apps, internal and external collaboration tools you expect, a knowledge base with self-service portal, interfaces for WhatsApp, Facebook Messenger, Twitter, live chat, or email, creation of macros for responses to basic tasks, and Zendesk pricing is highest among those reviewed here. Jira Service Desk is available as a cloud or self-hosted solution. It is built on the Jira workflow engine. It is expandable by purchasing add-ins or upgraded service levels. A Confluence account is required to create a knowledge base. Chat is limited to a few business-oriented apps like Slack or Teams. Complex automations are available, including sending events to third-party applications by using webhooks. And the core Jira Service Desk per user pricing is the lowest of systems reviewed here. Next, Freshdesk is an AWS cloud-based ticketing system with customizable ticket views, enhanced tracking time of agent interactions and ticket completion, AI-powered chatbots to offer relevant resolutions to service agents and customers, a training solution for system users called Freshworks Academy, and Freshdesk is moderately priced. Live Agent is a cloud-based ticketing system that emphasizes live chat along with traditional call center and email capabilities, includes integration with more than 200 applications including email, Facebook, WordPress, Jira, Twitter, and Slack, has a chat widget that can be embedded in any web page, includes the creation of unlimited email addresses, and is moderately priced. And finally, ServiceNow provides a comprehensive IT and workflow automation management platform, which includes a cloud-based ticketing system. ServiceNow embraces the IT service management or ITSM philosophy that IT should be delivered as an efficient service providing a higher value for customers. It focuses on custom, repeatable workflows for simple to complex tasks. ServiceNow is also an integrated system featuring change and release management, service level management, request management, and systems configuration management. ServiceNow includes custom apps for mobile devices integrated directly into the system, and the cost of ServiceNow is based on configuration. In this video, you learned that the criteria for choosing a ticketing system includes one that promotes agent productivity, customer interactivity, metrics, reporting, and collaboration. Ticketing systems can be cloud-based, self-hosted, open source, and enterprise. And popular ticketing systems include Zendesk, Jira Service Desk, Freshdesk, Live Agent, and ServiceNow, but there are many others available. Ticketing systems are the heart of a tech support organization. Why are they so important? And what ticketing systems are commercially available?
I come across numerous ticketing systems, and they might be called by different names by different companies or in different organizations. They might be called help desk systems, they might be called incident response systems, etc. But they play a very similar role, pretty much all of them. In that respect, I've used custom-built ticketing systems, in-house ticketing systems, as well as off-the-shelf software and cloud-based or service-based ticketing systems. So including Zendesk, ServiceNow. I've used open-source ticketing systems such as OS Ticket. I've used User Voice, and several others.
So in my experience, I have worked in multiple ticketing softwares or platforms. in my past experience. So few of them are like ServiceNow, Sherwell, Sapphire, Summit, etc.
So each company has a different ticketing software for the most part. Everyone kind of just picks their own. Sometimes they'll have their own developed and created for their business purposes. The majority of it comes down to, do they have one that's web-based or as a program itself? Then the other part is, do they have a knowledge base connected to it at all, so where you can easily search for issues or whatnot?
But few companies also prefer to have their own custom built ticketing software to meet their exceptional business needs. Ticketing systems play a vital role in tech support ecosystem, as it helps determining type and number of issues, tickets history, real-time tracking of service requests with their priorities set, agent performance, and most important thing, which is maintaining SLAs.
What are best practices for using ticketing systems? And what are some ways or methods you use to help you manage ticketing systems more effectively?
For me, the best practice is always to get the user's name, write down exactly what the issue is, and then verifying that that's what is the issue. And then from there, it's making sure to get all the relevant information for details beyond just how you fix and stuff, the stuff that you've tried and failed to do, and then along with the information on the actual computer and software, like software version, OS version, things like that. Is it even a Mac or a Windows computer? And the big thing that comes down to is making sure you detail everything in the ticket itself, what the issue was, what you saw, and how to fix it. If you can make it step by step, that's great. But basically, it makes it able for many of the past cases and stuff like that to look up what had happened or search for something related to what other people have had with that issue and how that tech fixed it. And so that way you can proceed with making it much easier. Whereas if you can't search for stuff like that, it makes it much harder. And it's like, oh, has someone dealt with this before or not?
Ticketing systems can vary from one to the other. So it's really important that whichever ticketing system that your organization wants you to work on, that you get the right training for it, get familiar with the various features within that ticketing system, and learn about tips and tricks. Talk to some of the other agents in your organization to see how they're using, what kinds of best practices that they've established or tricks that they've learned over time. So any software that you end up using, make sure you become intimately familiar with its various features and capabilities.
Welcome to Introduction to Troubleshooting. After watching this video, you will be able to define troubleshooting, list the steps in the CompTIA troubleshooting model, and explain the CompTIA troubleshooting model. Troubleshooting is a systematic approach to problem solving that is often used to find and correct issues with computers. Troubleshooting is a significant part of an IT tech support professional's work. The industry standard troubleshooting model comes from the Computing Technology Industry Association, or CompTIA. Let's look at the process and some specifics applicable to the IT support specialist. The CompTIA model includes the following steps. Identify the problem. In this step, you research the knowledge base, or internet, if applicable. Establish a theory of probable cause. In this step, you test the theory to determine the cause. Once the theory is confirmed, determine the next steps to resolve the problem, and if the theory is not confirmed, establish a new theory or escalate the problem. Establish a plan of action to resolve the problem and identify potential effects. Implement the solution or escalate as necessary. Verify full system functionality and, if applicable, implement preventative measures. And finally, document findings or lessons learned as well as actions and outcomes. Let's look at these steps in more detail. In the first step, you identify the problem. Start by gathering information. This may come from a telephone call, a ticket submitted online, or other sources. Next, contact and question the user who submitted the issue. Try to understand what is happening, including hardware, software, and system settings involved, and what the user was doing when the issue occurred. Based on the information collected, clearly try to identify the symptoms. Let's say in this scenario, the user sees an access denied message when trying to print on a network printer. Determine if anything else has changed. For example, are all servers up and running? Have any servers been updated recently? Does the user's account allow access to that printer? If an answer is not immediately apparent, try to duplicate the problem. If there are multiple issues, it is good practice to address each problem individually. For example, if the user also reports his monitor is also too dim, approach that separately from the printer issue. If the problem is not yet solved, it is time to do some research. If your company has maintained a knowledge base, search that for similar issues that have been resolved before. An internet search may also provide useful information. So, based on the information you have collected and your research, establish a theory of probable cause. One important starting strategy may be to question the obvious. For example, is the printer plugged in and turned on? Also, consider more than one approach. For example, could this be a user machine configuration problem, or is this a network issue? Next, test your theory to determine the cause. You may work with the user to verify the computer is appropriately configured, or review network accounts and policies to see if the issue can be found there. Did you solve the problem? Sometimes the answer is not obvious and may require more research and testing. If you discover the root cause of the issue is complex or systemic, establish a plan of action. Keep in mind that some fixes may require reboots or downtime, or require downloading software or patches. Perform testing in a staging environment if available. There may be change management processes in your IT department to perform tests. Back up any data that may be affected by the change, and remember, any systems changes may require approval by other IT staff members. The next step is to implement the solution or escalate the issue. This may involve running scripts to correct a programmatic issue. The solution may require updating systems or software. The answer may also involve updating configuration files, or a change in firewall settings may be required. After implementing a fix, verify full system functionality and implement preventative measures as appropriate. Often, users are more knowledgeable about how their systems are supposed to work. Consider asking users to test the functionality of the fix. Also, consider if the solution may also need to be applied to other servers or devices. An important part of the problem resolution process is to document your findings, lessons learned, actions taken, and outcomes of the changes. Be sure to fully document your research, theories, changes, and updates. If you have a knowledge base, add this information so other support professionals can reference it in the future. Documentation is particularly useful if the solution later causes unintended consequences. In this video, you learned that the Computing Technology Industry Association, or CompTIA, has the industry standard troubleshooting model. The CompTIA model involves identifying and researching the problem, establishing and testing a theory, planning, implementing and verifying a solution, and documenting the process and results. And finally, CompTIA troubleshooting steps are useful to tech support professionals to solve problems for their customers. Welcome to ITSM Methodologies and Frameworks. After watching this video, you will be able to define IT Service Management or ITSM, identify ITSM frameworks and standards, and discuss the benefits of ITSM frameworks. What is ITSM? ITSM, or Information Technology IT Service Management, includes all of the processes, activities, technologies, and people that are part of an organization. ITSM is the strategy that organizations use to manage IT services for their clients. IT services can include things like your computer, the programs and applications installed on it, and technical support for these services. Organizations can use ITSM to structure how to deliver IT as a service and to increase their productivity and performance. ITSM includes the tools to manage IT services, which allow control and oversight of an organization's IT infrastructure. A successful ITM strategy adds structure and value to IT. To implement these best practices and standards of ITSM, organizations often use predefined frameworks. ITSM frameworks are guides with a formalized structure of standards, processes, and best practices. Popular ITSM frameworks for many businesses include these common elements. Strategy, which includes assessing and planning services for an organization. Design, including creating and structuring IT services. Management, which is implementing the management of projects, knowledge, and assets. Operation, which includes managing issues and problems with services. And improvement, which involves continuously reviewing and evaluating of services and processes. Some important frameworks include ITIL or ITIL, COBIT, LEANIT, MOF or MOF, and ISO IEC 20000. And these can work together to set IT service standards and optimize business effectiveness. ITIL, or the Information Technology Infrastructure Library, is a standardized set of detailed processes and practices for IT activities that focuses on aligning IT services with business objectives. ITIL stages include service strategy, which focuses on the service lifecycle, like how to design, develop, and implement ITSM. Service design, which focuses on designing services and processes. Service transition, which focuses on how to balance new or changing services. Service operation, which focuses on ensuring services are running smoothly and reliably. And continual service improvement, which focuses on the continuous, iterative, agile process of product and service improvement. COBIT is a framework for governance and management of IT, and the framework focuses on aligning business goals to IT processes. It does not provide a map for best practices for implementation of IT or information security, but it is a framework using the processes contained in ITIL and other frameworks. Lean IT is an extension to IT that establishes a framework for applying lean manufacturing principles to developing and managing IT products and services. It is designed to cut out excess or waste, such as poor technical support that doesn't add value to a business. MOF, Microsoft Operations Framework, also known as MOF, provides a series of best practices guides for IT to establish reliable and cost-effective services. MOF provides guidance for the IT lifecycle structured this way: the plan phase, deliver phase, operate phase, and manage layer. ISO IEC 20000 is an international standard for IT service management systems, or SMS, and it sets guidelines for service providers for how to establish, implement, operate, and maintain an IT service management system. Common ITSM metrics that organizations measure are customer satisfaction, or CSAT scores, first contact resolution, first level resolution, cost per ticket, and mean time to resolution. The benefits of ITSM processes for IT services are assurance of consistency in IT services, simplified processes and efficiency, better incident management, reduced risk and downtime, lower operational costs, and greater standardization and accountability. These benefit organizations by reducing IT costs, improving the quality of service and customer satisfaction, increasing an organization's competitive advantage, and allowing more agility for new IT services. So, why should you learn about ITSM methodologies? In technical support, you and your team are a critical part of ITSM. Services and support that technical support provides are based on ITSM processes. Your success in technical support depends on a well-organized standard for managing IT services. IT solutions and knowledge is a main part of the technical support roles. And the feedback technical support professionals provide to an organization is an important part of the Agile process. In this video, you learned that ITSM, or IT Service Management, is the strategy including processes, technologies, and people that organizations need to deliver IT services to their clients. To implement best practices and standards of ITSM, organizations often use predefined frameworks. And the benefits of ITSM include assurance of consistency, lower operational costs, and greater accountability in IT services. In this video, technical support professionals will discuss emerging trends in technical support. How long have you been working, or did you work in technical support? And what has changed since you started working in technical support?
So I've worked in tech support, I'd say, for about 8 years now. I started out working just for like typical Subway, and I worked from then on. And that's not including any of my like volunteer sort of stuff where that kind of not work sense. But basically from there, I've noticed that technology always changes. So there's always something new to learn and progress. With that in mind, one of the big things I've noticed is people have been moving more to, how do I describe it? Office 360 based for a majority of stuff. And so like the Exchange server is moving to the cloud. Everything in general is moving to the cloud with Office 365 or other products. And so it's more of a, what is it called? Product as a service type thing. And so it's all very heavily online. So it gives you can change the products as you want, but it's something new to learn, and it's very similar, but still different.
I worked in technical support role for a little over 2.5 years, and this was almost 20 years ago. I think technical support has evolved significantly in the last couple of decades. Some of the things have remained the same in that there are ticketing systems and that there are agents. What primarily used to be phone-based support or ticket-based support, there are a lot more channels now. It's becoming a more omni-channel support, using email, using social media, using chatbots and other automated support mechanisms. I think in a way, technical support has become harder because the customer who you're talking to, they can Google an answer probably quicker than you can. So you need to be on top of your game. You need to have the right skills.
I've been involved in technical support in one way or another since 1981, believe it or not. By far the greatest improvement is the ability to either screen share or remote into a client's workstation. Today, with more focus on security, it's sometimes difficult or even not allowed to do that.
Welcome to Effective Documentation and Communication. After watching this video, you will be able to define effective documentation and communication for technical support, identify documentation and communication best practices, and discuss the benefits of effective documentation and communication. Many IT professionals agree that in order to succeed in technical support, you need to have an interest in technology. If you have a curious mind and are willing to seek solutions to technical problems, you'll do well in IT. However, your success also depends on your ability to write clearly and effectively. You must be able to communicate technical information clearly with clients and with your team. Effective communication in technical support is informative communication. In your IT role, you will expect clear information from customers and clients about what the problem or issue is. More detailed and relevant explanations will enable you to resolve problems more quickly. Imagine this scenario. You've just received a support ticket from a client through email. The subject line says, "Printer issue, help." You open the ticket to see that the client has not provided any further details. They only tell you that the printer isn't working. Where do you start with a ticket like this? You can start by asking the client questions. This will involve several emails and going back and forth between you and the client until you finally obtain the information you need to work on the issue. If the client doesn't communicate enough information from the start, you will take longer to resolve issues. Now imagine this scenario. You've received an email from a client with a subject line that says, "Printer not connecting to Wi-Fi." You open the email and it provides more details about the printer, what steps the client has taken before contacting you, and other relevant information. Because the client has communicated detailed information to you in one email, you're able to quickly run through the troubleshooting steps to help identify the issue for the client. Email is just one way that you will be communicating with others to resolve issues. Ticketing systems and direct messaging could also be involved. Other communication tools include online collaboration software like Google Docs and Sheets, Slack, and Microsoft 365 and Teams. These online collaboration tools allow you to create, use, and update documents with your teams and clients. But be aware that the tools only enable communication, they don't write for you. You must be able to explain in writing your technical knowledge. Even technical support roles that require you to talk over the phone or in voice chat will also require you to document your conversation. Another part of technical support is keeping notes and documentation for yourself, which means you might encounter an issue with a client that you've resolved before, and you can return to your notes and repeat the process that worked to resolve the issue quickly. You could use Notepad or other notes apps, word processing apps like Google Docs, and spreadsheets like Microsoft Excel. Remember that you'll always need to keep your audience in mind. Are you writing for yourself, or are you writing for your supervisor? Are you communicating with a client, or are you escalating an issue to someone with less technical knowledge than you? Decide what and how much information is essential to share so your audience may better understand your findings. But what if you aren't able to resolve an issue for the client? You would need to escalate the issue. Now it's your turn to communicate clearly with your team about the issue. Documenting what the problem is and what steps you have taken is crucial for the next level of support. One way to document your steps for the next level of support is to list the order of what you have tried. You can state it chronologically. For example, saying, "First we tried reinstalling the printer, and then we tried updating the driver." Another option is to list steps in order of most important to least important. It doesn't matter as long as you have a clear, consistent order. Another method of documentation includes an analysis of the problem, which includes the following. State your understanding of the problem and why it's happening. If you don't know, you can state what you know the problem is not. By thinking through the problem and working towards a solution, you are making progress with the issue even if you're not solving the problem. You should also include what actions led to the issue. And you can include what might have worked for clients in the past, but didn't work for this client. Another way to document is by listing the essential details. For the other two methods, you included details, but these details might be more technical. You might not have a set order or an analysis of the issue. The details might be simple, and you could use a list. Also, remember that your notes might include all of these methods, and maybe some other ones too. The good news is that you don't have to be the best writer to succeed in technical support. Remember to keep it simple, ask clear questions, and model your writing from others who have proven to be successful communicators. In this video, you learned that you should use simple, clear, and proven methods of communication and documentation in technical support. Effective communication is informative communication, and it allows you to understand issues and resolve them more quickly. Clearly explaining problems and documenting issues enables faster resolution for you and clients. And finally, documentation can include ordered steps to resolution, an analysis of the problem, detailed lists of issues, or other various methods. Welcome to a day in the life of an IT support technician. After watching this video, you will be able to describe the daily tasks an IT support technician may perform, describe how an IT support technician may receive requests, and identify the use of ticketing systems by IT professionals. This is Letitia, a Level 2 IT support technician working for Lone Star IT Services. She works to support internal customers with their day-to-day problems. Let's see what Letitia does during a typical day. Letitia starts each morning with a cup of tea and reviews the condition of all equipment and hardware. This includes making sure all managed client networks and servers are running smoothly and that all overnight backups have successfully run. Earlier this morning, a gateway server went down. Letitia needs to address this immediately, so she corrects the problem and runs a backup. Now Letitia's day really starts. She checks new tickets and reviews any left over from yesterday, looking for red tickets, those of the highest priority. Today, there are none of those, but it's still early in the day. Letitia looks at the remaining open tickets and prioritizes them. There are low, medium, and high priority tickets. One high priority ticket was sent over instant messenger. It seems a router in another building has stopped working. Letitia calls Samuel, who sent the ticket, and gets more information, then logs into the managed router, a quick reboot, and all is well. Letitia reviews the remaining tickets and looks for the ones that can be handled quickly, like adding server access for one user and another unable to access a network printer. Server access is easy. Letitia logs onto the server and sets the appropriate permissions. When she closes the ticket, the ticketing system automatically sends an email to the requester indicating access is now available. She then text chats with John, who's having the printer problem, and leads him through the process of removing, then reinstalling the printer through Windows. Now John has access to the printer, and Letitia closes the ticket. She completes a few more easily addressable tickets. It's good to finish a few jobs in the morning. Later, Letitia is working a request for Janice, who is having a printer problem with Slack. Janice sends Letitia a screenshot of the error message. Letitia hasn't seen this before. She does some research and finds a couple of older tickets with details of the same issue. Letitia calls Janice and connects to her computer remotely. She checks some settings and restarts Slack. It is now working correctly and the ticket is closed. Today, Letitia is assigned setting up a new laptop for an external client. She will install Windows and configure it to connect to the client's network. She also installs and configures software as requested. Meanwhile, another ticket comes in about the network router she reset earlier. Samuel reports that it is down again and seems to be running hot. Okay, time to replace the router. Letitia provisions a new router and configures it. She then walks to the other building to replace the one that is broken. She picks up more tea on the way back. Once the afternoon starts, there's often an increase in requests. The phones don't stop ringing, the email inbox starts filling up, and the IM keeps chirping. Letitia receives an email and helps a client install software. The ticket is closed. Next, there's a problem with one Exchange server unable to connect to another. She looks at the settings and does some research. It's still not working. Letitia troubleshoots by changing and testing some settings. She finds the problem, and now they connect. A ticket is assigned to Letitia to create a new user, which she does. Letitia answers a phone call for a user that cannot log in, so she resets the account. And so it goes. At the end of the day, Letitia checks all her assigned tickets, making sure that each has been closed or the status updated. Some need more information from a client, and some will be scheduled for tomorrow. What Letitia does each day requires curiosity and problem solving. And that's okay. She likes to fix things. Now it's time to go home. In this video, you learned that an IT support technician may perform daily tasks including hardware support, software support, and computer maintenance. An IT support technician may receive requests by phone, email, and text. And IT support technicians use ticketing systems to document, research, and solve end-user problems. In this video, technical support professionals will discuss what makes technical support a great career choice. Why was starting your career in technical support the right choice for you? And why might this be the right time for others to start down this path?
Technical support turned out to be a great stepping stone for me into helping me evolve and grow my career to what I am today. It gave me the confidence and skills to deal with people, to work with people, to understand their issues, to communicate better with them. And that helped me a lot in my next job, which was a product management role, and then subsequently a technical evangelism role, and currently in a role around content strategy and growth, where I am a program director for IBM.
Starting my career in technical support was a great idea for me, just because, my curiosity, about how things work, and I'm kind of a little bit geeky and nerdy, and I like gadgetry and things like that. But it afforded me a better quality of life. I made a lot more money, and it opened a lot of doors for me, and helped me better support my family.
So for me, I really love technology. I'm very much the early adopter. If something comes out, even if it's in the beta phase, if it looks interesting and exciting, I'm one of the first people to try it out. I want to get hands-on with new stuff. I like to learn about it all. It's great. On the same regards, I love fixing stuff and helping people. So it's been very natural for me to just get into it. I'm very good at what I do, and so it makes me proud. If you really enjoy technology and troubleshooting stuff, it's a great career. It can be hard at times, but it can also be very fun at times. You'll get really great people that are very sincere when you get to help them, and it's something that always really brightens my day when I do that.
I think that any time is a good time to start a career in technical support, even at the entry level, because over time it's going to expose you to so many other paths that you can take in the IT industry. And it's kind of cool. It's like a try before you buy. I mean, you see what your other colleagues are doing in IT. They may not necessarily be tech support engineers, but you can see what a DBA does, a DB admin, database admin, or, what a system administrator does. And, whether it's, the field that you're in, or, whether it's medicine or healthcare or biotech, everybody needs good technical support engineers. I mean, there are never enough. And you come up with one or two or three possible solutions, and you solve that problem for that customer. Maybe they've been grinding on that problem for a week or 2 weeks or a few days, and, you help them resolve it, and now you're happy, and they can move on to the next thing. There's a really deep satisfaction that a lot of us in this field really get from that job and, from those results, and that's what keeps us working as technical support engineers.
With technical support, you're able to develop the skills to ease into a kind of a technology role that you're interested in. And I think it's also really, there's so many opportunities out there in technical support that the possibilities are endless. So I think it's a great time to be in technical support, regardless of your background, regardless of whether you have a degree or not. And I wish you good luck in your endeavors.
Welcome to Introduction to Hardware and Operating Systems. According to Statista.com research, global IT spending on PCs, tablets, mobile phones, printers, data center systems, enterprise software, and communication systems is expected to total about $4.45 trillion in 2022. Who will install, configure, manage, and program these IT assets? The most recent U.S. Bureau of Labor Statistics report indicates about 667,600 annual job postings and projected job growth of 13% through 2029. At the time of this course publication, the median U.S. IT salary was $112,161, more than double the U.S. median salary of $41,950 for all jobs. An IT role is right for you if you like change and enjoy ongoing learning. Computing technology is always evolving, and there's always new technology or a new feature to learn. If you're balancing work-life commitments, many companies offer on-site work, remote work, hybrid work environments, and flexible shifts. Employers need coverage 24 hours a day and 7 days a week. IT careers offer multiple paths for career growth, and if you enjoy making a positive difference for others, an IT role can be rewarding. When you complete this course, you'll be able to describe and apply operating system fundamentals and identify, classify, and describe computing devices and peripherals, interfaces and connectors, and internal computer components. Then gain job-ready skills and certification-ready insights when you learn about recommended workstation evaluation, setup, and troubleshooting processes and practices. This course is the first in a series of IBM courses intended to help you develop IT fundamental skills and knowledge. In addition to gaining valuable skills in Introduction to Hardware and Operating Systems, this course, along with other IBM IT courses, can also aid in your preparation for the CompTIA IT Fundamentals Certification exam. Especially for beginners, guided instructional videos walk you through key concepts with essential need-to-know facts. Interactive activities reinforce what you've learned in videos. Forums provide connections where you can introduce yourself to others, provide feedback, and get support. Practice assessments help you gauge your knowledge, and graded assessments prove what you've learned, leading to a shareable badge and certificate that you can show prospective employers. We're here to support your success, and we're excited that you're here. Let's get started. Welcome to Introduction to Computing Fundamentals. After watching this video, you will be able to define what a computer is, classify computers based on their size and their uses, list the 4 functions of computing and the parts of a computer associated with those functions, and describe the benefits of computing. A computer is a device or system that includes hardware, operating system software, application software, and peripheral devices. Hardware is the platform that processes data based on the provided instructions and stores data. Software includes the operating system software that enables and configures hardware capabilities, and the application software that enables the computer to perform tasks. Peripheral devices, such as keyboards and monitors, enable user input and output. And finally, computers need users who provide instructions. A fast way to classify computers is by their size and speed. Supercomputers are the fastest computers and are used for the most complex mathematical and analytical computations. Mainframe computers function at the speed of business and are used to perform transactions and more. Next in size and speed are mini-computers, which enable more than one person to access the same data. Finally, the smallest computers are microcomputers. This category includes personal computers, laptops, smartphones, and other single-user devices. Another way to classify computers is by use. General-purpose computers perform functions such as creating documents, saving files, web conferencing, working online, financial analysis, data analytics, coding, and other multifunction capabilities. Even smartphones can be considered general-purpose computers. Special-purpose computers which perform defined limited use functions include IoT devices, such as sensors that report water quality, lights that activate during occupancy, sensors that report building occupancy, and IoT devices that monitor manufacturing processes. Other types of computers include Wi-Fi-enabled appliances, weather stations, alarm systems, and both wired and wireless gaming consoles. Computers perform many tasks, but we can simplify and categorize those tasks into 4 easy-to-remember functions: input, processing, output, and storage. Let's learn more. Input is the function or action of getting data into the computer. Input happens when you type or tap on a keyboard, use a touchscreen, or speak a voice-to-text command. Clicking the send button for an email is also input. Input is also the information and instructions a programmer provides to perform calculations using a set of programs. Next, processing happens when the computer receives the input and then converts the data into a format or action that a user can recognize and use. Examples include downloading an app, document, or photo, and moving data from one drive to another. Processing also occurs when the computer performs programming instructions, such as data calculations or even instructions to fly a rocket to the stratosphere and back. Technically, processing happens when raw data changes into usable formats, such as email, documents, and photos. Processors, also called central processing units or CPUs, are located inside computers on a system board, also called a motherboard. These boards and their processors are usually located centrally within the devices. Next, the computer delivers the processed results to the default or configured output devices, including monitors, speakers, and printers. Output, meaning what you see, hear, or understand, is what makes the data apparent and valuable. At the same time or just after the processing function completes, and while output is happening, computers can use the storage function. Storage is the saving of data to disk space on your computer, an external hard drive, or on network or cloud storage for an indefinite or undefined time, unless you explicitly specify a data expiration date or delete the data. Storage saves data for reuse. Server, desktop, and laptop computer storage is usually located inside of the case and to the side of the case. Storage is often welded onto the system board for phones, IoT, and gaming devices. So, what are the advantages of using computers? Manual entry errors are eliminated by using capabilities such as copy and paste and data duplication to reuse data or content. Communication is sped up by using network, wireless, cellular, and other communication technologies. Exponential and complex computations, such as those used for medical research, civil engineering, and space exploration, are enabled by processors, memory, and programming languages. Computers enable the saving of documents and data to disk storage, eliminating the extra storage space needed for stacks of paper. Businesses thrive on digital data storage, and whether it's medical images, car claims, research records, or family photos, saving digital images provides durable and long-lasting access to that information. Finally, editing capabilities eliminate the time-consuming drudgery of having to erase and rewrite work manually. In this video, you learned that, based on size and speed, supercomputers are the fastest, followed by mainframes, then mini-computers, and finally microcomputers, which include PCs, laptops, smartphones, and others. Computers can perform general functions or specific functions. The 4 functions of computing are input, processing, output, and storage. And the benefits of computing include reducing the number of tasks humans need to do, enhanced data storage, the ability to perform complex mathematical tasks, and faster communications. Welcome to Common Computing Devices and their platforms. After watching this video, you will be able to categorize common computing devices and describe their main features and benefits, and identify frequently used operating platforms associated with these devices. Common computing devices include stationary computing devices, mobile computing devices, and Internet of Things or IoT devices. Stationary devices, which include workstations, servers, and tabletop gaming consoles, remain on a desk or rack or other fixed location. These devices consist of a box that includes processors, memory, and input and output connections that connect to networks, keyboards, monitors, mice, printers, speakers, microphones, webcams, and other devices. In some instances, you can update the device's memory, storage, or video cards. Let's explore workstations. Workstations, used both at the office and at home, are what most people think of when they think about a desktop computer. Also categorized with personal computers, these devices are typically in a box that contains a system board with a processor, memory, storage, and slots for add-on cards for additional functions. Their motherboards have ports that support monitors, keyboards, mice, microphones, printers, speakers, and other devices, as well as onboard cards for wireless connectivity. Many newer devices enable memory, storage, and graphic card upgrades. These devices use Microsoft Windows, Mac OS, and Linux operating systems. Next, servers are generally installed as standalone units or in stacked racks on networks, enabling shared access to media, such as movies, videos, and sound clips and web pages for websites. Servers also manage print requests, enable shared data and document access, store email, and more. On the network, multiple servers can contain the same data, so that if one server fails, users can keep working using the same data from other servers. The ability for work to continue if a shared computing resource is malfunctioning is known as fault tolerance. Server hardware offers robust capabilities that often support multiple processors, memory, graphic cards, storage, and port connections within the same box. Servers use network operating systems geared towards optimizing data distribution. Popular operating system software vendors include Microsoft Windows Server, Linux, Unix, Mac OS X, and FreeBSD. Desktop gaming consoles are also known as tabletop gaming consoles. Gaming console system boards contain processors, memory, graphics processors, storage, input ports, output ports, and a memory controller that exists separately between the other function blocks and the system memory. In times past, many of these functions existed separately as multiple chips on the motherboard, but today these functions exist in a single functional block. Gaming consoles, such as those made by Microsoft, Sony, and Nintendo, are similar to desktop computers but use upgraded memory caching and graphics processing to enable smoother game-playing experiences. Gaming consoles used to require cable connections to monitors and gaming controllers. Today's gaming consoles provide wireless connectivity. Gaming consoles are not usually upgradable. Mobile devices, including laptops, tablets, mobile phones, and portable gaming systems, have transformed how we live, work, and play. Let's first check out laptops. Many laptop computers run versions of Microsoft Windows, Mac OS, and Linux operating systems, while others use Google Chrome's lightweight operating system. Laptop system boards include processors, memory, video cards, ports for connecting to other devices, and Wi-Fi capability. Many laptop manufacturers allow upgrades to storage and memory. Tablet devices are usually less powerful than laptops, but that is beginning to change. Tablets built in very tight cases include most laptop components, but don't include a keyboard. Tablets generally use operating systems such as Microsoft Windows, iOS, and Chrome. The system board includes the device's processor, memory, a video card, sound card, a limited number of ports, a Wi-Fi card, and limited hard drive storage. Tablets are usually not upgradable. Mobile phones include onboard components with specialized processors, memory, sound, and video capabilities. Phones can include a slot for a SIM card that links the phone to a cell phone access provider and a slotted port for additional storage. All phones include one multifunctional port primarily used to recharge the phone's battery. Mobile phone operating systems built for speed are specifically designed to support multiple communication spectrum capabilities, including the designated cell phone frequencies, Bluetooth, Wi-Fi, near-field communications, and other connectivity options. Android and iOS operating systems dominate the market, but with practically all components welded onto the board, you can only upgrade the software, not the hardware. Portable gaming devices use specialized processors, storage, and memory, and include battery and multi-use ports for power, Wi-Fi, and other connectivity options. These devices use operating systems specially configured for mobile use, and many of those operating systems are Linux-derived. Gaming software is usually on board or downloadable, and the hardware is generally not upgradable. Internet of Things, known as IoT devices, describes physical objects that have sensors, processing ability, software, and other technologies that enable these devices to exchange data with other devices and systems over the Internet or other communications networks. IoT devices communicate via Wi-Fi, Bluetooth, NFC, Zigbee, and other protocols. They can receive software updates, but generally, the hardware within a limited space is soldered to the board and is not upgradable. Let's learn more. Widely available consumer IoT devices include smart speakers, TVs, wearable devices such as fitness trackers, and appliances such as automatic floor vacuums, stoves, and others. Light bulbs, toys, thermostats, and medical devices are also part of today's IoT world. Enterprise IoT devices enable organizations to offer consumers more targeted features and manage costs. For example, utilities install smart meters to help both residential and commercial customers manage their energy usage. Occupancy sensors and IoT-enabled security systems help businesses prevent losses and enhance worker and customer safety. Similarly, industrial IoT devices help organizations monitor the weather, operate robots, assess water and air quality, and more. In this video, you learned that common computing devices currently fit into 3 categories: stationary devices, mobile devices, and IoT devices. Desktop computers, mobile computers, and IoT devices feature a processor and input and output ports or capabilities. Desktop machines usually offer the most upgrade capabilities, while IoT devices are generally not upgradable. And desktop operating systems include Microsoft Windows, Mac OS, Linux, or Unix, while Google Android, Google Chrome, and Apple's iOS operating systems dominate the mobile operating system market. Welcome to understanding how computers talk. After watching this video, you will be able to describe 3 widely used notational systems, convert numbers between notational systems, identify common data types, and identify the 2 most widely used character types. In computers, a notational system, also called a numeral system, is a system of symbols that represent numbers. The 3 most widely used notational systems are decimal, binary, and hexadecimal. Decimal notation is base 10, as in numbers 1 through 9, then 10, 20, 30, and so on. Decimal notation uses a decimal mark, usually a period, which identifies the numbers to the right of the period as a fractional amount. Decimals with negative values display a minus symbol immediately left of the number. Binary notation is the base system for computer speak and programming in bits, but more commonly referenced in bytes. Binary uses only 2 numbers, 0 and 1, and combinations of those 2 numbers. Binary notation represents 0 as an off state and the number 1 as an on state. A single digit is known as a bit and is the smallest piece of computing information computers process. The next size of computing information is a byte. 8 adjacent bits, or digits, create a byte. To convert decimal numbers to binary numbers, divide your starting number and each subsequent quotient by 2 until the quotient equals 0. For example, start at the top of the column with the decimal 25. Divide 25 by 2 and note the remainder. Now divide the quotient 12 by 2 and note the remainder again. Repeat these steps until you get 0 as the quotient. For your final step, write the remainders so that the last remainder for 1 divided by 2 is written first, followed by the other remainders reading from bottom to top. So the binary equivalent of 25 is 11001. Here's how to change a number from binary to decimal using the doubling method. Let's start with the binary number 010010. Start with the leftmost digit, which is 0. Since you are starting from the leftmost digit and there is no previous digit to the leftmost digit, we consider the double of the previous digit as 0. Double the previous number and add the result to the current digit. Continue the same process for the next digit, which is 1. Now double the previous digit and add the number to the current digit. In this example, you get 0 times 2 plus 1, which is 1. Repeat the process for each number, moving to the right 1 digit at a time. The result of converting the binary number 010010 to a decimal using the doubling method is 18. Next, the hexadecimal notation system, often shortened to hex, is made up of 16 symbols using the numbers 0 through 9 and the letters A through F to represent decimal numbers 10 through 15. Hex offers compact notation for large numbers. Hex is used for MAC addresses, which identify where the device resides on the network, similar to your home address, color values, IP addresses, which are website addresses, and memory addresses, which identify where data exists within the computer's storage. The first column displays decimal numbers from 0 to 10. The second column displays the decimal numbers hex equivalent. The third column displays the decimal and the hex numbers binary equivalent. In this example, reading left to right, you can see that the decimal 10 is equal to A in hex and 1010 in binary. Many websites offer conversion tables where you can quickly convert numbers to their decimal, hex, and binary equivalents. To convert a hex number such as 123A into binary, follow these steps. First, note the hex number and represent each hex digit by its binary equivalent number. Next, add insignificant zeros to the left if the binary number has less than 4 digits. For example, write the decimal 10 as 0010. Then string each of the converted binary numbers together, working from left to right. This process is called concatenation. Your fourth and final step is to discard any leading zeros at the left of the concatenated binary number. For this example, let's use the hex number 123A. Use the table to convert each hex digit in 123A to binary, adding zeros to the left of the number if necessary to make the number a 4-digit number. Then string all 4 groups of 4-digit numbers together. On the leftmost binary number, discard any leading zeros. So 0001 becomes 1. Your result is 1001, 0001, 11010, the binary equivalent of the hex number 123A. Computers follow sets of instructions to perform tasks such as calculations, word processing, and web browsing using the following data types to process and present that information. Characters represent single letters. Strings show combinations of characters. Integers display whole numbers, such as the number 8. Floats represent decimals and fractions. And Boolean values provide yes or no and true or false statements. ASCII, first published in 1963, is the American Standard Code for Information Interchange format that translates computer language into understandable text. To save on transmission costs, ASCII was originally a 7-byte system, representing 128 binary characters. The system expanded to 8 bytes, providing another 256 characters. The displayed chart shows binary, ASCII, and hex equivalent numbers. You'll find similar charts online. Unicode includes ASCII characters, characters from languages worldwide, as well as emojis. More than 95% of the world's web pages use Unicode 8-bit encoding, commonly called UTF-8. Programming languages tend to use Unicode 16-bit, referred to as UTF-16, and a few programming languages use Unicode 32-bit encoding. Unicode provides a unique hexadecimal value for each character called code points. The default encoding format is usually shown as U plus HHHH, where the HHHH is the character's hexadecimal value. You'll find numerous conversion services online. In this video, you learned that bits and bytes are the base language of computer communications, and 8 bits equals 1 byte. MAC addresses, colors, IP addresses, and memory addresses use hexadecimal notation. Programs can read ASCII character text, strings, integers, floats, and Boolean data. And Unicode text, namely UTF-8, is used to display character sets on web pages. Welcome to an Introduction to Operating Systems. After watching this video, you will be able to describe what an operating system is and describe the functions operating systems manage, classify types of operating systems, describe operating system generations, and describe the history of Linux, Windows, Mac OS, and Chrome OS operating systems. Operating systems provide standardized backbone code for managing input, output, processing, and storage. These efforts help keep data error-free and mitigate data loss. Operating systems can have more than one environment. The first environment, the Command Line Interface, or CLI, is an environment where the user can type commands. The second environment is known as a graphical user interface, or a graphic shell. These environments provide menus, links, buttons, and fields that help users manage the operating system. History groups operating systems into 4 generations. The first generation was from 1945 to 1955. The second generation happened from 1955 to 1965. The third generation lasted 15 years from 1965 to 1980. And 1980 ushered in the fourth and current generation. During the first generation of modern computing, from 1945 to 1955, operating systems that worked for multiple computers did not yet exist. Each computer's parameters were uniquely created for every job or task using machine language. However, some of the code developed during this era became the basis for future operating systems. During the second generation of operating systems, mainframe computers became available for commercial and scientific use. Tape drives, a relatively new invention, provided input and output storage. In 1956, General Motors Research produced the first single-stream batch operating system, notably for its IBM 704 computing system. Subsequently, IBM became the first company to create operating systems to accompany computers. Embedded operating systems developed in the early 1960s and still in use focus on a single task, providing split-second response times, also known as low latency. In case of a system error, these operating systems can restart where the task needs to resume. Real-time operating systems are a type of embedded operating system. Airplanes, air traffic control systems, and space exploration were among the first to use real-time operating systems. As time passed, satellite systems, robotics, and even our cars implemented real-time operating systems. Then, during the third generation of operating system development, additional companies began creating batch file operating systems specifically for their large computing needs. This generation of operating systems saw the development of network operating systems that provided scalable, fast, accurate, and secure network traffic and communications, and enabled each workstation within the network to operate independently. In 1969, the Unix operating system offered a new innovation, an operating system that was installable on multiple computer systems and featured processor time-sharing. Processor time-sharing enabled multiple users with different programs to interact nearly simultaneously with a central computer, such as a mainframe. The fourth and current generation of operating systems brought computing into a new age with multitasking operating systems, including Linux, Windows, Mac OS, and Chrome OS operating systems that enable computers to perform multiple complex tasks simultaneously. Mobile operating systems, including Android, Windows, iOS, and Chrome OS, which is also considered a mobile operating system, fit the definition of multitasking operating systems. Let's learn more about some of these operating systems. In 1991, Linus Torvalds created a small open-source operating system for a PC, releasing version 1.0 of Linux in 1994. In 1996, the version 2.0 release, with support for network-based symmetric multiprocessing, or SMP, provided a serious technical benefit for commercial and scientific data processing, evolving Linux into a powerful network and server operating system. Throughout the next 10 years, Linux gained market acceptance and its distributions continued to mature. In 2013, Google's Linux-based mobile operating system, Android, took 75% of the market share. When evaluating the value of Linux, consider that in 2018, IBM acquired Red Hat for $34 billion. The operating systems PC-DOS and MS-DOS once existed, with MS-DOS launching in 1981. In 1985, Windows offered the consumer market a graphical user interface version of the Windows operating system, written in variations of C language. In 1995, the debut of Windows 95 catapulted Microsoft's dominance in the consumer operating system software market, with Microsoft holding about 70% of the consumer desktop operating system market share in 2021. Microsoft also offers network, server management, mobile, and phone operating systems. Apple, with its OS X and Mac OS based on Unix, began its foray into the operating system market in 1999 with PowerPC-based Macs. In 2006, Apple began selling Macs using Intel Core processors. In 2020, Apple began the Apple Silicon chip transition, using self-designed 64-bit ARM-based Apple M1 processors on new Mac computers. Apple also offers the iOS operating system for its tablet and smartphone devices. In 2011, Google debuted Chrome OS built atop Linux. Chrome OS offers a lightweight operating system for mobile devices, including laptops. Laptops and tablets running Chrome OS require less local storage and cost less, making them ideal for students, and this operating system is currently used by about 10% of the laptop market. In this video, you learned that operating systems provide standardized code that eliminates the need to manually recreate all the possible code necessary for input, processing, output, and storage for every computer action. In 1956, GM Research created the first operating system that is also credited as being the first single-stream batch operating system. Linux evolved into a powerful operating system for networks and servers. With the creation of Windows 95, Microsoft began its domination of the consumer operating system market. And Chrome OS, built on top of Linux, is a lightweight, primarily browser-based operating system. Welcome to Getting Started with Microsoft Windows 10. After watching this video, you will be able to identify 4 Windows login methods, describe how to use the Windows desktop, explain how to find the Settings app, explain how to resize windows and switch programs, and identify Windows keyboard shortcut commands. Microsoft Windows 10 provides 4 easy methods to log into a machine. You can log in using a PIN, a password, by drawing over a photo that you previously set up, or by scanning the fingerprint that you previously paired with the computer. Next, let's check out parts of the Windows desktop. Click the Windows icon to view the Start menu and Productivity pane. On the left side of the Start menu, you can see which user is logged on and shortcuts to documents, pictures, settings, and power management options. Available programs are organized alphabetically. If you right-click a program's icon, you can see menu options to uninstall the program, pin the program to your taskbar, run the program with administrator rights, and open its file location. To the right of the Start menu is the Productivity pane, which consists of a mixture of live and static tiles. Static tiles are shortcuts to favorite and frequently used programs, and live tiles provide a quick view of information such as news, weather, and sports. Right-click any tile to remove the tile, uninstall the program, or perform other tasks. At the bottom of the screen, the Windows taskbar provides access to the Windows Start button where you can open the Start menu. Next is the taskbar search box, where you can search for files, settings, and programs on the computer or perform a quick web search. The circle icon provides a shortcut to Talk to Cortana, and the film strip icon provides access to Windows Task View. Next, access File Explorer. Settings lets you access an app that customizes the toolbar. On the right side of the taskbar, you can see the current weather, an upward caret that you can click to display the news, the Windows Meet Now icon that opens a video conferencing program, access to OneDrive, shortcuts to Wi-Fi and wired network access, speaker volume settings, time and date settings, and notifications. When you have time, explore taskbar customizations by using the Settings app, selecting Personalization, and selecting Taskbar. Notifications are a convenient way to view the news you want to see, receive app notifications, and more. On the taskbar, click the Notifications icon to display your notifications. Click Manage Notifications to customize the notifications you see. Clicking Manage Notifications opens Notifications and Actions, which is located within the Settings app. Here you can set notification preferences, including getting app and vendor notifications, showing notifications on the lock screen, allowing notifications to play sounds, and other settings. Next, let's learn about the control buttons used to resize, maximize, and minimize windows on the desktop. To resize a window, hover over the edge of the window to display the double-headed arrow. Then drag the double-headed arrow to resize the window. You can quickly maximize a window by clicking the rectangle, and if you need to minimize the window, click the underscore button. To close a window, click the X. You'll see the X shaded in red to remind you that you are about to close an active window. Now, you can quickly locate and switch windows by pressing the Alt and Tab keys. Your screen will display windows using a carousel format. Keep the Alt key pressed and repeatedly press the Tab key each time you want to switch to the next window. Then, click and hold to display the selected window. Let's check out more keyboard shortcuts. Keyboard shortcuts save valuable time and reduce errors, resulting in productivity gains to benefit the business. Windows provides numerous keyboard shortcuts, many more than are listed here. Often new users become confused when they see the first key and the second key with a plus sign in between, so we've shown them here as the first key, the second key, and, if needed, the third key. To copy your file or content, press Ctrl-C. To paste or insert a file or content, press Ctrl-V. To delete a file or delete content, press Ctrl-D. To repeat an action, such as inserting rows or columns, or a series of words, press Ctrl-Y. To undo the previous action, press Ctrl-Z. To edit the file name, press Ctrl-O. To restart the computer, press Ctrl, Alt, and Delete. And to capture a screen image, you can use the Print Screen button displayed as PRT-SCR or the Windows Start key and the Print Screen button. In this video, you learned that you can log into Windows using a PIN or a password by drawing over a photo that you previously set up or by scanning your fingerprint. The Start menu provides shortcuts to documents, pictures, settings, and power management options. If notifications are interrupting your workflow, open the Notifications panel, click Manage Notifications, and then turn off notifications. To resize a window, Hover over the edge of the window to display the double-headed arrow, then drag the double-headed arrow to resize the window. Using the Alt and Tab keys is a fast way to locate an open window that you're not currently viewing. And finally, Windows keyboard shortcuts save you valuable time performing frequent tasks. Hello and welcome to Using Your Windows Lab Workspace. We're excited for you to take these next steps in your skills journey. The labs in this course and other courses provide you with a virtual, hands-on lab environment where you can boost your skills by practicing what you've learned in your course videos and readings. Your lab space, also known as a guided project or the My Cloud Workspace window, contains all the software you need to successfully complete your lab tasks. You'll also open a lab instructions file. For your best experience, we recommend displaying your lab space and instructions side by side. To access your hands-on lab, first open the item in the course for the hands-on lab. If the lab instructions display in a new tab, hover over the tab and pull the tab down onto the desktop. You can drag the window edges to resize the window to about 1/3 of the screen size. You'll return to this window later. Return to the course screen and scroll through the displayed course lab instructions. Select the checkbox to accept the Coursera Honor Code conditions. Then click the Open Tool button. Next, you'll see the Coursera Guided Project window. This window may take a moment to display. The displayed My Cloud Workspace window is divided into 2 panes. The left pane is named the Cloud Workspace window, and the right pane is named the Instructions window. You won't use this instructions window. Now, you can expand the Cloud Workspace pane on your screen's left side using one of 2 methods. Drag the vertical slider between the Cloud Workspace and the instructions pane to the far right side of the screen, or click the Expand Cloud Workspace window button displayed on the top right of the left pane. Take a moment to view your lab window. You can click the lab window resolution drop-down arrow to adjust the size of the on-screen icons in the Cloud Workspace. And next, let's adjust your browser windows to see your Cloud Workspace and lab instructions side by side. On the Cloud Workspace lab window, hover over the double box icon located in the top right of the browser window to reduce the size of your window. Move the window to the left side of the screen. Now, drag the window's right edge so that the Cloud Workspace lab window uses about 2/3 of the available desktop space. Next, select the browser window that displays your lab instructions. Drag the instructions window so that the window is to the right of the Cloud Workspace lab window. Now, you can perform the lab tasks in the Cloud Workspace window while using the lab instructions. After completing the lab, select Leave Session to close the Cloud Workspace window, then close your lab instructions using the option available for your browser. Also, before you begin, here's some extra information you need to know. Each time you connect to these labs, Coursera creates a fresh new environment. Data or files you saved in a previous session are no longer available. To avoid losing your data, plan to complete your lab tasks in a single session. These labs are timed to provide enough time to complete lab tasks, but if you leave the lab session unattended, your lab may time out or end. Now, these setup instructions used a Chrome browser within Microsoft Windows 10. Other browsers and web browsers on Mac or Linux computers may use different navigation. You're now lab ready. Let's get started. Welcome to Identify Hardware Components and Peripherals. After watching this video, you will be able to explain the difference between internal and external components, describe what a peripheral device is and what it does, and apply your learning to contrast, an interface, a port, and a connector. What is a computer component? It's a physical part needed for computer functioning, also called hardware. And each component performs a specific task. Components can be internal or external. External components connect via ports, which are openings on the sides of a computer. Without a given component, such as a CPU, a computer system cannot function as desired. An internal component is a piece of hardware inside the computer. Examples include random access memory, or RAM, which is the computer's working memory and is temporary, storing items you are working with as long as the power is on. If you are working on a document and the power goes off, the document is lost. The hard drive is permanent storage that you can save a file to. A file stored on the hard drive is permanently stored and will not be lost if the power fails. And the CPU does all the math calculations in a computer. It's often called the brain of the computer. The faster the CPU, the more things the computer can do at a given time. A peripheral is a device which connects to a computer to provide extra functionality. It is used in the transfer of data to or from a computer. Peripherals can be easily connected to and removed from a computer system. Peripherals attach to the computer through a connector, and the type of connector varies with the peripheral. Examples include a mouse, keyboard, and printer. There are 3 kinds of peripherals: input devices, which send commands and data to the computer, output devices, which receive commands from the computer, and storage devices, which are a type of permanent memory for files you want to keep indefinitely. A connector is the unique end of a plug, jack, or the edge of a card that connects to a port. For example, all desktop computer expansion cards have an internal connector that allows them to connect in a slot to the motherboard. A universal serial bus, or USB connector, at the end of a cable is an example of an external connector. A connector plugs into an opening on a computer called a port. A port is the jack or receptacle for a peripheral device to plug into. Ports are standardized for each purpose. Some common ports are universal serial bus or USB ports, and high-definition multimedia interface or HDMI ports. The HDMI port pictured here could be used to connect a monitor. In this video, you learned that a component of a computer is a physical part needed for computer functioning. Examples of internal components include memory and a hard drive. Examples of external components include ports and connectors. The end of a plug or cable is called a connector. Connectors fit into one specific type of opening called a port. And a peripheral device can connect externally or internally. Hello and welcome to Input and Pointing Devices. After watching this video, you will be able to compare input devices, identify which devices use a touchpad, and define a pointing device. A pointing device, such as a keyboard, mouse, joystick, touchpad, or trackball, is used to move the cursor on a computer screen. All pointing devices send a command in the form of data to the computer. Keyboards are used primarily to input data. Keyboards typically attach to the computer via a universal serial bus or USB port, although older machines may use an IBM Personal System 2 PS2 port. To add a new keyboard layout on Windows 10, use these steps. Open Settings, select Time and Language, select Language. Under the Preferred Languages section, select the default language. Select the Options button. Under the Keyboard section, select the Add a Keyboard button, and select the new keyboard layout you want to use. You can repeat these steps to add even more layouts. The most used input device, used primarily to input data and move the cursor, is the mouse. A mouse generally connects to a computer via a USB port, which is a wired connection. You can also connect a mouse via a wireless Bluetooth connection. You can change the mouse settings, such as the size of the cursor in Windows settings. Touchpads are most often used on laptops. Touchpads are built into laptops and don't need to be connected externally. However, you can purchase an external touchpad for a laptop and connect through USB or Wi-Fi. The camera is another input device that produces a digital image on the computer. A camera generally connects to a computer via a USB port, which is a wired connection. You can also connect a camera via a wireless Bluetooth connection. Cameras are typically built into laptops and don't need to be connected externally. However, you can purchase an external camera for a laptop and connect through USB or Wi-Fi. A joystick sends commands to the computer. It moves the cursor and is often used to play games. You can connect it to the computer through a USB cable or wireless Bluetooth connection. Trackballs also send commands to the computer, although they have been largely replaced by computer mice. People with mobility issues might find the trackball to be a more comfortable alternative to a mouse. A pointing device is a type of input tool. As such, you can use it to move the cursor and additional commands to the computer. A pointing stick, or stylus, is usually used on tablets. Most styluses work via capacitive technology, which is about heat and pressure. When you push the stylus onto the screen, it senses the heat and pressure and elicits a response. In this video, you learned that input devices move the cursor and send commands to the computer. Common input devices include the keyboard, mouse, touchpad, joystick, and trackball. A touchpad acts like a mouse. It's usually built in and found on laptops. And a pointing device or stylus is used for navigation and to send commands. Welcome to hard drives. After watching this video, you will be able to identify an internal storage device, describe the characteristics of a hard drive, and apply knowledge of hard drive performance to choose the best one. A storage device is hardware that can be used to store digital data in the form of images, video, audio, and text. There are two kinds of internal storage, ROM and RAM. ROM stands for read-only memory. It is non-volatile, which means it can retain data even without power. It is used to start or boot up a computer and for permanent data storage. RAM, or random access memory, is the opposite of ROM. It is volatile or temporary storage. The hard disk drive, or HDD, is one type of internal storage device, but external hard drives exist. Hard drives are available from several vendors in both formats. Hard drive and hard disk drive, or HDD, are used interchangeably. Hard drives work by a drive head reading and writing data to magnetic platters. The 2.5-inch hard disk drive is used in notebook computers and mobile devices. They trail the 3.5-inch desktop drives in capacity. Standard hard drives for desktops run from 500 gigabytes or smaller to as large as several terabytes, or TB, or larger. But given the accessibility of cloud storage, the everyday user doesn't usually need a large capacity hard drive. Serial Advanced Technology Attachment, or SATA, is the most common hard drive type for modern computers, though many motherboards support Parallel Advanced Technology Attachment, or PATA drives, which are slower than SATA drives. To evaluate disk storage capacity and availability in Windows 10, on the taskbar, type "This PC" and press Enter. Select Open. The window for this PC displays. Then, within Devices and Drives, view the available disk space. Hard drive performance is measured by spin speed, access time, and transfer rate. Spin speed, or RPM, is how quickly the magnetic platters rotate. The platters need to spin faster to increase performance in a hard drive. So, the faster the platters spin, the better the performance of the hard drive. The two most prevalent speeds in hard disk drives, or HDDs, are 5400 rotations per minute, or RPM, and 7200 RPM. Access time refers to how quickly the hard drive can find stored data on one of the magnetic platters. Access times of fast hard disks are typically from 5 to 10 milliseconds. And the transfer rate, sometimes called media rate, is the speed at which data is transferred to and from the disk media, or actual disk platter. It is described in megabytes per second, or Mbps. Follow these steps to install an internal hard drive. First, be sure to back up your data before connecting an internal hard drive. Transfer the hard drive enclosure to the new hard drive if present. Some computers use a special enclosure to secure the hard drive. If your hard drive has an enclosure for the hard drive, remove all the screws and pull the old hard drive out. Place the new hard drive in the same enclosure and secure it. Insert your new hard drive in the hard drive slot. Then secure the hard drive using the screws that came with it. Ideally, you should use 2 screws on each side of the hard drive. If the hard drive is loose, it can rattle and lead to physical damage. Now, attach the drive to the motherboard using the SATA or PATA cables. SATA cables can be connected in either direction. And finally, connect the power supply to the hard drive. To configure a hard drive in Windows, you must log on as an administrator or as a member of the administrators group. Right-click on My Computer, then select Manage, and in the console tree, select Disk Management. To customize how you view your disks and volumes in the upper and lower panes of the window, point to top or bottom on the View menu, select the view that you want to use, and make your choice of appearances. In this video, you learned that hard drives are a repository for images, video, audio, and text. Hard drives are read-only memory, or ROM, which is permanent storage. Hard drives have distinct characteristics and performance measurements such as spin rate, transfer speed, and data capacity. You should evaluate how much storage space you need before installing a new hard drive, and you should follow the correct procedure when installing a hard drive. Data should be backed up before connecting a new hard drive. And finally, hard drives can be configured in the Device Management window. Welcome to Optical Drives and External Storage. After watching this video, you will be able to identify how an optical drive records data, describe an external storage device, and apply knowledge of expansion devices to choose the best one for your needs. Data is written to optical devices through a laser pressing or burning the disk. This creates recessed areas known as pits and raised areas known as lands. The laser reads and writes data on the reflective surface of the disk. Single-sided disks have one recordable layer to write data to. Storage capacity is usually 4.7 gigabytes for a DVD-ROM and 700 megabytes for a CD. Double-sided disks have 2 layers on which to record data. They hold twice as much data as a single-layer disk. There are many types of optical drives. These include CD-ROM, CD-RW, DVD-ROM, DVD-RW, and Blu-ray, which has a data capacity of 50 gigabytes or 50 GB. CD and DVD writers, such as CDR and DVD-R drives, use a laser to read and write data on the disks. A solid-state drive, or SSD, uses integrated circuit assemblies to store data, typically using flash memory and functioning as permanent secondary storage. It is also sometimes called a solid-state device or a solid-state disk, even though SSDs lack the physical spinning disks and movable read-write heads used in hard disk drives, or HDDs, and floppy disks. An external hard drive is an excellent medium to back up and transfer files. They can store large amounts of data, including documents, spreadsheets, presentations, music, and videos. Most external hard drives connect to a computer through a USB or eSATA connection. Many draw power from the computer's USB port. External SATA or eSATA is a SATA connector accessible from the outside of the computer to provide a signal but not power. If the external hard drive requires a power cord, connect it to the back of the hard drive. The end of the power cord that connects to the hard drive is usually a small round connector. Connect the other end of the power cord to a power outlet. If no power cord is required, skip to the next step. Connect the USB cable to the external hard drive and plug the other end of the USB cable into a USB port on the computer. After connecting the external hard drive to the computer, it should be recognized automatically by your computer's operating system. Your computer should find and install any necessary drivers. In Windows, File Explorer may automatically open, displaying the contents of the external hard drive. If File Explorer does not automatically open, manually open File Explorer and locate the drive. An expansion drive provides extra storage for an ever-growing collection of files. It typically attaches to the computer with a USB connection. Expansion drives consolidate files into a single location and frees computer space. The drive is automatically recognized by the Windows operating system, so there's no software to install or configure. One example of an expansion drive is a USB or thumb drive. These drives have a storage capacity of up to 2 terabytes or 2 TB. A USB flash drive is an expansion device that includes flash memory with an integrated USB interface. It is typically removable, rewritable, and much smaller than an optical disc. Most weigh less than 1 ounce. Since first appearing on the market in late 2000, as with virtually all other computer memory devices, storage capacities have risen while prices have dropped. As of 2018, 2 terabyte flash drives were the largest available in terms of storage capacity. Some are thought to last 10 to 100 years under normal circumstances or shelf storage time. A memory card is used to store digital information, typically using flash memory. These are commonly used in portable devices such as digital cameras, cell phones, laptop computers, and portable media players. The card is stored inside a device. This differs it from USB drives. Memory cards are available in both secure digital, or SD, and micro-secure digital, or MSD, formats. Common digital capacities are 32 GB, 64 GB, and 128 GB. Some of the latest generation memory cards offer 512 GB memory card capacities. Portable media players and smartphones are other types of storage devices. A portable media player is any type of electronic device that is capable of handling digital media. Depending on the device, the types of media files that can be played include digital music, audiobooks, and video. A mobile media player is often part of a smartphone. It is important to understand the difference between internal and external or expandable memory. Internal memory is the manufacturer-installed storage space, usually 16, 32, or 64 gigabytes, where the operating system, pre-installed apps, and other system software are installed. The total amount of internal storage cannot be increased or decreased by the user. So if your phone has only 16 gigabytes of internal storage and no expansion slot, this is all the storage space you will ever have. And remember, some of this will already be used up by the system software. External or expandable memory refers to a removable micro SD card or similar format, but not all phones will have this extra storage capability included. If storage for music, images, or other user-added files is important to you, the ability to add another 32 gigabyte or even 64 gigabyte card should be an important consideration. In this video, you learned that optical drives record data using a laser on a reflective disk. An external storage device, such as an external hard drive, often connects to a computer via a universal serial bus or USB connection. External hard drives and USB drives are solid state, which means they've got no moving parts. They're faster and more expensive than traditional hard drives. The best storage option for you will depend on your needs and your budget. Smartphones and media players offer portable storage as well as extensive functionality. And solid-state drive or SSD media, such as external hard drives, USB drives, and memory cards, increase the storage capacity of a system. Welcome to Display Devices. After watching this video, you will be able to Define and identify types of display devices. Enumerate how to adjust display properties. And identify the installation and removal of display devices. A display device is a hardware component for the output of information in visual form. Visually impaired people can choose a tactile monitor that presents the information in a fingertip-readable format. Common applications for display devices are television sets and computer monitors. A cathode ray tube, or CRT monitor, is an analog device that creates an image on the screen by directing 3 electron beams over millions of phosphor dots to light them up. CRT monitors were commonly used in televisions and computer monitors throughout the mid to late 1900s. By 1990, IBM's Extended Graphics Array, or XGA display, boasted 16.8 million colors in 800 by 600 pixel resolution. Flat screens are also known as liquid crystal display, LCD, or thin film transitor, TFT monitors. A digital signal drives the color value of each picture element or pixel. They replace the larger and heavier analog CRT monitors. Touchscreens use a touch panel on an electronic display. Their capacitive technology measures heat and pressure. They are often found on smartphones, laptops, and tablets. Projectors are output devices that can take images from a computer and display them on a screen, wall, or other surface. The surface projected onto is usually large, flat, and lightly colored, such as a wall or whiteboard. The projected images are either still, like slides, or moving pictures. Screen resolution refers to the clarity of the text and images displayed on your screen. At higher resolutions, such as 1600 by 1200 pixels, items appear sharper. Older CRT monitors generally display a lower resolution of only 800 by 600 or 1024 by 768 pixels. You can change your screen resolution by selecting Settings, then System, and then Display. Windows uses plug-and-play installation. Windows locates and installs a device driver when you connect the device. Hot swappable devices, such as monitors, do not require a system restart to connect or disconnect. If you need to manually install a driver, locate the driver setup program from the vendor's website and then download and run it. To enable your PC to recognize multiple monitors in Windows 10, make sure your cables are connected properly to the monitors, press Windows key plus P, and select a display option. Your choices include Duplicate. This will copy your display to both monitors, or Extend, and this will project your display equally over 2 monitors. To uninstall a device in Windows, launch Device Manager by selecting the Start button, typing Device Manager, and pressing Enter. Then follow these steps. Open the View menu and select Show Hidden Devices. Expand the node that represents the type of device you want to uninstall, then right-click the device you want to uninstall, and select Uninstall. In the Confirm Device Removal dialog box, if you wish to remove the driver package in addition to uninstalling the device, select the Delete the Driver software for this device option. When ready to complete the operation, select OK. With some devices, if the device is still plugged in when it is uninstalled, the device might continue to function until the system has been restarted. In this video, you learned that a display device is a hardware component for the output of information. Types of display devices include flat screen and CRT monitors. The display resolution can be adjusted by using Device Manager. To install a plug-and-play display device, you need only attach it to the computer. And to remove a display device, use Device Manager to uninstall it. Hello and welcome to Printers and Scanners. After watching this video, you will be able to describe what an output device does, install a printer in Windows, and identify types of printers used by a computer. Input to the computer is processed as data and shown or output via an output device. An output device is any piece of hardware that converts information into a human-readable form. That output can be text, graphics, tactile, audio, or video. Examples of output devices include monitors, printers, speakers, headphones, and projectors, as well as GPS devices, sound cards, video cards, optical mark readers, and braille readers. A speech synthesizer produces verbal output like human speech. A computer can function without an output device. However, without an output device, there is no way to determine what the computer is doing. There is no indicator of errors nor the need for additional input. For example, if you detach your monitor from your computer, the computer will still function, but you won't be able to see anything. A printer is simply a machine for putting text or pictures onto paper. There are 4 main types: laser, LED, inkjet, and thermal. Laser or thermal printers use a heated unit to fuse ink onto paper. LED printers, like laser printers, have a photoreceptive drum that surfaces positively charged with static electricity by a high-voltage wire. The paper then passes between 2 heated rollers, fusing the toner to the page before it comes out the printer. Inkjet printers have a print head containing thousands of tiny holes. These openings put microscopic droplets of ink onto paper very quickly. Inkjet machines use a liquid ink produced by either a colored dye or a liquid that contains solid pigments. And thermal printers heat specially coated paper to turn sections black and is used in point-of-sale terminals and fax machines. A networked printer is connected to a network using Ethernet or Wi-Fi, the latter being the more popular choice. Whereas a local printer would be cabled to the device that requires it, a networked printer can be accessed by multiple devices simultaneously on the same network. An IP-based printer is part of an IP network. It often refers to Unix computers that use a specific protocol for printing. Like an IP-based printer, a web-based printer can receive documents through a network and via the internet, rather than a direct connection to a computer. To install or add a local printer using Windows, follow these steps. Select the Start button, then select Settings. Then choose Devices and select Printers and Scanners. Select Add a printer or scanner. Wait for it to find nearby printers. Then choose the one you want to use and select Add Device. An image scanner or scanner optically scans images, printed text, or an object and converts it from an analog format to a digital image. This creates an electronic version of the document that can be viewed on a monitor or screen and edited on a computer. Commonly used in offices are variations of the desktop flatbed scanner, where the document is placed on a glass window for scanning. Flatbed scanners have been replaced by multifunction devices. More on those coming up next. A fax machine is a device that is used to send documents over a telephone network. The transmissions can be between 2 fax machines, or between a fax machine and a computer, or an online fax service. Often the functions of a printer, scanner, and fax machine are combined in one device, known as a multifunction device, or MFD. In this video, you learned that an output device is hardware that converts information into a human-readable form. Installing a printer in Windows 10 takes only a few steps. Printer types include inkjet, LED, laser, and thermal. Output devices display data from the computer in one or more formats. Scanner output can be selected in different formats, including a PDF. And multifunction devices, or MFDs, can be used instead of standalone printers, scanners, copiers, and fax machines. Welcome to Audio and Visual Devices. After watching this video, you will be able to define audio and visual devices, explore the usage of speakers, microphones, and headphones with computers, and evaluate the usefulness of webcams. On its own, your computer can't make a sound. Digital data from audio and video files need to be turned into something that our ears can hear, and this requires specialized hardware and processing in the form of audio devices. Audio devices refer to components that reproduce, record, or process sound. This includes microphones, CD players, amplifiers, mixing consoles, effects units, and speakers. Visual devices are units capable of presenting images electronically on a screen. Typically, such devices have a display greater than 4 inches when measured diagonally. Images can be displayed on smartphones, computer monitors, and laptop computers. A computer speaker is an output hardware device. It connects to a computer to generate sound. The signal used to produce sound is created by the computer's sound card. To configure your speakers in Windows 10, right-click the speaker icon in the taskbar's notification area or system tray and select Open Sound Settings to go straight to the Sound Settings screen. Locate the Output section on the sound screen, and in the drop-down menu labeled Choose Your Output Device, select the speakers you'd like to use as your default. A microphone, sometimes abbreviated as mic, is a hardware peripheral and input device. A microphone allows computer users to input audio into their computers. To install a new microphone using Windows 10, follow these steps. First, make sure your microphone is connected to your PC. Then select Start, then Settings, System, and Sound. Scroll to Input, choose your input device, and select the microphone or recording device you want to use. Sometimes referred to as earphones, headphones are a hardware output device that plugs into a computer line-out or speaker port. Headphones allow you to listen to audio without disturbing the people around you. To use a headset, you must connect it by one of 2 means. Attach one end of the headset to an available port on a PC, or link it via wireless. If you plan to use a wired connection, you might use a 3.5mm jack. Older and more affordable headsets usually have the cable split at the end with 2 3.5mm jacks, one for audio out and the other for the microphone. These connectors are green for the headset and pink for the microphone. The next option, if you plan on using a port, is to use a universal serial bus connection. USB-powered headsets offer enhanced experiences thanks to inline amps, controls, and other features that affect sound quality. Or you can use a wireless connection. Bluetooth headsets remove all the cables between the headset and your computer, allowing you to sit more comfortably without fear of creating a tangle of cables. A webcam feeds an image or video in real time to a network such as the Internet. Webcams can be used during a video chat and offer a compact video recording device. Once of very low quality, modern webcams are usually high resolution with 1080p or pixels or high definition HD. They can be built into laptops or attached using a universal serial bus or USB. Here's how to set up a webcam in Windows. Press the Windows key or click Start. Type Camera in the search box and select the Camera app. The Camera app opens and the webcam is turned on, displaying a live video of yourself on the screen. You can now adjust the webcam to center your face on the video screen. In this video, you learned that audio and visual devices, such as webcams and speakers, add multimedia functionality to a system. The sound quality of a speaker depends on the sound card. Headsets are available in a variety of connections and sound quality. Newer webcams offer HD or 1080p quality, and such webcams are useful in video chats. Welcome to Identifying Ports and Connectors. After watching this video, you will be able to define a port and a connector, differentiate between a port and an interface, and identify common ports and connectors. Devices connect to a computer using ports and connectors. A port is a hole or a slot that receives a connector and allows a device to physically connect to a computer. A connector is the distinctive plug at the end of a cable, jack, or electronic card that can be physically plugged into a port. Each port has a unique function and accepts only the connector designed specifically to fit into it. Common examples of physical ports and connector pairs include the USB port, HDMI port, display port, and speaker port. An interface is the point of communication between two or more entities. An interface can be either hardware or software-based. Examples of hardware-based interfaces include the point where a port or card connects to the computer motherboard, the point where a peripheral device connects to the computer, or a touchscreen device that records human inputs. Software interfaces provide routes for communication between software applications, the operating system, and hardware. For example, drivers are software interfaces that enable communication between the operating system and the computer's hardware components. Let's take a deeper look and learn to identify commonly used interfaces and connectors. The Universal Serial Bus, or USB, was built by a consortium of 7 companies to replace the many varieties of connectors available in the market with a common, simple-to-use, and fast standard that could be used across devices and peripherals. Since its launch in 1996, the USB connector has gone through several iterations. When USB was first launched, it supported speeds of 1.5 to 12 megabits per second. It also supported 4 different connector types: Type A, Type B, Mini A, and Mini B. USB 2 was launched in 2001 to increase data transfer speeds up to 480 megabits per second. It also added support for the Mini AB connector and introduced the Micro A, Micro B, and Micro AB connectors. The USB 3 series of updates saw speeds increase to 5 gigabits per second, with USB 3.0 in 2008. The Type-C connector was launched with USB 3.1 in 2014 with speeds of 10 gigabits per second. It was made backward compatible with all versions of USB up to USB 2. USB 3.2 was released in 2017 with speeds of 20 gigabits per second. The mini connector types were discontinued in this version. USB 4, based on the Thunderbolt 3 and 4 protocol specifications, was released in 2019 and continues to be the latest and greatest version for USB devices. It supports speeds up to 40 gigabits per second over a Type-C connector. The Type A USB port has an elongated rectangle shape with 4 pins and carries both data and power. It is typically used for keyboards and mice. The Type B port is almost square with beveled outside top corners. These also have 4 pins and are mostly used with printers, scanners, and similar devices. Mini USB ports were introduced for use with smaller devices such as digital cameras, mobile phones, and tablets. They have 9 pins and are smaller than Type A or B and twice as thick as micro USB ports. Micro USB ports are similar width as mini USB, but much thinner with only 5 pins. These were designed to replace mini ports on smaller devices. And finally, the 24-pin Type-C with a reversible connector is designed to be future-proof and to replace various Type A and B connectors. Thunderbolt is a commonly used hardware interface developed by Intel and Apple. It was originally marketed under the name Lightpeak, but was later renamed to Thunderbolt. The Thunderbolt interface is very versatile, combining data transfer, display, and power into one cable. It allows up to 6 peripheral devices to be connected through a daisy chain. Thunderbolt interfaces have 4 versions. Versions 1 and 2 use the same connectors as a mini DisplayPort or MDP. Versions 3 and 4 reuse the USB-C connector. While Thunderbolt 3 doubled the data transfer rate to 40 gigabits per second, Thunderbolt 4 has support for USB 4 protocol and data rates, and dual 4K displays. It also supports Thunderbolt Alternate Hubs USB, and not just daisy chaining. All Thunderbolt ports are identified using the Thunderbolt symbol to differentiate them from regular MDP and USB-C ports. Before Thunderbolt, FireWire was a popular interface on Macintosh computers and is comparable to the modern USB interface. It comes in various shapes. The 400 is a slimmer connection with one rounded side, and the faster 800 connector looks like a thicker version of the USB. FireWire ports use a serial bus architecture to transfer information one bit at a time. This makes them lighter and cheaper than parallel buses that use a number of different physical connections. Firewire interfaces have been replaced with Thunderbolt and USB interfaces on modern computers. However, users with older computers, as well as the automobile and aerospace industries, still use these ports. PS2 ports were developed by IBM for their IBM Personal System 2 series of computers and are named after them. They are round and have 6 pins for connectivity. These ports were specifically designed to connect the keyboard and mouse to the computer. Although the two PS2 ports look identical, they are not interchangeable and they are identified by different colors and symbols. And although the PS2 port is considered a legacy port, modern PCs may still carry them as they are preferred by gaming enthusiasts, legacy users, and industrial applications. eSATA is the most popular port to connect external storage devices, such as external hard drives, to computers. eSATA allows hot swapping, which is the replacement or addition of external devices without stopping, shutting down, or rebooting the host system. Since 2008, eSATA has been upgraded to the eSATA P interface that allows for both eSATA and USB devices to be connected through the same port. eSATA has been through 3 main revisions, and data transfer speeds have doubled with each revision. In this video, you learned that a port is a hole or slot that receives a connector and allows a device to connect to a computer. A connector is a plug at the end of a cable, jack, or electronic card that can be physically plugged into a port. An interface is a hardware or software-based point of connection between 2 or more entities that enables communication. And common ports and connectors include PS2, Thunderbolt, Firewire, eSATA, and USB. Welcome to Identifying Graphic Devices. After watching this video, you will be able to describe how graphic devices operate on a computer, list characteristics of the display system, and recognize the different types of display connectors and their use. Computers communicate with a display unit, such as a computer monitor, using display cards called the Graphics Processing Unit, or GPU. Generic graphic cards are built into a computer's motherboard and are good for everyday computing requirements. Graphic-heavy tasks, such as multimedia editing and 3D gaming, require specialized high-end graphic adapters. Radeon chipsets by AMD, GeForce and Enforce chipsets from NVIDIA, and other adapters from SIS, Intel, and VIA are popular products on the market. When selecting a computer display, the resolution, refresh rate, and bit or color depth all play an important part. The resolution is the number of horizontal and vertical pixels, which determines the clarity of an image or text. The refresh rate, based on how fast the screen refreshes to show a new image, governs the video playback quality, while the bit depth, which describes the total number of supported colors, dictates how close the colors are to real life. Higher resolutions, refresh rate, and bit depth result in higher quality images, smoother video playback, and true color displays. The display quality is directly linked to the amount of processing power required from the graphic processing unit, or GPU. It is, of course, possible to display low-resolution images and video on a high-end display, thereby reducing the need for graphic processing power. Initial displays used cathode ray tubes, or CRTs, with a 4:3 screen width-to-height aspect ratio. These displays supported Video Graphic Array, or VGA standards. The earliest VGA standard supported 640 by 480 pixels with a 4-bit 16-color display at 60 Hz. This was superseded by the SVGA standard, supporting 800 by 600 resolution and 4 or 8-bit color. The next iteration, using XGA standards, supported 1024 by 768 pixel displays, 16 or 32-bit colors, and a higher refresh rate. All of these displays used a 4:3 screen width to height aspect ratio. With the advent of LED technology, widescreen monitors supporting 16:9 aspect ratios are common. These monitors support high-end resolutions from between 1280 pixels by 720 to 1920 by 1080 for a full HD display. Larger devices use even higher resolutions, such as 3840 by 2160 for 4K or Ultra HD displays, and 7680 by 4320 for 8K displays. Different display and graphic adapters come equipped with different ports that support different connectors and cables. Sometimes the same adapter may have more than one type of connector. Each connector represents an advancement in display technology and brings its own benefits. Let's take a look at each of these in greater detail. High-Definition Multimedia Interface, or HDMI, is the latest and most widely used interface for digital audio and video for televisions, Blu-ray players, computers, and other consumer electronics. Beyond just data transfers, HDMI also provides remote control, or CEC support, and digital content protection, or HDCP. The HDMI connector has a proprietary 19-pin connector in 3 sizes: HDMI 2.1 for regular connections, HDMI Mini for portable electronics such as DVD players, and the micro HDMI for GoPro action cameras, smartphones, and so on. The newer versions of HDMI offer greater bandwidth and can therefore support higher quality resolutions up to 8K. Developed by the Video Electronics Standards Association, or VESA, DisplayPort is designed to complement HDMI and offer a royalty-free alternative. It improves upon the DVI interface and is the first to use packetized data transmission. This allows DisplayPort to transmit higher bandwidths over fewer pins, thereby resulting in almost lossless data transmission. The DisplayPort connector has 20 pins, where 12 are for the main link, 3 pins for the auxiliary channel, 1 for the hot plug detection, 2 for power, and 2 additional ground pins. It can support 7 different transmission modes for progressively increasing bandwidth. Intel and Apple developed the Thunderbolt interface, and this interface remains popular on Apple computers. This versatile cable type functions both as a display and as a peripheral interface. The initial version of Thunderbolt used the Mini DP interface. Thunderbolt version 3 and the current Thunderbolt version 4 both use a USB-C interface. However, it is important to know that a Thunderbolt device plugged into a standard USB-C interface does not support Thunderbolt features, and a USB-C cable plugged into a Thunderbolt interface does not support Thunderbolt features. Developed as an industry standard for digital video content transmission, DVI connects a video source to a display. It transmits uncompressed digital video and can support both analog and digital devices in various formats. The DVI-I interface supports integrated digital and analog equipment on the same connector, while DVI-A supports only analog equipment and DVI-D supports only digital equipment. The digital connectors come in single and dual link formats, where the dual link provides higher bandwidth for resolutions higher than HD TV or 1920 by 1200. This interface was very popular but has since been replaced by HDMI and Thunderbolt or DisplayPort interfaces. One of the earliest interfaces, the VGA, was developed for analog video transmission. Considering that most of the modern graphic devices handle digital content, the VGA is now considered legacy, although some PCs continue to support it. The VGA has a distinctive 15-pin array distributed into 3 rows. The connector can be secured to the port using screws. There are several other connectors used commonly that are worth mentioning here. Apple provides a free license for the Mini DisplayPort, and it can support up to 4K resolutions, so users can connect their computers to HD TVs starting from the 2010 version. Many popular laptop models ship with the mini DisplayPort interface. Some displays use USB to connect. Universally, cameras use USB ports to connect to computers. Some display monitors also use USB Type-A connectors. And some older televisions, VCRs, and computer monitors use S-cables to connect using the S-video port. Component RGB is used to process analog video signals. These interfaces typically split video into 3 signals and usually have 1 or more additional cables for transmitting the audio signal. In this video, you learned that computers need a display unit connected to a screen in order to display graphics and video. Quality of display is based on resolution, bit depth, and refresh rates. And higher quality display requires high-end specialized adapters. The current display systems use 16:9 aspect ratio with LED displays, while older models use CRT displays featuring a 4:3 aspect ratio. And there are different graphic connectors available, and each has its own features and benefits. Welcome to Identifying Audio Connectors. After watching this video, you will be able to describe how audio devices connect to a computer, list the different types of audio connectors, and identify audio connectors based on the connection type. Computer programs use an internal expansion audio card, also known as the sound card, to transmit audio signals into and out of a computer. These cards have a digital-to-analog converter to help external analog devices connect and communicate with the computer. Depending on the sound card, it can have ports to connect a variety of devices, such as headphones, speakers, microphones, video projection devices, and more. Sound cards are commonly used to listen to music, record and edit audio or video, play computer games, make presentations, and conduct teleconference calls. Audio input and output devices use different types of connectors, such as sound cards, Bluetooth, game ports or USB ports, and external audio interfaces. Let's take a look at each of these in more detail. The number of connectors or ports on a sound card depend on the requirements. These ports accept a 6.35mm tip, ring, and sleeve or TRS jack, or a 3.5mm TRS mini jack. The ports are usually labeled but are also color-coded for easy identification. At a minimum, a sound card offers a light blue analog line in, a pink microphone in, and a lime green audio line out connector. Sound cards with advanced features may also provide additional outputs, including black for left and right rear surround speakers and orange for mid-surround. Built-in Bluetooth connectors use a wireless interface to connect audio devices like headsets and speakers. Modern computers and laptops come with built-in Bluetooth adapters. However, external Bluetooth dongles are also available. These connect through the USB port to receive and transmit Bluetooth signals. Until the late 1990s, game ports used MIDI interfaces with the standard 15-pin connector. The 2 redundant pins, 12 and 15, were repurposed to transmit audio and enhance the gaming experience. Modern computers and gaming controllers use the USB port for both connectivity and audio, and the game port is now obsolete, except for backward compatibility with outdated devices. A single external audio interface can connect to multiple input and output devices, such as amplifiers, microphones, speakers, and so on. Professionals and studios use external audio interfaces for better quality and amplified sound. These external audio interfaces then connect to the computer via USB, FireWire, Thunderbolt, or similar digital connectors and require specific drivers to work. In this video, you learned that computers use internal expansion cards, called audio or sound cards, to send and receive audio signals. There are a number of ways a computer can connect to audio devices through the sound cards. And the most common connectors are sound card ports, Bluetooth, game ports or USB ports, and external audio interfaces. Welcome to Wired and Wireless Network Connections. After watching this video, you will be able to describe network communication types, give examples of wired and wireless connections, and contrast wired and wireless connections. Today, hardly any device operates in isolation, unless that's what you want. Communication technology allows components to communicate over a network by converting information into data packets that are sent from one smart object to another in dialogue. Like papers in an envelope, each data packet contains information about the sending and receiving device, along with the message that needs to be transmitted. This ensures that only the designated device receives the information. As such, devices built to talk over a network can communicate with each other. A finite number of devices can be connected in a closed network or to an unlimited number of devices over an open network, such as the Internet. For example, your phone could be used to control your humidifier on your home network. Either type of network connection can be wired or wireless, such as Bluetooth. An RJ, or registered jack connector, is used for landline telephones. There are two types of RJ connectors. An RJ11 is used to plug a phone into a wall outlet and for connecting a handset to a telephone. RJ45 connectors are used for connecting computers and other Internet-enabled devices, such as wired credit card readers, servers, modems, gaming consoles, and smart TVs, to Ethernet-based local area networks or ELANs. The RJ45, like the RJ11, has a plastic tab to prevent misconnections between the connector and the port. Wired connections allow faster data transmission. This connection offers speeds up to 5 gigabits per second, while wireless connections have a speed of only 1 gigabit per second. They're more reliable than wireless connections because they have consistent speed and connectivity. Wired connections are not impacted by weather conditions and are immune to signal drops and dead zones. Wired connections are less prone to radio interference, so there are fewer dropped packets that need to be retransmitted. This translates into greater network stability and speed. As devices need to be physically connected in a wired connection, they are more secure and less likely to be hacked. Wireless connections use different technologies based on connection requirements. For example, wireless fidelity, or Wi-Fi, is used to connect computers, phones, tablets, smart TVs, and other devices to the Internet. It works by connecting a wireless router directly to an Internet modem. The router acts as a hub for all wireless-enabled devices within a range to connect to a home network and the Internet. Note that newer modems have built-in routers to avoid the need for connecting a separate device. Bluetooth technology, available since 1998, uses ultra-high-frequency radio waves to connect devices in a one-on-one connection over short distances. The connection between a sending and receiving device is established through a process called pairing, where both devices send a passkey to recognize each other. Radio frequency identification, or RFID, is used to identify and track objects using tags. RFID devices can operate over several hundred meters. RFID is used in the automatic collection of road tolls through tags affixed to vehicle windshields. Other uses of RFID tags can include implanting them in pets and livestock to enable easy identification, tracking pharmaceuticals through warehouses, preventing theft, and expediting checkout in stores. NFC, or near-field communication, is an evolution of RFID technology that works over extremely short distances. Near-field communication transmits data through electromagnetic radio fields to enable two devices to communicate with each other. To work, both devices must contain NFC chips. The short range makes NFC power efficient and increases security by eliminating accidental triggers. Common implementations of NFC include key cards for hotels and office access, digital wallets, and chip-enabled credit cards. Wireless networks are becoming increasingly commonplace because of their advantages over wired connections. For example, there's the increased mobility. Users can easily move from one location to another without losing connectivity most of the time. Wireless connections are extremely quick and easy to set up. On the other hand, wired networks require extensive cabling and equipment that must be installed and tested before the network becomes operational. As your networking requirements evolve, it is very easy to make updates and scale up in a wireless network. A wireless network can be easily extended to reach a wide area, including places where you cannot install network wires and cables. And wireless networks are more economical, as they require less equipment and are easier to scale and maintain than traditional wired networks. In this video, you learned that devices connect with each other using wired and wireless networks. The main types of wired connectors are the RJ11, which is used in telephony, and the RJ45 used to connect computers and related peripherals. Wireless networks use different technologies based on usage requirements. Wi-Fi connects devices to home networks and the internet. Bluetooth has a short range but transmits large streams of data. RFID uses a tag and receiver model to collect identifying information. It is useful in tracking products, livestock, and pets, and for collecting tolls on highways. And NFC is an evolution of RFID and operates over extremely short distances. It often requires physical contact between devices to transmit data. Welcome to Peripheral and Printer Connections. After watching this video, you will be able to list common methods for connecting to and installing printers and peripherals, describe how to connect printers or peripherals using serial ports and parallel ports, and describe how to connect printers or peripherals via a local or network connection. How does a computer recognize a peripheral device or printer? Computers require software that enables peripheral or printer device recognition and communication. Computers use onboard pre-installed plug-and-play software designed as generic software that can work with multiple printers, scanners, or other specific peripherals. For example, a generic printer driver could enable the installation of various brands of printers. If the device doesn't successfully install when trying a plug-and-play installation, your next step is to visit the manufacturer's website to locate and install the device driver that works with your operating system. Often, by installing the driver software, you can use the device's basic features. However, for example, if you have a peripheral device, such as a multifunction printer, and you want to use its additional features, such as scanning and faxing, manufacturers generally require that you download and install their device application software. To save time, check the manufacturer's instructions before starting your installation. Initial standalone peripheral installation often still requires a wired connection or network connection. You'll connect the printer to your computer using a cable, then turn on the printer. Frequently used standalone peripheral and printer connections include USB cable connections and wireless connections, including Wi-Fi, Bluetooth, and near-frequency communications, or NFC. And you might encounter 3 other printer connection methods, including a serial port connection, a parallel port connection, or a network connection. Serial-connected printers are less common these days. Serial connections transmit data more slowly. RS-232, a recommended standard protocol, remains in use. RS-232 data signals can travel longer distances with better noise immunity and compatibility among manufacturers. And RS-232 cables commonly feature 9-pin connections, as shown here, and 2 screws to secure the cable to the device and the computer. Parallel port connections are less common, but do still exist. In many instances, they have been replaced by USB and other connections. Parallel ports can send and receive multiple bits of data simultaneously, processing data faster than serial ports. Parallel port cables feature 25-pin connections and include 2 screws that help keep the cables connected to computers and devices. Peripheral and printer network connections can be wireless using Wi-Fi or wired using an Ethernet connection. Before adding a connection to a network-based peripheral, verify your connectivity. Here's how to connect and install a printer using a serial or parallel port. These instructions also apply to other peripheral devices. If needed, locate and install the driver or software using the manufacturer's instructions. Next, locate the serial port or parallel port on your computer. Serial port cables usually have 9 pins. Parallel ports have 25 pins. Attach the cable connection to the computer's port. These cables include side screws that attach to the computer body so that the cable remains connected to the computer. Power on your printer and configure the printer. Printer connections are available within the Settings app. Using the Settings app, select Devices, Printers, and Scanners, and then select the plus Add a Printer or Scanner option. Windows often automatically detects connected printers. If the printer's software is installed, select Open Printer app to configure the printer. If you don't see the printer that you want to add, select the link for The printer that I want isn't listed. This option is beneficial for older style printers and network-connected printers. Follow the prompts to find a printer using other options, including older printers, network printers, Bluetooth printers, or any printer needing a manual connection. In this video, you learned that printers require software known as drivers for the computer and the printer to be able to communicate with each other. In some instances, to use all the printer's capabilities, you need to install the manufacturer's software. Both serial and parallel port cables include side screws that attach to the computer body so that the cable remains connected to the computer. And to add a network printer, verify your computer's network connection, locate your operating system's printer and scanner settings, and search for an available network printer. Welcome to Installation Types. After watching this video, you will be able to define hardware and software installation, evaluate the advantages of plug-and-play over driver installation, and explain the similarities of IP-based and web configuration. Installation is the process of making hardware and/or software ready for use. Different systems require different types of installations. While certain installations are straightforward and can be performed by non-professionals, others are more complex and may require the involvement of specialists. The types of installation can be broken down into 2 categories: plug-and-play and driver installation. Plug-and-play, sometimes abbreviated as PNP, describes devices that work with a computer system as soon as they are connected. The user does not have to manually install drivers for this device, or even tell the computer that a new device has been added. Examples of PNP devices include mice and keyboards. If a PNP device doesn't function in Windows, the user should look in Device Manager for an indication of a problem with the device. Device Manager is part of the Windows operating system. It allows users to view and control the hardware attached to the computer. When a piece of hardware is not working, that hardware is highlighted with a yellow icon for the user to deal with. One cause of device malfunction is an outdated driver. A driver is the software that allows a device to talk to the operating system. Updating the driver may restore proper function to a device. To update a device driver in Windows 10, follow these steps. First, open Device Manager by typing Device Manager in the search box and selecting Device Manager. A list of names of installed devices will display. Click the arrow to the left of the device you're looking for to expand the list. Right-click the device you'd like to update and select Update Driver. An IP-based peripheral is hardware that is connected to a transmission control protocol, Internet Protocol, or TCP/IP network. Examples of IP-based peripherals are wireless access points, wireless routers, IP security cameras, network print servers, and networked printers or multifunction devices. These devices must be connected to a local area network or LAN or the Internet for installation and functionality. When you install a device, you get it ready for use, but when you configure a device, you're setting it up to work according to your preferences. Web-based configuration is used for networking devices, such as routers. This makes the setup process easier. All your work is done on a web page, which is generally found on the manufacturer's website. In this video, you learned that hardware and software installation is a prerequisite for functionality. One of the advantages of plug-and-play over driver installation is the speed with which a device can be installed. The alternative is to install drivers manually, which is more time-consuming. And IP-based and web-based configuration both require an internet connection for installation and functionality. Welcome to Internal Computer Components. After watching this video, you will be able to recognize several internal computer components, explore the role of a motherboard, and evaluate the importance of data flow. A motherboard is the main printed circuit board or PCB in computers and other expandable systems. Motherboards contain significant subsystems such as the chipsets, input, output, and memory controllers, interface connectors, and other components integrated for general use. Motherboards allow communication among many crucial electronic components, such as the central processing unit or CPU and memory. And motherboards also provide communication pathways for peripherals, such as keyboards and other components. A chipset is a set of electronic components in an integrated circuit that manage data flow among the processor, memory, and peripherals. A chipset has two parts, the north bridge and the south bridge, which manage communications among the CPU and other parts of the motherboard. A north bridge chip, or host bridge, is one of the two chips in the core logic chipset on the motherboard. Unlike the south bridge chip, the north bridge chip connects directly to the CPU via the front side bus and performs high-performance tasks. The south bridge chip, the second chip of the chipset, generally implements slower performance tasks, and a south bridge chip is usually not directly connected to the CPU. A bus is a high-speed internet connection embedded as printed circuits on the motherboard. A bus sends control signals and data among the CPU and other internal components. It's like the information superhighway of the computer. A front-side bus is a computer communication interface that carries data between the CPU and the memory controller hub, or the north bridge. Now, a socket is the array of pins and the securing mechanism that hold a processor in place and connect the processor to the motherboard. Socket pin connections differ depending on which generation of CPU your motherboard supports. Older sockets use a pin grid array, or PGA, that uses short, stiff pins on the CPU that align with the holes on the socket. When installing a CPU, do not force the CPU into the socket. If the CPU and socket are correctly matched, the CPU should fit. Newer motherboard sockets, called land grid arrays, or LGAs, have built-in pins and the CPUs have contact points on them. A power connector is a device found on a motherboard that allows an electronic current to pass through it to provide power to a device. Not all power connectors look alike. An ATX-style connector is one of the larger power connectors inside a computer. These connectors join the power supply to the motherboard. In this video, you learned that internal computer components include everything connected to the motherboard. A motherboard provides a communication pathway for peripherals. Buses send control signals and data between the CPU and other components. Components not directly attached to a motherboard connect via sockets. And sockets are the architecture of pins that allow CPU installation. Welcome to Data Processing and Storage. After watching this video, you will be able to recognize the role of memory in a system, differentiate between memory slots and expansion slots, and evaluate the importance of the BIOS and CMOS. The CPU is a silicon chip in a special socket on the motherboard. CPUs contain billions of microscopic transistors on a single computer chip. These billions of transistors enable the computer calculations needed to run programs available in your system's memory. A 32-bit CPU is a processor architecture that can transfer 32 bits of data per clock cycle. Think of a 32-bit CPU as a two-lane information highway. 32-bit processors are found in laptops, workstations, and servers. A 64-bit CPU is comparable to a four-lane information highway, enabling twice the amount of data to move compared to a 32-bit CPU. 64-bit processors are also found in laptops, workstations, and servers. Random access memory, or RAM, temporarily stores working data and machine code. Because RAM is volatile, any data existing in RAM is lost when power is terminated. RAM is cold pluggable or cold swappable. Cold pluggable or cold swappable means that the hardware is off or that the hardware is in a state of being without power. RAM speeds are measured in megahertz or millions of cycles per second. Currently, RAM speeds can range from 1333 MHz to speeds of 2133 MHz. RAM is available in several forms of varying speeds and storage capacities, depending on your type of motherboard and needs. The memory you use depends on your motherboard type. Common forms of memory include the following. Dynamic Random Access Memory, or DRAM, stores each bit of data in a memory cell, usually consisting of a tiny capacitor and a transistor. SDRAM, or Synchronous Dynamic Random Access Memory, is a form of DRAM semiconductor memory that can run faster than DRAM. Double Data Rate Synchronous Dynamic Random Access Memory, or DDR SDRAM, is faster than SDRAM because it fetches data twice per clock cycle. Double Data Rate 3 Synchronous Dynamic Random Access Memory, known as DDR3 SDRAM, is faster than DDR SDRAM. And Double Data Rate 4th Generation, or DDR4, is a faster, more reliable replacement for DDR3 SDRAM that uses less power. And Small Outline Dual Input Memory Module, or SODIMM, chips are commonly used in notebooks since there is a lack of space. SODIMM slots take half the space of desktop slots, but they draw more power. A memory slot holds a RAM, random access memory stick in place on a computer's motherboard. Only memory chips can fit into these dedicated slots. Memory slots allow the system to use RAM by enabling the motherboard to communicate with memory. Depending on the motherboard, there will be 2 to 4 memory slots, sometimes more on high-end motherboards. The memory slots on the motherboard determine the type of RAM that's compatible with a computer. Older machines used the original Peripheral Component Interconnect, or PCI, expansion slots. Newer motherboards use the PCI Express, known as PCIe. These slots hold expansion cards designed to provide additional features to a computer, such as enhanced sound, memory, high-end graphics, and network interfaces which can be wired or wireless. The computer's motherboard determines which additional capabilities are available based on the additional slots. The disk controller is a circuit that enables the Central Processing Unit, or CPU, to communicate with a hard disk, floppy disk, or other kinds of disk drives. The Integrated Drive Electronics, or IDE disk controller, was a standard created for communications between the CPU and hard drives in computers. An IDE controller exists as a small circuit board on the motherboard, with chips that guide how the hard disk drive stores and accesses data. Most controllers include some memory that boosts hard drive performance. The BIOS, Basic Input-Output System, manages your computer's exchange of inputs and outputs, mostly when you're booting up your computer. Every computer has a BIOS pre-programmed into its motherboard. It's different than an operating system that can be installed, uninstalled, and updated long after you've bought the computer. When your computer is unplugged, the BIOS remains operational and relies on a battery for power. Such batteries exist in laptops and desktop PCs, but it's used more frequently in a laptop because laptops are usually unplugged longer than desktop PCs. You can update a BIOS through a process called flashing. To do this, you need the BIOS version number. You can find the BIOS version number in the System Information window. In Windows 10, press the Windows key +R, type MS-INFO32 into the run box, and press Enter. The BIOS version number is displayed in the BIOS version date field. The directions on how to flash the BIOS differ among motherboard manufacturers, so check the manufacturer's website for their procedure and proceed with caution. CMOS is short for complementary metal oxide semiconductor. A CMOS battery is a coin-sized battery similar to a watch battery that is installed on the motherboard to power the CMOS memory chip. The CMOS memory chip stores a computer's hardware settings. Like all batteries, CMOS batteries expire, and when the battery expires, the system clock resets, and you'll need to replace the battery to restore the computer system time, date, and hardware settings. In this video, you learned that internal computer components include everything connected to the motherboard. A motherboard provides a communication pathway for peripherals. A memory slot holds RAM in place on a computer's motherboard. The computer's BIOS is pre-programmed into the motherboard and uses CMOS to store configuration settings. And you can replace the CMOS battery to restore configuration settings. Welcome to Internal Storage. After watching this video, you will be able to describe general hard drive characteristics, identify characteristics of PATA drives, IDE drives, SATA drives, SCSI, and SSD drives, describe the general characteristics of optical drives, and identify expansion slots. Introduced by IBM in 1956, internal hard drives provide non-volatile long-term data storage, fast access time, and fast data transfer rates. Traditional hard drives contain a platter or disk with a magnetic surface where data is stored. The platter rotates on a spindle which controls the speed of the platter's spin. The metallic head floats just above the platter where it can read and write magnetic data. The head is at the end of an actuator arm that positions the head to read or write data on the platter. Together, the spindle, actuator arm, and head are controlled to read and write a specific task on the disk. Data that is read or to be written reaches the drive using a combination of power connectors, data connectors, jumpers, and other technologies that trigger the actuator arm. The actuator arm positions the head to read and write data from the disk. The power connector provides power to the hard drive. The data connector provides the connection to pass input and output to the drive. And in some cases, the drive can be configured with jumpers to enable specific types of settings. Advanced technology attachment hard drives, known as ATA drives, including integrated drive electronics or IDE drives and parallel advanced technology attachment or PATA drives, originated in the 1980s and were popular until about 2003. The early ATA drives processed data at 33 megabits per second. Later, ATA drives processed data at 133 megabits per second. In 2003, Serial Advanced Technology Attachment, or SATA drives, which communicate using a serial cable and bus, advanced data processing to 1.5 gigabits per second, more than 10 times faster than an ATA. Currently, SATA drives can process data at 6 gigabits per second. SATA drives are available in multiple sizes, known as form factors. SATA drives typically spin at 5,400 or 7,200 revolutions per minute or RPMs, with capacities from 250 gigabytes to over 30 terabytes. SATA drives still dominate today's desktop and laptop market. Each SATA port supports a single drive. Most desktop motherboards have at least 4 SATA ports. Small Computer System Interface, pronounced SCSI hard drives, joined the storage market in 1986. SCSI drives were fast, working at 10,000 or 15,000 rotations per minute or RPM. At the time, SCSI drives accessed data much faster than standard ATA drives. SCSI drives began to be discontinued around 1994 and are no longer used. Solid-state drives, known as SSDs, which store data on non-volatile flash memory, joined the hard drive market in 1989. SSDs provide significantly more reliability and are faster than traditional drives. SSDs operate at speeds of 10 to 12 gigabytes per second. Speeds vary by manufacturer and form factor, and SSD drive capacity ranges from about 120 gigabytes to 2 terabytes. SSDs cost more than equivalent SATA drives. However, SSDs provide significantly more reliability than traditional platter-style hard disk drives. SSDs are also available as external drives and hybrid hard drives. As part of a hybrid drive configuration, the SSD serves as a cache and the SATA drive functions as the storage disk. Hybrid drives tend to operate slower than SSD drives. Next, optical drives, which use compact discs or CDs and digital versatile discs, known as DVDs, were invented in the 1960s and came to market in 1992. These drives, like SSDs, provide non-volatile storage. Optical drives use low-power laser beams to retrieve and write data, encoding data for storage onto the laser disc in tiny pits arranged in a spiral track on the disc's surface. CDs are suitable for small capacity storage up to 750 megabytes. DVD storage ranges from 4.7 gigabytes to 17.1 gigabytes. CDs and DVDs can be read-only or read-write compatible. CDs are single-sided, but DVDs can be either single or dual-sided. CDs are created using universal read-write formatting. DVD player formatting happens by region. Media providers can encode DVDs to match the players located in the regions where the content is licensed. Blu-ray discs, as media for movies and video games, provide high-resolution and digital surround sound content. Blu-ray discs exist in single-sided formats, from single-layer up to quad-layer, storing 25 gigabytes per layer. Writable Blu-ray discs also exist in triple-layer 100 gigabyte and quad-layer 128 gigabyte formats. These require BDXL-compatible drives for writing and reading. Expansion slots, when available on the motherboard, are locations where you can add additional storage capabilities. In this video, you learned that internal hard drives provide non-volatile long-term data storage, fast access time, and fast data transfer rates. SATA drives still dominate today's desktop and laptop market, providing larger volumes of less expensive data storage. SSDs, comprised of non-volatile flash memory, provide fast data access but are more expensive than traditional SATA drives. Optical drives provide portable non-volatile data storage. And Blu-ray discs meet the demands for high-quality video and audio and can be copyright protected by region. Welcome to Display and Sound Cards. After watching this video, you will be able to define what a video card does, explore the function of sound cards, and evaluate the use of a MIDI controller. A video card is either an expansion card in an empty slot on the motherboard or a chip built into a system's motherboard. It allows the computer to send graphical information to a video display device, such as a monitor, TV, or projector. A video card is alternatively known as a display adapter, graphics card, video adapter, video board, or video controller. A graphics processing unit, or GPU, is a specialized processor originally designed to accelerate graphics rendering. GPUs can process many pieces of data simultaneously, making them useful for machine learning, video editing, and gaming applications. Although GPUs are normally associated with the realistic graphics found in top-quality video games, several industries rely on their powerful processing capabilities. An audio card is also known as a sound card. It's an integrated circuit that generates an audio signal and sends it to a computer's speakers. The sound card can accept an analog sound, as from a microphone or audio tape, and convert it to digital data that can be stored in an audio file. Conversely, it can accept digitized audio signals, as from an audio file, and convert them to analog signals that can be played on the computer's speakers. On personal computers, the functions of a sound card are usually directly integrated into the motherboard. But for users who desire higher quality audio, a sound card is a separate circuit board that is plugged into the motherboard. A MIDI controller is a simple way to sequence music and play virtual instruments on your PC. It works by sending MIDI, musical instrument digital interface data, to a computer or synthesizer, which then interprets the signal and produces a sound. MIDI controllers are frequently used by musicians. In this video, you learned that video cards, also known as graphics processing units or GPUs, display data. Audio cards process sounds input into the computer and send signals to internal and external speakers. For most users, integrated audio is all that's needed for meetings and listening to podcasts, videos, and music. Dedicated sound cards allow for more than one input, enabling the computer to process musical instrument digital interface, or MIDI, controller input. And musicians use specialized MIDI sound cards to record sounds from digitally enabled musical instruments onto computers and process those sounds as output. Welcome to Network Interface Cards. After watching this video, you will be able to define a network interface card, or NIC, explore the types of NIC, and apply your understanding of how a modem functions. A network interface card, or NIC, is a hardware component without which a computer cannot connect to a network. It is a circuit board installed in a computer that provides a dedicated network connection to the computer. The card receives network signals and translates them into data that the computer displays. Originally, network controllers were available only as expansion cards that could be plugged into a computer port, router, or USB device. A NIC, or Network Interface Card, provides a connection to a network, usually the Internet. On-board NICs are built into the motherboard, and add-on NICs fit into an open expansion slot on the motherboard. In terms of function, speed, and quality, there's no significant difference between the types of NICs. Wireless NICs rely on an antenna to communicate through radio frequency waves on a Wi-Fi connection. Wired NICs rely on an input jack and a wired LAN technology, such as fast Ethernet. On a basic level, your modem gives you access to the Internet. From Wi-Fi routers to mobile devices, the components that make up your home network all speak different digital languages, but your modem is the translator. It translates the signals coming from your Internet Service Provider, or ISP, into an Internet connection for your Wi-Fi router to broadcast. The modem receives information from your ISP through the phone lines, optical fiber, or coaxial cable in your home, depending on your service provider, and converts it into a digital signal. Your router and ISP can't communicate directly because they speak different languages, or rather, they transmit different signal types. So the modem digitizes those signals and sends the now usable signals to the router. Before you know it, you're online. In this video, you learned that a Network Interface Card, or NIC, is a hardware component that can be built in or added to a motherboard. A NIC connects a system to a network, often the internet. NICs can be wired or wireless. Onboard network cards are built into the motherboard, whereas add-on cards are placed into an expansion slot on the motherboard. And a modem transforms digital information from your computer into analog signals that can be transmitted to a network, and it translates incoming analog signals back into digital data that your computer can understand. Welcome to Cooling and Fans. After watching this video, you will be able to define system cooling, explore the methods of cooling a computer system, and evaluate the effectiveness of liquid cooling. Computers generate heat. Excessive heat can damage internal components. You should never operate a computer without ensuring there is a proper cooling system, air or liquid, installed. Central Processing Unit or CPU coolers are designed to dissipate heat produced by the processor that sits at the heart of your PC. The fans, radiators, and other elements in these cooling components allow the accumulated heat energy to flow away from vital internal parts. There are many cooling methods available. Passive cooling slows the speed at which a component, such as the processor, is operating. This approach contrasts with active cooling, which involves using powered fans instead. Fans in the computer case draw cool air through front vents and expel warm air through the back. In this process, the fans are used to dissipate warm air from delicate internal components. In forced convection, the hot air around an object, such as the Central Processing Unit or CPU, is moved away by a fan blowing air across a heatsink. Thermal paste and a base plate rest between the water block and CPU to help improve the heat transfer properties. One approach to system cooling is to use a heat sink. First, add a heat sink compound to fill gaps between the CPU or Central Processing Unit and other heat-generating components and the mechanical heat sink. Then place the heat sink, which is a passive component made of a conductive metal, over the CPU. Now excess heat is drawn from the CPU through the heatsink to its fins, where a fan blows air to dissipate the excess heat. This method dissipates warm air before it can harm components inside the computer. Liquid cooling works very much like a radiator in your car or home. It's quieter and more efficient than using fans to cool your system. Liquid cooling circulates liquid through water blocks, which rest on top of the chip that is being cooled. The relatively cooler liquid circulating through the water block pulls the heat away from the chip, cooling it. The heated fluid is pumped to the radiator where fans expose it to cold air. The re-cooled fluid is then returned to the water block to be heated, and the cycle repeats. Sometimes liquid cooling is a necessity. PCs used for high-end gaming and places where the ambient temperature is high require augmented cooling measures. Liquid-based cooling methods help in these cases. In this video, you learned that system cooling refers to one of several methods of keeping the internal components of a computer from overheating. Those methods include use of a heatsink and thermal compound, the transfer of heat away from internal components by convection, the use of fans, and liquid cooling. And liquid cooling is quieter and more efficient than fans, but it costs more and comes with the risk of water leaking inside your computer. Welcome to installing the Microsoft Windows 10 operating system. After watching this video, you will be able to list Windows operating system installation prerequisites and identify Microsoft Windows 10 operating system installation steps. Before you begin the installation process, you'll want to confirm the base Windows operating system is available on the computer's hard drive. You'll also want to connect the computer to an electrical source. Let's get started. First, select the installation language, time and currency format, and keyboard or other input language settings and click Next. Then click Install Now. Skip the activation step by clicking I don't have a product key and click Next. You will need a Windows activation key to receive operating system security updates and bug fixes. Select Windows 10 Pro to include all the operating system features and click Next. Click the checkbox to accept the license terms and click Next. Select Custom Install Windows Only Advanced. This option installs Windows for the first time or removes all previously installed operating systems. Accept the default disk partitioning settings and click Next. Now, you have to wait for this part of the installation process to complete. The computer may restart at the end of this process. Scroll the drop-down list to locate the region where the computer will be used. In this demo, we select the United States as the region and click Yes. Now select your keyboard layout. We'll choose the US keyboard and click Yes. Bypass adding a second keyboard layout and click Skip. Next, you'll choose between setting up Windows for an organization or for personal use. In this video, we'll select Setup for Personal Use and click Next. Now, you can associate a Microsoft account with the computer, but we're going to bypass this step and select Offline Account. Then click Next. Windows will remind you to opt in for a Windows account to access apps and services. For this installation, select Limited Experience to stay offline and click Next. Now type a username that specifies who will use the PC and click Next. Create a password for the user. In this demo, we set password spelled $$W0RD as the password for the account. In real life, however, follow good password practices to create passwords that are not easily guessed. And click Next. You'll type the password again to confirm the password and click Next. But don't worry, if you forget the computer's password, you can recover use of the machine by answering the security questions. Using the drop-down options, create 3 security questions for the account and click Next each time. Now, set the toggle switches to Yes to permit Microsoft capabilities. These capabilities include speech recognition, device location, linking and typing, access to the user's geographic location, diagnostic data, and tailored experiences. Click Accept. Microsoft offers the option to synchronize activity history across devices, such as sharing information between a workstation at the office and a workstation at home. Click Yes to accept this feature. Next, you'll see an opportunity to enable the use of Cortana, Microsoft's digital assistant. You can click Not Now or Accept. After completing the prior installation steps, your workstation will take several minutes to complete the remainder of the steps. Then the workstation will shut down and restart. The next time you access the computer, you'll enter the username and password you specified during installation. And congratulations! After logging back in, you'll see the default Windows 10 desktop. In this video, you learned that before beginning the installation process, confirm that the computer is connected to an electrical power source. During the installation process, you may need to confirm which version of Windows you are installing. By selecting Offline Account, you can bypass associating your Microsoft account with the computer. You'll create a username and password and configure 3 security questions and their answers as part of your setup process. And after installation, you'll need to log in using the username and password you previously specified. Welcome to Microsoft Windows 10 Operating System Configuration. After watching this video, you will be able to describe how to create user accounts and use the Settings app to configure frequently updated operating system settings. Most operating systems allow the configuration of multiple levels of users with specific security settings. These include Administrator with full permissions, Standard User with most permissions except for system configuration changes, and Other Users with limited access. In this course, we will assume you have administrator permissions. Depending on the organization's rules, you might want to add one or more additional user accounts that do not include administrator permissions. This task is usually more conveniently completed before delivering the computer to the user. On the Settings window, select Accounts. Follow the on-screen prompts to add additional other users. You can even add users who do not have Microsoft accounts. You'll add the user's name, password, and answers to 3 security questions. Select Next, and the user account is automatically added. You'll want to show your user how to sign into their machine using their ID and password or PIN. Some organizations may have protocols for the user to change their password. Then begin adjusting operating system settings with the user present. As an IT support person, you may prefer to unbox the computer before its delivery to the user. You'll use the Settings app, a central location for many Windows configuration and management tasks, to personalize and customize the computer. One of the fastest ways to access settings is to select the Windows Start button and select the gear icon, which opens the Settings app. The Settings app is also a hub for many user-facing operating system settings. Communication protocols enable computers to communicate with each other, including internet communications, document sharing, and more. Standard protocols include Hypertext Transfer Protocol, or HTTP, which displays web pages, Transmission Control Protocol, known as TCP, a network protocol that enables software applications to communicate with each other, User Data Protocol, or UDP, which helps keep communications from chaining out, kind of like a dropped phone call, Internet Relay Chat, known as IRC, a historical text messaging platform, and communication permissions that allow computer users to talk to each other. The first question almost every user asks is, "Am I connected?" To join a wireless network, first select the wireless icon, then select your wireless network and enter the password. Your mobile devices can also use your computing device's internet connection as a mobile hotspot. Simply select the mobile hotspot icon within your wireless settings, then, on the mobile device, select your PC's mobile hotspot name. In addition, you can set connectivity using the Settings app. Select Network and Internet. Depending on how you opened the Settings app, the left pane may or may not display. Both views enable you to verify the computer's current connection status. To discover new networks, select Show Available Networks. To connect to a different network, select Connect and enter the network security key. Then select Next, and the workstation automatically adds and, if needed, connects to the network. View the status to confirm the workstation's network connection. You can also select the Wi-Fi icon on the taskbar to view current connections and add new connections. Here's how to adjust monitor display settings. Using the Settings app, select System. Scroll the display options to display the screen brightness, scale and layout, and screen orientation. If starting from Settings, select System. On the System window, scroll the left pane and select Sound. Here, you can choose your speakers, set the default speaker volume, and set the microphone settings. To add a printer or scanner, on the Settings app window, select Devices. Then select Printers and Scanners, and existing printers and scanners are displayed. If needed, you can select the plus add a printer or scanner, where you'll see additional connection options. Review the time and language settings with your user. Here, you can set region, language, and speech settings. If you have a user who wants to use speech recognition, you'll need to set up this capability here, in addition to configuring ease of access accessibility settings. On the Settings window, select Ease of Access to configure capabilities that help accommodate the needs of blind, colorblind, low vision, and deaf users who need computing enhancements. In this video, you learned that some organizations may require setting up additional user accounts that do not have administrator capabilities. You can use the Settings app to configure regional preferences, printers, networks, video, audio, accessibility options, and more. and ease of access capabilities accommodate the needs of blind, colorblind, low vision, and deaf users. Welcome to Microsoft Windows 10 Management and Performance. After watching this video, you will be able to describe disk configuration and management, explain storage and file and folder management basics, explain how to access the health report, and describe how to locate system maintenance. Preferred disk configurations vary by operating system platform. Windows computers generally use FAT32, NTFS, or HPFS configurations. Linux workstations use ext4, and Mac workstations use HFS+. Storage management goals are about optimizing performance, minimizing data loss, and maximizing disk use. You can quickly access storage management options via Settings and Storage. But remember, always back up your data before changing your disk configuration. Storage management capabilities include viewing storage usage on other drives, changing the storage destination, managing storage spaces, optimizing hard drives, and viewing data backup options. Disk management enables hard drive formatting and partitioning. Here's how. In the Windows taskbar box, type Disk Management and open the Disk Management app. Use the Disk Management app to perform disk formatting, partitioning, compression, and cleanup. To see the rules for how files are indexed, within the Settings app, select Search and select Searching Windows. Here you can set rules for how users find their files and which folders to exclude when users search for files. With the rules set, to search files and folders, open File Explorer. Within File Explorer, the ribbon bar displays commands to perform tasks such as opening, editing, copying, and moving, known as pasting and deleting files. Primarily managed through File Explorer, your hard drive configuration determines the allowable number of files and folders. The average user will not encounter limitations. Now, in the Windows taskbar box, type File Explorer Options to open File Explorer. Here you can set file and folder options to open folders within an existing or in a new window, to use a single-click or a double-click action to open a file, and to display recently accessed files and folders. A user might not need a program, or a program may not be permitted on the user's computer based on company policy. You can select Settings and then Apps, and in the Apps and Features section, locate the program and right-click on the program to select the Uninstall option. Most software originates from online sources, so before downloading software, verify that the website is legitimate. In most instances, to install the software, click the designated .exe file. Windows will request your permission to install the software. Simply follow the manufacturer's installation instructions. Now, Windows manages most operating system software updates automatically. To check the update status, using the Settings app, select Update and Security where you can view your Windows update status. If your user mentions that they're having issues with the system performance, open the Settings app, enter the word Performance, and select Device Performance and Health. When viewing device performance and health, the Health Report displays the status of Windows time service, storage capacity, battery life, and apps and software. If needed, use the Settings app, search for System Maintenance, and select the second option to troubleshoot and help prevent computer problems. Then, follow the on-screen instructions to help maintain the computer. In this video, you learned that Windows computers generally use FAT32, NTFS, or HPFS configurations, while Linux workstations use ext4 and Mac workstations use HFS+. The Disk Management app enables disk formatting, partitioning, compression, and cleanup. You can go to Settings and select Storage to change storage destinations, optimize drives, set access data backup options, and more. And you can use File Explorer to set folder options, such as whether to open folders within an existing or new window, whether to single-click or double-click to open a file, and whether to display recently accessed files for quick access. You also learned that the Health Report displays the status of the Windows time service, storage capacity, battery life, and apps and software. And System Maintenance provides troubleshooting capabilities to help keep your computer running smoothly. Welcome to Managing Files and Folders. After watching this video, you will be able to define files and folders, explore the basic options for files and folders, and evaluate security permissions for files and folders. A computer file is a resource for recording data in a storage device primarily identified by its file name. Just as words can be written to paper, so can data be written to a computer file. A file is created first by writing data into temporary memory or RAM. Saving data involves using permanent storage, usually a hard disk drive. All files are either binary or text in nature. While text files contain only textual data that can be read easily, binary files contain textual and custom binary data. Data in binary form can be interpreted by supporting programs, but will show up as garbled text of ones and zeros in a text editor or word processing program. Files and folders have similar naming rules. Both should be named so the file or folder you want is easy to find. Names should be short but descriptive, 25 characters or less. Avoid using special characters or spaces in a file name. Use capitals and underscores instead of periods, spaces, or slashes. And to make names easier to remember, you can use a date format such as 4-digit year, 2-digit month, and 2-digit day, and/or include a version number. A folder is a container for data written to disk. While drives store files, folders are used to organize those files by creating distinct logical areas with different security privileges. Folders separate the operating system or OS and application files from user data. Folders also organize user data belonging to different accounts. In Windows, there's no limit to the number of folders within folders or subfolders you can create. A file path is also known as the path name. It's the precise location of a computer, file, device, folder, or web page. For example, C Windows System 32 tells the user that the System32 folder is in the Windows folder in the C drive. In Windows, you can choose from these commands: Edit to create an updated file or folder, Save to preserve a copy of the file or folder to disk, Cut to place a file or folder temporarily onto the clipboard, and from there the file or folder can be copied or moved to a new location. Copy, similar to the Cut command, also places a file or folder temporarily on the clipboard, and from there the file or folder can be copied to a new location. And Move, to place a file or folder in a new location. An extension is the final part of the file name that follows a period. For example, letter.docx. The extension .docx indicates the file letter is a MS Word document. The file extension shows the file type and which applications can be associated with different actions, such as open, edit, and print. In this case, the related application is MS Word. Additional file extensions can be researched using the Internet. To create a file, right-click inside a folder or on the desktop. Select New, and then select the application you want. But you'll have to name the file to complete this brief process. Opening a file is just as simple and quick. Either double-click it or right-click it, select Open With, and select the appropriate application. When you create a file, you'll need to choose where you want to save it, for example, the desktop. To do so, select File, then Save As. Choose the location for the new file, and once you've saved a file to the proper location, just select the Save icon or File, then Save. To open or launch a program, just double-click the icon associated with it. Another option is to select the icon and press Enter. Deleted items are kept in the recycle bin and can be recovered by right-clicking an item in the recycle bin and selecting Restore. A file or folder typically can't be recovered if the recycle bin has been emptied, or if you press Shift+Delete when removing something. There's no recycling for items on flash drives or network shares, although a server administrator might be able to recover those files. To select multiple files and folders, click and drag the mouse to highlight them, press the Control key and select items individually, or press the Shift key and select the first and last file you wish to affect. All files between the first and last selected will become highlighted. To find folders and files, follow these steps. Right-click the Start button and type the item name in the search field, or use Cortana to find matching files, programs, apps, messages, and web pages on your system. Alternatively, you can use Windows Explorer to search by file name, file contents, file date, or size by selecting the folder icon on the taskbar. Windows Explorer, or Explorer, is a tool that you can use to manage your files on OneDrive and your PC. To rename a file or folder, right-click it and select Rename. Do not change the extension unless you mean to do so, as that can render the file inoperable. The File Properties dialog box has options for a file or folder. To access the properties of a file or folder, right-click it and select Properties. The window will give you information about and additional control over a file or folder. For security purposes, files and folders have attributes that can be set to read-only, system, hidden, or archive. Read-only allows you to view but not edit a file or folder. The read-only attribute prevents changes from being saved back to the file. You will be prompted to create another file containing the modified data. System attribute specifies that the file should not be accessible to ordinary users. A Windows system file is any file with the system attribute turned on. Windows depends upon system files to operate properly. The hidden attribute specifies whether the file is visible in the default view. It is possible to adjust Windows to display hidden files and folders, though. And the archive attribute shows whether a file has been changed since the last backup. Compression, or zipping, saves disk space by reducing the size of an item. Here's how to do it. Right-click the file or folder, select Send To, and then Compressed or Zipped folder. A new zipped folder with the same name is created in the same location. You can use encryption on files and folders for security purposes. Right-click the folder or file you want to encrypt and select Properties. Select Advanced. Under Compress or Encrypt attributes, check the box for Encrypt contents to secure data. Then click OK and click Apply. Setting permissions is another means to control what can be done with a file or folder. To change these permissions, right-click any folder or file and select Properties. Then switch to the Security tab and make your selection. In this video, you learned that files are organized data in a specific format. That data may exist in memory, a permanent storage capacity, or both. Folders are digital containers for files. Folders are used primarily for file storage and organization. Files have numerous extensions that identify the file type and which program or programs can open them. Files and folders have a variety of options to manage them. And files and folders have native encryption options in Windows for security purposes. Welcome to Evaluating Computer Performance and Storage. After watching this video, you will be able to identify the 4 key processor performance criteria, evaluate random access memory known as RAM availability, assess a computer's storage capacity, and evaluate network speeds and identify common connectivity issues. The following 4 components contribute to performance: the processor's speed, the number of cores, the bus types and speeds, and the presence of cache. Processor speed, a primary computing measurement, is measured based on electrical clock speed in units of time referred to as hertz. Older devices measured processor speed in megahertz, but today's computing resources measure in gigahertz and even greater speeds. Faster processor speeds usually mean faster task completion. Cores located in the center of the CPU can process data together or separately. While current CPUs can have up to 64 cores, most processors offer between 2 and 8 cores. Core speeds, called clock speeds, are based on the speed the CPU runs internal processes and accesses its cache. Next, processors can have multiple cores. The presence of more than one processor or core on the same physical platform is known as symmetric multiprocessing, or SMP. Multiple cores can process tasks together or independently, and many current personal computers offer 4 or more cores. More cores can equal faster computer performance, but that outcome is task-dependent. Next, buses located on the CPU's perimeter act as the data highway from the processor to the components. Historically, computers had 3 bus types. The address bus, which transports memory addresses from the processor to memory and sends and receives memory address information from the CPU, primary storage, and input-output devices. The data bus, which transports data to and from the processor, the CPU, and input-output devices. And the control bus, which transports control signals from the processor to memory and input-output devices. New technology such as Quick Path Interconnect, PCI and PCI Express, Hypertransport, and others are replacing traditional buses. When available on the CPU, cache memory buffers information and speeds tasks, which can help offset slower processor speeds. Many desktop computers and many laptops support traditional hard disk drives, solid-state drives, portable flash memory, and hybrid hard drives. In this chart, you can see that solid-state drives are the fastest storage option. Hybrid storage drives, new to the market, promise greater capacity while maintaining speed. To evaluate disk storage capacity and availability in Windows 10, on the taskbar, type this PC and press Enter. Then click Open. The window for this PC displays, and within Devices and Drives, view the available disk space. Next, Random Access Memory, known as RAM, provides temporary memory that enables computers to install software, display websites, display files, and process edits for files in memory before those changes are saved to storage. Upgradable on some computers, RAM is currently available in gigabyte increments. When machines run out of RAM, you'll experience screens that freeze or stop working, browser tabs that error and close, out of memory and other on-screen errors, corrupted files, computer beeping sounds, and other errors including the infamous blue screen of death. When RAM errors happen, you'll want to check RAM usage. On Windows 10 computers, in the search box on the taskbar, type Task Manager. Select the Performance tab and view the Memory section. You'll also want to check the computer for hardware failures. In the Windows taskbar search field, type Windows Memory Diagnostic. Follow the prompts to run the diagnostics. When the diagnostic tool runs, hardware-related memory errors, if they exist, are displayed on screen. If indicated, upgrade or replace the RAM. Network speed, known also as throughput rate, is commonly measured in bits per second, although sometimes you will see measurements in bytes per second. Most network processing is measured in megabits per second or gigabits per second. A speed test is one of the fastest ways to determine connectivity. Open a web browser, search for speed test from your internet provider or from a trusted organization, such as Ookla at speedtest.net. Follow the on-screen instructions to test and view your results. What if the machine is not connected to the internet and you want to determine if the machine is connected to a wireless network? Click the wireless icon in the taskbar tray, click Properties to view your wireless network connection, and scroll to the Properties heading and view your link speed. If the computer is connected to the network using an Ethernet cable, you can check its connectivity via Ethernet settings. In the Windows taskbar search box, type Ethernet settings and click Open. Scroll the settings window to the Properties section and view your link speed. In this video, you learned that evaluating processors is a 4-part process based on the processor speed, the number of cores, bus types and speeds, and available cache. Determining used and available storage space is a fast process on Windows computers. When evaluating RAM, check its usage and check the computer for hardware errors. An online speed test is a fast network speed assessment method. And a computer's Ethernet settings is a quick method of checking a connected computer's network access and speed. Welcome to Workstation Evaluation and Setup. After watching this video, you will be able to identify the user's computing needs, evaluate computers based on their hardware specifications, and perform basic hardware setup tasks. Let's begin evaluating the user's workstation requirements. First, identify the user's job location. Does the user work on-site at an office, work from home, work mobile from a job site or a client site, or work at multiple locations? Once you know where the user works, what are their workspace conditions? Do they have access to a desk and chair? How many electrical connections are available? What kind of lighting does the workspace have? How will the user secure the computer? And finally, does the user have accessibility needs that require additional hardware? Today's work relies on connectivity. If the job function is highly confidential or is moving large amounts of data, a wired network connection might be required. Most users can use a Wi-Fi connection, but users who are away from an office and need to maintain connectivity will need access to a cellular network. Next, will your user store their data on their local machine, within an on-site network of servers, or using hybrid cloud? Applications have memory and storage requirements. Based on the cumulative number of applications, what are the storage, RAM, connectivity, and backup requirements? To meet company or job requirements, or to accommodate user accessibility requirements, users might need peripheral devices, including additional keyboards, mice, monitors, speakers, headphones, microphones, and scanners, among others. You'll need to know what connection types these peripherals require before shopping for the user's new computer. Desktop units generally provide the most versatile and powerful computing solutions. However, laptops are powerful enough for most tasks, including some big data-related tasks. For users who work for multiple locations or work primarily with cloud-based applications, laptops and 2-in-1 laptop-tablet combinations often are more appropriate and cost-effective. This table displays some minimum specifications you'll want to keep in mind when shopping for your user's new workstation. In most instances, 16 gigabytes of RAM is adequate. However, power users may need an upgradable solution, and web and cloud-based users may be able to work with a minimum of only 8 gigabytes of RAM. Users who work with big data and graphic-intensive design processes usually need a machine with a more powerful and possibly upgradable GPU and storage, adequate ports and peripheral connections, connectivity options, and the ability to physically secure and lock the computer. Purchasing decisions then weigh 4 important considerations: user requirements, business requirements, available technology, and the company's budget. After the purchasing decision is made and your user's new workstation arrives, the following 6-step process facilitates successful workstation setup. First, reassess your user's physical environment. Next, follow the instructions to unbox the workstation and any peripherals. Then, follow recommended cable management practices. Connect the workstation and peripherals to the appropriate electrical outlet or a power strip. Recheck the user's ergonomics, and complete the workstation setup by configuring the workstation hardware and software. When you arrive with the new workstation, begin by assessing the user's environment, including the sturdiness of the desk and chair. the availability of work-appropriate lighting, electrical outlet access and outlet amperage, and the ability to physically secure the computer. When unboxing, read the instructions and follow the manufacturer's practices. As you unbox the equipment, move boxes and packing materials into a safe location, out of the user's workspace. A part of environmental safety, cable management also reduces support calls. Here are 3 easy-to-remember practices. Install shorter cable lengths when possible. If you have an extra long cable, loop the cable and use a zip tie to secure the cable into its shorter length. Securely attach and identify each cable as you work, and collect and tie multiple cables together out of the way of the user. Electrical management is about safety for you and your user. Label each electrical cable connected to each computing device for peripherals. Then verify that the electrical connections are away from the user and are accessible for later IT support. Connect power supplies to their assigned wall or power strip location, and remember to note the wall outlet number. New computers often require ergonomic adjustments so that the user can work comfortably. Check the user's foot placement, monitor height, arm placement, shoulder placement, lighting, and cord and cable placement. Next, it's time for workstation setup. Power on the workstation and peripherals. Then set up the user's operating system options, including user logon credentials, keyboard options, monitor resolution, printer connections, sound options, security options, and network connections. Next, select the user's default browser. Uninstall unnecessary software. Install and configure additional productivity software, and if the user requests, modify their desktop productivity pane and set up backup options. In this video, you learned that job needs, location, connectivity, and accessibility are essential user considerations. Ranking user requirements, the company's requirements, current technology offerings, and the company's budget are factors that determine which device is purchased. And workstation setup can be summarized as a 6-step process. Welcome to Screen Captures and Tools. After watching this video, you will be able to describe 3 keyboard commands you can use to create screen captures on a Mac OS computer. Identify 3 keyboard commands you can use to create screen captures on a Windows 10 computer, and name 2 keyboard commands used when capturing screens using a Chromebook. There are 3 ways to capture a screen on a Mac OS computer: Command plus Shift plus 3, Command plus Shift plus 4, and Command plus Shift plus 5. To capture an entire screen, select Command plus Shift plus 3. To capture just part of a screen, select Command plus Shift plus 4. You'll also need to apply a drag and release motion when you've included the screen portion that you wish to capture. Note that these first 2 screen capture options automatically save images in a PNG format to the desktop folder. Options and capabilities for Command plus Shift plus 4 include the following: to create a screenshot with a white border around the window with a bit of a drop shadow, press and release the spacebar and release the mouse or trackpad. To adjust the location of the screen capture area, press and hold the spacebar and drag the capture area to where it's needed. Then release the mouse or trackpad when the screen capture area is in the correct location. To adjust the bottom edge of the capture, hold down the Shift key as you move the bottom edge to the desired location, then release the mouse or trackpad. To capture part of a screen or an entire screen as a photo or video, select Command plus Shift plus 5. The displayed options enable you to select the entire screen, a window, or a part of the screen and capture it as an image or a video. After recording, select the location to save your image or a video capture. Microsoft Windows 10 provides the following screen capture capabilities. To capture an entire screen, select Windows key plus Print Screen. The Windows key may have the Windows logo or say Win, short for Windows. After you use this keyboard shortcut, Windows automatically saves your image in a PNG format to the Pictures/Screenshots folder. To capture only your active window, select Alt plus Print Screen. The screen capture exists on the clipboard. Next, open an image editor to view and save the image. The default screen image format is PNG. For more screen capture options, select Windows key plus Shift plus S. This keyboard shortcut opens the snip and sketch tool. The displayed options enable you to select the entire screen, a part of the screen, or your active window. To capture an entire screen, select Control plus Show Windows. Note that the Show Windows key looks like a rectangle with two lines on the right side. To capture a partial screen using the keyboard, select Control plus Shift plus Show Windows. Click and drag the crosshair icon until the part of the screen you want to capture is highlighted, then release the mouse or trackpad. Note that each of these screen capture methods saves your image in a PNG format. Depending on the installed Chrome operating system version, your image might display in a pop-up window. Clicking on the notification will open the Chrome OS Files app. But if you don't see your image display, all screenshots are saved as PNG files and stored in the Downloads or Google Drive folder. In this video, you learned that each operating system platform provides full and partial screen capturing capabilities through keyboard commands. The default image file format for all three platforms is a PNG file format. And the OSs differ in how they save screen captures. Mac OS saves images by default to the desktop. Windows 10 automatically saves images to the Screenshots folder. And Chrome saves images in the Downloads folder or to the online Google Drive of the logged-in account holder. Welcome to Introduction to Troubleshooting. After watching this video, you will be able to describe basic computer support concepts, describe troubleshooting procedures, leverage sources of support, and summarize the CompTIA troubleshooting model. Effective computer support involves three basic concepts: determining the problem, examining the problem, and solving the problem. It's hard to fix something if you don't know what's wrong, so you first need to determine the problem. Ask users questions and discover if the hardware or software has been changed in any way. Next, try to reproduce the problem and note symptoms. If there is more than one problem, then you should address each problem separately. Do not let yourself get overwhelmed or off track. Do what you can to collect information about the reported problem, including common symptoms. Once you've determined the problem, examine it more closely. The better you understand the problem, the easier it will be to choose the best solution. Here are some tips for examining the problem. Consider the simplest explanations, such as improper settings or even incorrect use of the hardware or software. For example, the source of the problem may be as simple as the power cord being unplugged. Consider all the possible causes of the problem and address them one at a time. Try different troubleshooting methods until you find one that works. And once you have a theory, test it. And if necessary, bring the problem to a higher level support person or another department. Okay, now that you are familiar with the problem, you can solve it. At this stage, you should create a plan for addressing the problem and document the process for carrying it out. Documentation will help you track the steps that you follow and how effective they are. Once you have decided if you will solve the problem by repair, replacement, or both, carry out the solution. Let your documentation guide you so that you do not repeat steps. Record each step you take and include the results it produces. After you've carried out your solution, confirm that the system is fully operational, then update your documentation. Troubleshooting is a systematic approach to problem solving that is often used to find and correct issues with computers. The first step in troubleshooting is gathering information about the problem. Identify any undesired behavior or lack of expected functionality. Other steps in the troubleshooting process include duplicating the problem, triaging the problem, identifying symptoms, researching an online knowledge base, establishing a plan of action, evaluating a theory and solutions, implementing the solution, and verifying system functionality. To restore functionality, check the following. Check for signs of activity such as LEDs, the power light, and the typical sounds computers make when running. Check for the cause of 2 or more beeps. This step requires using the internet. Check the monitor controls and power if the screen is dark. And check connections on peripheral devices. Many issues occur regularly on a personal computer. Some examples include the following: loose cables or connections, power issues, physical damage, boot up problems at the BIOS level, or during the power on system test, or POST. POST is a program which runs on startup and verifies that everything the computer needs to properly boot up is there. Blue or black screen, operating system or OS problems, and software errors. Fortunately, many of these problems have simple solutions that you can quickly implement. If you need additional support, consider consulting the internet. A search engine such as Google, Bing, or DuckDuckGo can be an invaluable tool in your tech support kit. You can also look for online support such as driver downloads, as well as technical support community groups. Often, manufacturer-provided documentation is also available online. If you cannot find the help you need online, consider contacting the manufacturer's technical support. You can often find the contact information in the computer's manual. Before contacting support, ensure you have all documentation on the machine. You will likely be asked to provide them with the name of the hardware or software currently experiencing the problem, the device model and serial number, the date of purchase, and an explanation of the problem. The industry standard troubleshooting model comes from the Computing Technology Industry Association, or CompTIA. The CompTIA model includes the following steps. Identify the problem. In this step, you gather information, duplicate the problem if possible, question users, identify symptoms, determine if anything has changed, and approach multiple problems individually. Research the knowledge base or internet if applicable. Establish a theory of probable cause. In this step, you question the obvious, consider multiple approaches, and divide and conquer. Test the theory to determine the cause. Once the theory is confirmed, determine the next steps to resolve the problem. Or, if the theory is not confirmed, establish a new theory or escalate the problem. Establish a plan of action to resolve the problem and identify potential effects. Implement the solution or escalate as necessary. Verify full system functionality and, if applicable, implement preventative measures. And finally, document findings or lessons learned, as well as actions and outcomes. In this video, you learned that computer support concepts are specific and sequential. Troubleshooting procedures often begin with looking for common problems. Sources of support include online resources and the manufacturer's technical support. And the Computing Technology Industry Association, or CompTIA, has the industry standard troubleshooting model. Welcome to Advanced Microsoft Windows 10 Management and Utilities. After watching this video, you will be able to describe essential workstation management tasks, describe the purpose of drivers and how to update them, and identify 5 useful Windows utilities. Policy management applies rules for passwords, password retries, allowed programs, and other settings specific to the machine or group. Here's how to access policy management. Type Group Policy in the taskbar search box. The Edit Group Policy control panel option displays. Click Open. Select the user configuration settings to view its details and edit policy settings. Windows automatically schedules processes and allocates resources most of the time uneventfully. Sometimes, though, a task might stall and you need to end the task and stop the process. Open Windows Task Manager to view apps and their background processes. When you locate the troublesome software or process, select End Task to stop the process. Perhaps you want to verify the installation and performance of a new hard drive, or that the computer recognizes memory, or recognizes another computer component, such as an add-on card, which includes interfaces. In the Windows taskbar field, type Device Manager. Select Open to launch the Device Manager app. Scroll the list and you'll see the computer's hardware, components, and interfaces, such as the Intel Management Engine Interface number 1. Double-click to view the interface's properties. Here, on the General tab, you can confirm that the interface is working properly. You can also view events, evaluate resources, set power management options, update driver software, which works with the computer for external capabilities, update firmware, which is onboard device software, and view additional device details. Windows uses RAM for frequent memory tasks and virtual memory for less frequent tasks. If the computer's performance is slow or the computer is displaying low on virtual memory errors, it's time to take action. To evaluate memory performance based on the installed RAM hardware, open Task Manager and view the memory resource usage. If needed, run the Windows Memory Diagnostic. Sometimes an installed program needs more virtual memory. To manage virtual memory, select Settings and About, then begin typing the word Performance. Select the option to adjust the appearance and performance of Windows. The Performance Options window displays. In the Virtual Memory section, select Change. In most instances, Windows automatically adjusts virtual memory. If you do find that you need to adjust virtual memory, such as for a memory-intensive application, this is the Windows operating system location where you can adjust those settings. Service Management automatically handles background tasks. However, sometimes a program just won't close, or perhaps you see a program using so much memory that other programs can't run. Service Management enables you to troubleshoot and manage these situations. Capabilities include stopping the service, restarting the service, running a program, taking no action, and restarting the computer. Drivers are software components that enable communications between the operating system and the device. If a device suddenly stops working aside from a power issue or other hardware issue, it's possible that the driver is outdated. Perhaps a printer suddenly stopped working because the printer needs a new driver to communicate with the computer. To update or configure a new driver, access Windows Device Manager, locate your device and right-click to view the device's details. If needed, select Update Driver. Utilities help you administer and manage the operating system. Windows Diagnostics locates hardware memory errors. Windows Performance Monitor provides performance details for processes, applications, and hardware. Windows Event Viewer provides detailed activity logs to diagnose errors, installation problems, and other issues. Windows Registry Editor enables the correction of embedded software registration information, such as the disk location for a program's files. And Windows Task Manager enables the viewing and management of machine tasks that help you troubleshoot errors and enhance performance. In this video, you learned that policy management decisions enhance security. You can use Windows Task Manager to view apps and their background processes and select End Task to stop software processes. Windows Device Manager helps you verify that computer devices, components, and interfaces are working correctly. Service Management automatically manages background tasks and enables advanced troubleshooting of performance issues. And 5 useful Windows utilities include Memory Diagnostics, Performance Manager, Event Viewer, Registry Editor, and Task Manager. Welcome to Introduction to Business Continuity Principles. After watching this video, you will be able to describe the importance of business continuity, evaluate a fault-tolerant system, and explain the importance of disaster recovery plans. In today's technology-reliant world, you must understand some basic risk management strategies to deal with disruptions so productivity issues are minimized. That's where something known as business continuity comes in. Business continuity is having a plan to deal with difficult situations so an organization can continue to function with as little disruption as possible. Whether it's a business or charity, all organizations must know how they can keep going under any circumstances. Business continuity is built upon fault tolerance. That's the ability of a system to continue operating without interruption when one or more of its components fail. Fault tolerance anticipates disruption and develops contingency plans. Fault tolerance designs systems without single points of failure, so if one part of a system goes down, it doesn't take down the entire system. The cost of a system outage is a crucial consideration of a business continuity plan. So is having a strategy to minimize the effects of system outages. This is known as redundancy. The broad categories of redundancy include system, network, and hardware. System redundancy augments the fault tolerance levels of the existing system. Network redundancy allows data to be rerouted to an alternate path until all systems are functional. And hardware redundancy serves as a solution to a disabled server. Redundancy, or replication, refers to the additional capacity of a computer network above what is needed for normal operation in the case of an outage or other disruption of operation. Think of it as a safety net for the almost inevitable system or component failure. It's having a backup system at the ready. There are 5 common types of redundancy. The first type of redundancy is data redundancy. It's implemented through backups. Data redundancy occurs when the same piece of data exists in multiple places. Unfortunately, data redundancy can cause data inconsistency, which can provide a company with unreliable and/or meaningless information. One example of this is to have multiple versions of the same file on a network. As such, real-time syncing of the data across all its backups is vital for all copies to be consistent with one another. The next type of redundancy is known as Redundant Array of Independent Disks, or RAID. RAID has 3 varieties and provides server hardware failover redundancy. RAID 0 allows a storage system to tolerate individual disk unit failures as the data is simultaneously written to more than one disk. In a RAID 1 system, there's an exact copy or mirror of a set of data on 2 or more disks. And in a RAID 5 group, there are a minimum of 3 hard disk drives, or HDDs, and no maximum. RAID 5 is considered one of the most secure RAID configurations. Network redundancy is the process of adding additional network devices and lines of communication to help ensure network availability and decrease the risk of failure. Some of the features of network redundancy are multiple adapter cards and/or ports for individual hosts, and load balancing, in which a networking solution is used to distribute traffic across multiple servers in a server farm. There are multiple network paths between nodes, and routers can detect failed links and choose to reroute data by finding alternate paths for it. Site redundancy is the ability to lose an entire site without losing signaling or application state data. It guards against total loss of operations due to a natural disaster or major network failure. This type of redundancy employs the process of replication to synchronize data among multiple sites and ensures data access. And power redundancy is having 2 independent power sources. If one power source has an interruption, the other source activates. This eliminates downtime from the loss of the primary power source. One way to augment a power redundancy scheme is to use an uninterruptible power supply, or UPS. A UPS adds a layer of protection if something as expensive as a backup power generator is not feasible. The point of backups is to create a copy of data that a business can restore from when a primary copy is damaged or unavailable, and have a specific and sequential strategy for backups that identifies key backup concerns and selects appropriate backup types based on needs and resources. Backups restore data. Backup methods include the following: full, which creates copies of all files; incremental, which copies only those files that have been altered since the last full backup; differential, which saves only the difference in the data since the last full backup; and daily, which keeps a backup of just those files that have been modified the same day the backup is done. A backup storage device is used to make copies of data that is actively in use. Backup media provide redundancy of data residing on primary storage. Should the primary storage medium, such as a hard disk drive or HDD, fail or become corrupted, the original data can be recovered from copies on the backup hardware. Examples of backup devices include a USB drive, an external hard drive, a local area network or LAN, and tape. A backup strategy must balance these considerations. Costs: you may have to buy hardware and software, pay for a maintenance agreement, and train your staff, and location. Many businesses back up to the cloud, but consider keeping a copy of your data in an additional location too, as cloud outages do happen. Businesses need to know the requirements of each backup approach in storage, cost, and time. These factors impact the length of the backup procedure and the recovery. Disaster recovery is an organization's strategy for restoring functionality to its IT infrastructure. This plan must explain the actions to be taken after a disaster. It involves strategies for specific scenarios to ensure continuity. A swift recovery depends on plans that are specific, imaginative, and comprehensive. And the choice of disaster recovery methods depends upon needs and resources. In this video, you learned that business continuity in the wake of unexpected outages relies heavily on planning. Fault-tolerant systems can continue operation despite outages. The choice of redundancy option and backup system depend on a business's needs and resources. And disaster recovery plans aim to resume operational functionality to a business after an outage. Welcome to the IBM Technical Support Professional Certificate. Did you know that industries worldwide depend more on technology now than ever before? That's because more people are using technology in their everyday lives, including working remotely, taking online classes, and even having health checkups with a doctor via webcam. With a worldwide increase in demand for technology comes an increase in need for user support for all technology-related needs. Who will provide technical support to individuals, companies, and organizations? Professionals who are knowledgeable in the fundamentals of computer hardware, operating systems, software, networking, storage, cybersecurity, and cloud computing. According to the most recent U.S. Bureau of Labor Statistics report, about 70,400 computer support jobs are posted annually in the U.S. alone, and job growth in the computer support industry is projected to increase 9% through 2030. At the time of this course publication, the median U.S. computer support specialist salary is $57,910 US annually, and per hour pay is almost $28 US. Technical support jobs are also a great way to start on your path to a high-paying career in information technology. This certificate consists of several engaging and informative courses designed to introduce you to the fundamentals of technical support as well as information technology fundamentals. Additionally, this professional certificate can help you prepare for the CompTIA IT Fundamentals Certification exam. This is a beginner-level certificate, which means that anyone, even if you're new to IT, can take this course. You don't need prior experience in IT or technical support. No college degree is required. All you need to get started with this certificate is a willingness to learn and a basic computer literacy to take online courses through your web browser or mobile app. The courses in this certificate will introduce you to the essential parts of IT. You will learn about hardware, software, networking and cybersecurity, cloud computing, ticketing systems, and careers and pathways in IT. Throughout the courses, you'll hear from IT insiders as they share their experiences and what they've learned as they've progressed through their careers. Some of the experts you'll hear from are Aditya Pundir, an IT manager, Michelle Sanchez, an instructional designer who started in help desk, Mike Schwartz, who works in IT support, and Amy Taylor, an enterprise support technician. You will learn in this course through guided instructional videos that walk you through key concepts with essential need-to-know facts. Interactive exercises will reinforce what you've learned in videos. Insider viewpoints allow you to learn from professionals working in many fields of IT. And practice assessments and graded assessments will help you gauge your knowledge and prove what you've learned. Upon completing all of the courses, you'll earn a shareable badge and the IBM Technical Support Professional Certificate. Why do you need a professional certificate? A professional certificate is beneficial for you because it's proof of your knowledge and accomplishments. The IBM Technical Support Professional Certificate has been specifically created to focus on the core knowledge you will need to possess to succeed in technical support and beyond. The courses work together to familiarize you with the elements of IT, introduce you to hardware and software, help you build your IT skills, and provide you with hands-on labs to practice using what you've learned in the course. When you've completed the courses in the certificate, you will receive a professional certificate so that you can share your hard work and accomplishment with potential employers and your professional network. One of the many benefits of the IBM Technical Support Professional Certificate is that all of the courses are online and ready to start when you're ready to take them. The courses have flexible schedules, meaning you can complete the course at whatever time is most convenient for you and at your own pace, even if you have only 2 to 3 hours a week to spare. Or you could even complete the entire professional certificate in as little as 3 months if you've spent 5 or more hours per week on the courses. Financial aid is available for those who qualify. So, if you are not sure this program is right for you, you can try a free 7-day trial or you can audit the courses. These options give you the opportunity to sample the content and determine if the courses are right for you. And remember that we're here for your success. If you have any questions about the courses or the professional certificate, just ask. So, what are you waiting for? Let's get started. Welcome to the IBM Technical Support Professional Certificate Overview of Courses. This certificate includes introductory courses on technical support, hardware and operating systems, software, programming and databases, networking and storage, cybersecurity essentials, and cloud computing. The certificate also includes the final course, Technical Support Case Studies and Capstone, to apply your knowledge and skills. The course, Introduction to Technical Support, describes many support essentials, including the roles and responsibilities of technical support professionals, career pathways and progressions in information technology or IT, support tools, ticketing systems, technical skills, and soft skills, all of which are needed to succeed in IT support. In Introduction to Hardware and Operating Systems, you'll learn about internal hardware computer components, including motherboard components, central processing units or CPUs, hard drives, and expansion slots. You'll also learn the essentials of basic workstation setup, commonly used operating system settings, screen capture commands, and effective troubleshooting practices. In the Introduction to Software Programming and Databases course, you'll learn about software, web browsers, software development, programming languages, and database management. In Introduction to Networking and Storage, you'll learn how to diagnose and repair basic networking and security problems. You'll also learn about network types and standards, wired and wireless connections, and common network storage and network sharing options. In Introduction to Cybersecurity Essentials, you'll learn about the fundamentals of cybersecurity. You'll also learn how to recognize common security threats and risks, examine the characteristics of cyber attacks, and explore methods for securing and managing confidential information. In the course Introduction to Cloud Computing, you'll discover the many elements of cloud computing and how cloud computing is changing the world of technology. You will identify various cloud service models, deployment models, and key components of cloud infrastructure. You'll also learn about cloud security, monitoring, emerging trends, and job roles in the cloud industry. And finally, in the technical support case studies and capstone, you will apply your knowledge and skills to practical IT support scenarios. You will also complete a final exam designed to prepare you for the CompTIA IT Fundamentals Certification exam. Are you ready to begin your journey toward becoming a technical support professional? Start on your first course today. Welcome to Exploring Linux Operating System Essentials. After watching this video, you will be able to explain why companies adopt Linux, describe how to create a local system account and confirm its settings, explain how to view system information, describe how to use the Ubuntu file system, and explain how to monitor system performance. As an open-source operating system, multiple vendors offer Linux operating system, or OS, versions. Some OS versions include user-friendly graphical user interfaces similar to Windows, while others focus on command line interfaces and capabilities. But no matter which vendor or version, Linux is often the operating system that organizations and their programmers prefer because of its stability, security, and efficiency. Linux versions are known as distributions, or distros. Popular vendors include Debian, Red Hat, Linux Mint, Ubuntu, OpenSUSE, and others. Canonical distributes Ubuntu, a Linux version with a lightweight, easy-to-use graphical interface, and Canonical reports more than 40 million users as of 2021, making Ubuntu's graphic interface a widespread Linux distribution. Linux is available pre-installed on servers and laptops, but you can also download a base Linux operating system and install the system to the workstation using a thumb drive, CD, or network drive. And after you connect to the web to finish your installation, you can complete your workstation setup. Let's begin with an installed version of Ubuntu. To set up a local account, you need to first log in as the administrator. Next, you'll create a local system account that doesn't have administrative rights. Local accounts are typically shared with computer users and do not permit administrative rights. Next, click Activities, and in the search bar, begin typing the word User and then select Settings. In the Settings pane, select Users and then select Unlock. Type the administrator password. Next, you'll add the user's local account information. In the Users window, select Add User. In the Add User dialog box, select the Standard tab, type the user's full name and username. In this example, you see the new user shown as New User 1. Select the Allow User to Set a Password when they next log in option and click Add. Next, locate the Power Off Logout option. Click the expander arrow and select Switch User. Select New User 1. Now type the new password, ChangeMe! 234, and press Enter. Again, click Activities. Then, in the search bar, type the word User and select Settings. Select Users in the Settings pane, then select the New User 1 tab to confirm the account information. And you'll see the user's account settings below the user's name. Next, let's learn how to locate system hardware and operating system information. You can quickly locate system hardware and operating system information, including the operating system version and build number. Here's how. Select Activities. In the search bar, type About and press Enter. Then click the Settings option, About, View information about your system. You'll see the device name, hardware module, memory, processor graphics card, disk capacity, OS name, OS type, genome version, windowing system, virtualization, and software update status. Let's now quickly access folders and files by selecting either the Files icon in the left navigation pane or the Home folder on the desktop. On the home screen, you'll see an easy-to-navigate familiar folder structure. This file structure includes pre-configured folders for desktop, documents, music, pictures, templates, videos, and other categories of files. To create a new folder, on the home screen, within Folders, right-click and select New Folder. And name the new folder Test Folder 1, for example. Next, double-click Test Folder 1 to view its contents. In this empty folder, let's create a file. Select the LibreOffice document icon and a document opens. Add some text to the file, for example, test:creating a file. Select File and Save or Save As. Then select the destination folder and save this new file in that folder. Now close the document. Finally, confirm that your file is in the correct folder. On the home screen, double-click Test Folder 1 and you'll see the test1.odt file. Next, let's look at where you can find system performance information. To monitor system performance, view the Activities screen and click Activities. Within the search bar, type System and select the System Monitor app. The System Monitor app provides essential CPU, RAM, disk, and priority performance information to help you troubleshoot performance-related issues such as applications that stall or lag. The app organizes this information in the Processes, Resources, and File Systems tabs. In this video, you learned that organizations adopt Linux because of its stability, safety, and efficiency. You first log in as an administrator to create user accounts, and you can set a user account so that the assigned user sets their password the first time they use the workstation. You also learned that you can select About and click About View information about your system to view your computer's name, memory, installed version of Ubuntu, as well as verifying operating system updates and more. To locate files and subfolders, select the Folders icon within the left navigation pane on the home screen. And finally, the System Monitor app organizes system performance information in the Processes, Resources, and File Systems tabs. Welcome to Getting Started with Mac OS. After watching this video, you will be able to explain why companies invest in Mac OS computers, list Mac OS setup steps, describe Mac OS desktop features, describe how to view users, update user settings, and add and remove users, and explain how to use the Finder for folder and file management. So, why do companies invest in Mac OS computers? Apple pre-installs Mac OS, providing users with simplified setup and migration. Built on Unix, Mac OS computers can also run Linux in dual mode or as a virtual machine. And Mac users are less likely to need on-site help desk support, reducing support costs. Apple's rigorous application testing process is built for both security and ease of use. Mac OS applications include business productivity vendors such as Microsoft, Adobe, Slack, and many others. And Apple provides online help and in-person support at the Apple Store and designated vendors. Organizations, including IBM, report lower total ownership costs after factoring in hardware, software, security, and support costs. Users reported improved ease of use, and organizations, including IBM, have reported significant worker productivity gains. So let's get started and explore Mac OS. The initial Mac setup process provides a guided walkthrough excluding data migration. This process takes about 15 minutes, but options and timing can change with each new operating system release. First, specify the computer's displayed language, country, or region. You can optionally configure vision, motor skills, hearing, and cognitive accessibility settings. Then it's time to configure your network access. Next, accept Apple's mandatory data and privacy terms. When migrating from one Mac to another, you can transfer your apps and data to the new machine. When migrating from a Microsoft Windows machine to a Mac, you can bring your data. You'll create a new Apple account or log in with an existing Apple account. An Apple account is required for machine setup and email, App Store purchases, and cloud backups. Next, opt in for machine usage analytics. Then enable Apple's assistant, Siri. If you didn't already, set up Apple Pay. Then set up a Touch ID and create your first user account, which includes administrative machine rights. And finally, allow location services. With this initial setup complete, let's explore the desktop. The dock is where you find applications. You can keep frequently used applications attached to the dock. Next is the contextual menu at the top of the screen, which displays the active application's menu options. For example, with the Safari web browser open, you'll see that application's menu. You'll also see the logged-in user's name, the battery level indicator, the spotlight search, and frequently adjusted options, including screen brightness, speaker volume levels, Siri, and date and time information. The desktop is the area between the menu bar and the dock. You can locate applications using the Launchpad and open the application for use on the desktop. Next, user management is one of the first post-setup tasks. You need to determine who can use the machine and install software on the computer. Here's how. Open System Preferences and type User in the search bar. Then select Users and Groups. You can view all computer users at a glance. Click the lock icon and enter your password to open the lock to add or remove users, configure user capabilities, change user passwords, and allow users to reset their password using their Apple account ID. When adding a new user, you can create an account with administrator rights or a standard account. Type the user's full name, name the user account, create the password and its hint, and click Create User. Click the key icon to enable automatic password generation. macOS can generate passwords with letters and numbers, numbers only, random characters, and U.S. federal government compliant passwords. To remove users, confirm that the lock icon is unlocked. Select the user, click the minus symbol, decide whether to keep or remove the user's data located in the home folder, click Delete User, and click the lock again to close the lock and prevent unintended changes. Next, let's learn about macOS file management. You can use the Finder to locate, move, store files locally and in the cloud, and show and hide folders. Start by clicking the Finder icon displayed in the dock. The left pane displays available top-level folders and the iCloud remote storage location. You can see your files in the central pane. Within the Finder, you can view files by list, icon, or gallery, and provide other options such as grouping files by kind. macOS supports dragging files from one location to another. If a user asks, "Why can't I see my files and folders?" try these steps. Click Finder, and then click Preferences. Now click the sidebar icon. To display folders on the sidebar, select the checkboxes. To remove these folders from the sidebar view, clear the checkboxes. Next, check the settings within Preferences and the general icon. These settings also control which storage locations are visible and the location a user sees first when searching for a file. To display data sources on the desktop, select the Data Sources checkbox. You can also specify the data storage location displayed when a user opens the Finder, and choose whether to open folders in tabs or new windows. A user might also ask, "Why do I see these warnings before I empty the trash?" Or, "Why are my files and folders missing?" To help answer these questions, look within the Finder Preferences and click the Advanced icon. Select checkboxes to receive a warning before changing a file extension, removing a file from an iCloud drive, and emptying the trash folder. You can also set default folder view options and search locations. In this video, you learned that companies appreciate Mac OS's easy migration, user satisfaction, and reduced support costs, which result in lower total cost of ownership. During Mac OS setup, a user creates an Apple account for email, cloud storage, and purchases, and creates a separate user account for computer access and management. You can manage users, their passwords, and machine permissions within users and groups. You can use the Finder to access folders and files. And finally, if folders or files are not visible, open Finder preferences and adjust the general, sidebar, and advanced settings. Welcome to Networking and Performance Mac OS Essentials. After watching this video, you will be able to explain how to locate system-level hardware, network, and software information, update the computer's network connection, and use the activity monitor to evaluate system performance. Here's how to locate and connect to new wireless networks. Within System Preferences, begin typing the word Wi-Fi. Apple uses predictive text, so you should quickly see the word Wi-Fi. Then select the Network app. Select an available network and enter the network password. After you enter the password, you'll be able to click Join. Optionally, you can display the network password while typing, and you can choose to have the computer remember the network for automatic login when you're near this network. Next, let's learn how to view system information. To view system information, click the Apple logo and select About This Mac. You'll first see the Overview tab. Here, you can quickly identify the Mac OS version, the MacBook model, processor, installed memory, graphics type, and the computer's serial number. Select Software Update to determine if the operating system files are current. You can opt in for automatic operating system updates. Next, select the Displays tab to view basic display information. Select Displays Preferences, and you can adjust the resolution, brightness, color profile, universal control, and night shift settings. Now, let's view the Storage tab. You'll first see an overview of the onboard storage. Click Manage to see an overview of what's being stored, view iCloud storage options, optimize storage, empty the trash automatically, and review and remove files that are no longer needed. So, now that you've seen the overview information, it's time to select System Report. The System Report provides a detailed look at the system's hardware, networking, and software. You'll first see the default hardware view that includes the computer's model name, identifier, processor name, speed, cores, RAM, serial number, and additional essential information for support. You can expand the view and click any of the items, such as Power. Click Network and let's check out the Wi-Fi information. You'll first see the system networking hardware-related information, including the machine's MAC address. Then view information about wireless networks and other network-specific details as you scroll the page. Okay, next let's check out the Software category. Select Software and review the System Software Overview. You'll see operating system version information, the computer's name, the logged-in user's name, and the time elapsed since the computer's most recent restart. And next, within Software, select Applications. Here, you can view application names, versions, sources, dates last modified, and software kind or type, such as if the application is a universal app for all Mac devices. Next, let's check out the Support tab. Select the Support tab and use the displayed information to find out if the machine is still in warranty, find service locations, and obtain help via chat and phone support. Next is the About This Mac Resources tab. Here you'll find links to online documentation and support for the Mac OS operating system and Mac hardware. So next let's explore the Finder for folders and files. Use the Activity Monitor app to monitor system performance. Press the Command key and spacebar to display the spotlight. Then type Activity Monitor in the search bar and click the Activity Monitor icon to open the app. You'll first see the CPU tab where you can identify which applications and processes are using CPU resources, what percentage of the CPU's capacity is in use for each application, how much of the total CPU power is in use, and how much of the total CPU power is idle. Next, on the Memory tab, you can see the amount of memory each application is using, the total physical memory installed, how much total memory is in use, the number of cached files, the amount of memory used by apps in total, and the wired memory or the memory needed for the machine to run. When you view the Energy tab, you'll be able to determine how much energy each application is using and whether the application is using the graphics card, the type of graphics card installed, the amount of battery charge available in both percentage of battery and time formats, and the most recent amount of time on battery. The Disk tab view provides disk performance information. You'll see how fast data is read and written for each application and as a total, and you'll also know the amount of data transferred per second. The Network tab displays the number of data packets sent and received individually and in total. You'll also see total data sent and received measured in megabytes based on the amount of data transferred per second. And what if you need system diagnostics? Select the drop-down arrow where you can run a spin dump. A spin dump report helps troubleshoot why programs are crashing. You can also run a systems diagnostic test for hardware issues, and you can run a spotlight diagnostics report to focus on evaluating system processes. In this video, you learned that you can click the wireless icon to locate and configure login information for new networks. You can view the computer name by selecting System Preferences, System Report, and then the Network Overview. And selecting System Preferences and then selecting Network displays the computer's name, IP address, related networking information, and the computer's MAC address. You also learned within System Preferences, System Report, you can view hardware, network, and software overview details. Press the Command key and spacebar to open the Spotlight. Using the Spotlight, you can type Activity Monitor and click the icon to open the app. Activity Monitor provides you with performance information organized by CPU, memory, energy, disk, and network. And finally, a spin dump report helps troubleshoot why programs are crashing. Welcome to Chrome OS Operating System Essentials. After watching this video, you will be able to explain the pros and cons of Chromebooks, describe Chromebook setup essentials, describe parts of the Chromebook desktop, explain how to adjust frequently modified settings, and describe how to locate essential operating system and hardware information. Chromebooks, known for being lightweight and portable, are suitable for web-based work and storage and run Android apps available on the Google Play Store. Chromebook hardware typically includes less powerful processors, less RAM, and less local storage than standard computers. With reduced hardware needs, Chromebooks are generally more affordable than laptops and desktops running other operating systems. Chromebooks tend to be popular with students and web-based workers in small to medium-sized businesses. Around 2020, Chromebooks incorporated additional capabilities. Chromebook users could now mirror programs from their desktops and laptops and run mobile Android versions of Microsoft Office 365 products. So why doesn't everyone use a Chromebook? Chromebooks require an internet connection for access to web-based apps and functions. Google Apps and some other apps are available for offline or asynchronous work. However, many business apps and tasks require a network and internet connectivity. Chromebooks also offer a strict automatic expiration date. After that date, the operating system is no longer guaranteed to work with hardware. So, after you press the Start or Power button, you'll select your preferred language and click Let's Go. Next, join a Wi-Fi network. You'll enter the network name, specify the security type, and enter the network's password. You can also allow others to use the Chromebook to access the same network. Then sign in with an existing Google account or create a new Google account. Next, let's learn about setting up Google Assistant. You'll be prompted to enable Google Assistant. Google Assistant integrates with Google devices, including lights, music, and other devices configured in Google Home. You can use both voice and keyboard input capabilities to ask Google questions or ask Google to perform tasks, and you can adjust these settings at any time. You can also find Google Assistant using the Settings pane. Select Search and Assistant, and Google Assistant settings appear. Click the toggle to enable Google Assistant. You can also click the OK Google toggle to use Google Assistant with your voice. If you want to use your voice instead of the keyboard, click the Preferred Input toggle. To talk with your assistant, say OK Google and ask your question. Also, on your keyboard, you can press the Search key or the Assistant key. Next, let's learn about another Chromebook essential: how you can configure your Chromebook to use a preferred wireless network. In the Settings pane, select Network. In the Network section, click to toggle Wi-Fi. To automatically connect or reconnect to a specific network, click the Automatically Connect to this network toggle. To set the connected network as the preferred network, click the Prefer this network toggle. Now it's time to learn about installing apps. To install additional apps, use the shelf and select the Google Play Store app. You'll find apps for gaming, productivity, navigation, shopping, social sites, education, movies, and books. But after your apps are installed, how do you find them? Let's check out the desktop, the shelf, and the launcher. The desktop is your workspace. You can access programs and shortcuts using the shelf, and you'll use the open space to view open programs. You can also select the launcher to find and open programs. When viewing an app in the launcher, you can right-click an app to pin or anchor the app to the shelf. The desktop is also where you access frequently adjusted settings, such as speaker volume and screen brightness, locate the Settings app, and, although not enabled here, view notifications. When connected to the Internet, Chromebooks can automatically check for, download, and install operating system updates. And within Settings and About Chrome OS, you can manually check for updates. You'll also be able to see which version of the Chrome operating system your Chromebook is running. After downloading the update, Chrome OS prompts you to select Restart to finish the update process. Chromebooks have a date when they will no longer receive Chrome OS updates. View update schedule details to see the expiration date. Some Chromebooks may also have a device name, but a search of this Chromebook device did not supply a name. To monitor your system performance, click Settings, then About Chrome OS, and select Diagnostics. Select System to view the battery health and a CPU usage graph. Scroll the System view to see more CPU details, and then view memory usage details. Next, select Connectivity, where you can view network performance. In this video, you learned that you need a Google account to use a Chromebook. Google Assistant, with both voice and keyboard command capabilities and notifications, provides functionality that integrates additional Google capabilities. You can use the launcher to locate files, and within Settings, select About Chrome OS to update the Chromebook operating system. You'll use the Google Play Store app to download apps, and within About Chrome OS, you can check the operating system update status, find the Chromebook's expiration date, and view system diagnostic information. Welcome to Introduction to Mobile Devices, iOS. After watching this video, you will be able to explain why companies support iOS devices, describe iOS setup essentials, including Siri, Apple's assistant, identify iOS screen types and navigation, explain how to adjust frequently modified settings, and describe how to locate essential operating system and hardware information. Apple, who owns iOS, provides a track record of security, extensive data privacy practices, interoperability with Apple desktops, laptops, and tablets, user satisfaction with the operating system, extensive app availability, extended employee availability, and corporate device controls. So, before you begin setting up an iOS device, plan ahead and have the following items ready: Wi-Fi access, the SIM card if needed, the existing Apple ID if available, a debit or credit card, and the prior device if migrating apps and data. After you press the Start or Power button, you'll choose the language and click Let's Go. Select your location and then connect to a Wi-Fi network. Accept the data privacy agreement and then set up security such as facial recognition, a password, or a PIN, and select whether to migrate apps and data. Next, you'll sign in with an existing Apple ID and password or create a new account. Then set up iCloud storage, the keychain, and accept Apple's terms and conditions. Next, decide whether to set up Apple's assistant, Siri, and whether to share app analytics. Then you'll configure screen display options to reduce blue screens at night. And finally, choose a standard or zoomed screen view. Now, let's check out the iOS device screens on an iPhone. With your iPhone set up, swipe up and display the home screen. Swipe right to display the leftmost screen, known as the Today view. Then swipe left until you see the final screen showing the app library. Whenever you see an app, such as the Calendar app, shown here on the home screen, you can tap to launch the app. By default, the Settings app is located on the home screen, and with more than 50 categories, the Settings app is the central location for customizing your iOS device. You'll also find additional application-specific settings for App Store installed items. Now, when you're ready to activate cellular service, within Settings, tap Cellular. On the Add Cellular Plan screen, scan the QR code provided by your carrier or type Enter details manually to type the setup information provided by the carrier. Tap Next to continue the setup process. To adjust how you see notifications, within Settings, tap Notifications and choose whether you will see notifications on a schedule, see notification previews, and see notifications when screen sharing. Also, decide which apps can suggest shortcuts when the screen is locked. For iOS devices, you'll get apps from Apple's App Store. By default, you'll usually see the App Store displayed on the home screen. Tap the App Store to view available apps by category or search for a specific app. And when you locate your app, tap Get to download and install the app. Connecting to Wi-Fi networks usually saves on mobile network charges and could be workplace policy. Within Settings, tap Wi-Fi. View the available networks and tap the network name, or tap Other to enter network details and connect to a network that's not visible. Next on the Enter Password screen, enter the password in its field and tap Next or Join as displayed. Siri, Apple's digital assistant, works with voice and keyboard input. Siri is compatible with Apple HomeKit and integrates with other iOS and macOS devices. You can adjust Siri's settings at any time. To use Siri, you can say, "Hey Siri," or you can press and hold the button on the right side of the phone to speak your request to Siri. Accessibility is built into iOS, with currently more than 20 accessibility categories and the ability to add apps and customize per app or individual app settings. Users frequently customize the on-screen display and brightness. Within Display and Brightness, you can adjust the screen display from light to dark, change the light tone from blue to yellow, schedule display changes, change the text size, and more. Let's now check out important device information you'll need to know. Within Settings, tap General and then tap About. You first see the device name, which you can edit. Then you'll see the current iOS operating system, device model name, device model number, and the device's serial number. Scroll to view the system storage capacity and available storage capacity. Then you can see the device's current Wi-Fi address, Bluetooth address, and modern firmware version. The SE-ID is the Secure Element Identifier, a near-frequency communication chip. Next is the EID, which is the acronym for the electronic SIM card, but not all iPhones have an electronic SIM card. Scroll again to find out if the device is locked to a specific cellular carrier. Then see who the current cellular carrier is and view the following identifiers. First is the IMEI, a unique 15-digit number assigned to every cellular device. IMEI numbers are internationally registered. Next is the ICCID, the identifier associated with the SIM card. And the MEID is a 14-digit PIN code assigned specifically to mobile devices. For example, an IoT device might have an IMEI, such as an electric meter, but since it's not a mobile device, the meter won't have an MEID. And finally, some phones may have a second IMEI 2 slot. This second IMEI enables iPhone users to keep one cellular plan for business and a separate personal plan on the same phone or use a local carrier when traveling internationally. You can set iOS to automatically check for, download, and install operating system updates. Within Settings, tap General and Software Update. Set automatic updates to On. When Apple releases a new iOS version, you'll see a message providing you the opportunity to upgrade. In this video, you learned that organizations appreciate Apple's security, data privacy practices, and seamless interoperability with other iOS and Mac devices. The Settings app is where you can adjust iOS settings and check storage and performance-related information. The three main iOS device screen names are the Home Screen, the Today View, and the App Library. Siri, Apple's digital assistant, works with both voice and keyboard input. And the About Settings page provides device, communication, and cellular identifying information. Welcome to Introduction to Mobile Devices, Android. After watching this video, you will be able to describe why organizations support Android devices, describe Android setup essentials, including Google Assistant, Google's digital assistant, identify Android screen types and navigation, explain how to adjust frequently modified settings, and describe how to locate essential operating system and hardware information. Android currently holds a global market share of 77%. Android is an open-source operating system supported by Google. Android supports development by multiple vendors, providing opportunities for innovation and multiple price points for devices that help extend employee availability and provides corporate programs with device controls. So, before you begin setting up an Android device, you'll want to have the following items ready: Wi-Fi access, the new SIM card if needed, the Google account ID and password if existing, payment options for the Google Play Store, and the prior device if migrating apps and data. With Android devices, setup processes will likely vary based on the device manufacturer. Connect your phone or device to a power source. After you press the Start or Power button, you'll choose your language and install your SIM card if needed. Then connect to Wi-Fi. You'll then sign into the device using your existing Google account or create a new account. Next, set the device date and time. Set up security, such as a PIN, drawing, passcode, fingerprint, or facial recognition. Then begin downloading apps and data. Now let's check out some Android phone screens. If you set up your phone's security, the lock screen displays when you first power it on. After you enter your security information on the lock screen, you'll see the first home screen. Whenever you see an app, such as Google One Storage app, shown here on one of the home screens, you can tap to launch the app. Next, let's view the Settings app. The Settings app is your central location for customizing your Android device. You can find the Settings app on one of your home screens or by searching for the app and typing in the predictive text SET. Now tap the Settings app icon. Organized into about 20 categories, you can use the Settings app to manage network and internet settings, view battery life, check your device's storage capacity, update the display, configure accessibility and security options, configure application-specific settings, and much more. So when you're ready to activate cellular service, within Settings, tap SIMs. If your device is capable of an eSIM, you can download your eSIM or digital SIM card number from your cellular provider, referred to here as your network or network provider. Confirm your network. Now, with your provider confirmed, scan the QR code provided by your carrier and complete the setup process. Next, tap the top of the home screen and swipe down to view notifications. To adjust how notifications are experienced, within Settings, search for Notifications. Here you can see some of the notification settings, such as configuring notifications based on the app, viewing notification history, how conversation notifications are seen, and numerous other settings. For Android devices, you'll obtain apps from the Google Play Store. When you tap the Google Play Store, you will see suggested apps, available apps by category, and you can search for a specific app. When you locate your app, such as the IBM security software shown here, tap Install to download and use the app. Next, let's learn about connecting to Wi-Fi networks. Within Settings, tap Wi-Fi. View the available networks and tap the network name or tap Add Network to enter network details and connect to a network that's not visible. For the new network you selected, enter the password and tap the checkmark icon. Now, Google Assistant, Google's digital assistant, works with both voice and keyboard input. Google Assistant, compatible with Google Home, also works with an ecosystem of other Android-compatible devices. You can adjust Google Assistant settings as needed. To use Google Assistant, you can say, "Hey Google," or you can press and hold the button located on the right of the phone. You can then speak your request to Google Assistant and you'll see or hear a response. You can customize Google Assistant to ask questions, control devices, plan events, and more. Within Settings and Accessibility, you can activate an accessibility menu, adjust accessibility shortcuts, update visual settings, and configure the time you have to respond to apps. Users frequently customize display settings. Tap Settings and type Display. Tap Display Size and Text, and on this screen you can adjust the size of icons, the text size, and set text to bold and high contrast. Now let's check out important device information you need to know. Within Settings, tap General and then type About and view About Phone. You can view the device name and model number, and you can also view the IMEI, a unique 15-digit number assigned to every cellular device. IMEI numbers are internationally registered. This device has one physical SIM card slot and a second eSIM slot. A second SIM card slot is often used for travel or when using a phone both personally and professionally. Next, you can see the device's current IP address, Wi-Fi MAC address, and Bluetooth address. Also, selecting About Phone displays important information about the operating system, including its baseband version, kernel version, and build number. This information is helpful for troubleshooting operating system issues should they happen. Android usually provides monthly operating system security updates. Each device manufacturer pushes updates to its branded devices. Android device owners receive a notification that an update is available and can choose to install the updates immediately or later. If the device is corporate managed, the administrator can choose when to push operating system updates to their devices. Here is how to check if your version of Android is current. Within Settings, type System and then tap System Updates. Then tap System Update. You'll also see the Android version your device is running, and when the system most recently checked for updates. Note that you can also manually check for updates at any time. In this video, you learned that organizations appreciate Android's security, data privacy practices, and seamless interoperability with an open ecosystem of providers and devices. The Settings app is where you can adjust Android settings, configure cellular service, view essential device information, and update the operating system. You can manually check for Android security updates at any time, and Android device owners receive a notification that an update is available and can choose to install the updates immediately or later. Welcome to Introduction to Software Programming and Databases. Are you interested in learning the basics of software programming languages? Does finding out more about software development, cloud computing, web browsers, and their security features appeal to you? Would you like to get more information about databases and their fundamentals? Ever wonder how to organize code in the easiest, simplest, and most efficient way possible? If so, this course is for you. During this course, you will learn about the basics of software development technologies and programming languages. This course introduces the basic concepts of cloud computing, and you will gain hands-on experience identifying file formats and installing and uninstalling browser extensions and plugins. During the course, security and development related to web browsers, applications, and content will be discussed. You will also discover how to identify types of databases, how to access and manage data, and identify the 4 types of backup methodologies. In addition, you will learn how to organize and plan software programs using flowcharts and pseudocode. This course is divided into 4 modules: Computing Platforms and Software Applications, Fundamentals of Web Browsers, Applications, and Cloud Computing, Basics of Programming, and Fundamentals of Databases. The Computing Platforms and Software Applications module provides information about computing platforms, including single and cross-platform software. You will discover the differences between commercial and open source software while also exploring software versions, compatibility, different types of software, and file formats. In the Fundamentals of Web Browsers, Applications, and Cloud Computing module, you will learn about common web browsers and browser settings, security, extensions, and plugins. You will examine cloud computing and learn about application architecture, delivery models, and software development lifecycles. The Basics of Programming module will give you a solid foundation of basic programming concepts and programming language categories. You will explore basic programming logic components and how to organize software using flowcharts and pseudocode easily and quickly. Throughout the Fundamentals of a Database module, you will learn about basic database concepts, types of databases, and how to use and manage databases. You will also learn about interfacing with a database and backing up a database. To successfully complete this course, you should be familiar with basic computer operating skills and terminology. Additionally, knowledge of how to use a modern web browser like Google Chrome is required to complete this course and the hands-on labs within it. Finally, you will need to create a free trial account for IBM Cloud. We're here to support your success, and we're excited that you're here. Let's get started. Welcome to Computing Platforms and Compatibility. After watching this video, you will be able to define computing platforms, identify single and cross-platform software, and identify cross-compatibility issues. What are computing platforms? A computing platform is the environment where the hardware, like your personal computer, and the software, like your operating system or OS, work together to run applications. Hardware refers to the type of computer or device, such as a desktop computer, a laptop, or a smartphone. Software in this instance refers to the type of operating system, such as Windows, Mac OS, iOS, Android, and Linux, and also includes the programs and applications that run on the OS. Here are 3 types of common computing platforms. The desktop platform includes devices like personal computers and laptops that run operating systems like Windows, Mac OS, and Linux. The web-based platform includes browsers like Firefox and Chrome that function the same in various operating systems, regardless of the hardware. The mobile platform includes devices like the Pixel and the iPhone that run operating systems like Android OS and iOS. When planning applications, software developers must consider if they will be designing for one platform or across platforms. Depending on who the primary users of an application will be, software developers design either single-platform software, meaning that the programming code only works on one kind of computing platform, or cross-platform software, meaning that the programming code will work on multiple platforms. Here are some of the differences. Single-platform software is written for a particular OS or version of OS. It may also be written in a programming language like Java or Objective-C, which is specific to the platform. Additionally, single-platform software is designed to run only in the target OS and most likely won't run as intended on other platforms. Some developers use applications like Xcode for iOS and Android Studio for Android to code single-platform software. However, cross-platform software is different from single-platform in several ways. It is written for more than one type of OS. Applications across devices and operating systems operate the same or similarly regardless of the computing platform. Performance of the software varies due to platform differences. And some developers use applications like React Native and Xamarin for cross-platform software development. Before creating a single platform or cross-platform application, developers must weigh the pros and cons. Let's look at some single-platform pros first. An advantage of single-platform software is that the software has a smaller, more focused app user base. Single-platform applications have better performance and faster speeds because they are running on their native platform. Also, the programs are normally easier to use because the user interface is designed for one specific OS. However, there are also some cons. With single-platform software, there is a higher cost of development because the application must be made specifically for one OS. Single-platform software also has a longer development time since the code must be uniquely written for the platform. Additionally, more specialized programming expertise is needed, which means higher costs for the software development. And updates and maintenance are higher due to the unique programming knowledge needed. Now let's look at cross-platform software. Some pros are lower cost of software development, which can happen over a shorter time. Another advantage is a wider app user base and market reach because the app is available on more devices. Additionally, programming expertise is more generalized because developers do not need to learn specialized operating systems, and they are able to use the same coding. Also, updates and maintenance are more readily available and affordable. Cons include the following. Cross-platform applications have design challenges for making the software function similarly and correctly in different operating systems. Performance and speed may vary due to differences in platforms. And the user interface may also vary and be less reliable across platforms. So, these are only a few of the key factors that developers should weigh when deciding what is best for their software and for their user base. When considering cross-platform software, it's important to realize that there are some compatibility concerns. Be aware that cross-platform software acts differently depending on the platform and may even have limited usability. It's important to remember that cross-platform software is created by different developers most of the time. This means that programs may interpret the code differently in each application. Functionality and results can differ between platforms. Sometimes these differences can mean undesired results and errors. Other times, it can just mean a difference in appearance or how the software is accessed. This could happen when a document is created in Microsoft Word on a desktop PC. Then the document is edited in Google Docs through a web browser, and then it is opened on a mobile device. As the document goes through this process, several different applications are being used. This results in a change in appearance in the document and sometimes a change in how the document is used. In this video, you learned that single-platform software is developed for one particular operating system. Single-platform programs are more focused on the user base, are faster, and have a better user interface. However, single-platform programs are also more expensive and take longer to develop, require more specialized programming expertise, and need more ongoing maintenance. Cross-platform software is developed to be used across different platforms, and it should function the same or similarly on different platforms. Cross-platform programs are less expensive to develop, have a wider user base, require more generalized programming knowledge, and have more readily available updates. However, cross-platform programs also have more design challenges, have varying performance and speeds, and sometimes have user interface issues across platforms. And compatibility concerns arise when a software does not function similarly or correctly across platforms, and when the same options and commands are not available across platforms. Welcome to Commercial and Open Source Software. After watching this video, you will be able to define commercial software, define open source software, and identify differences between commercial and open source software. So, what is commercial software? Commercial software, also sometimes referred to as proprietary or closed source, is copyrighted software. When individuals or companies purchase the software, they must acknowledge the software developer's copyright, which is identified in the End User License Agreement, or EULA. Commercial software source code is private, and users are prohibited from copying, modifying, or redistributing the software or any part of the source code, except parts of the source code that may be open source. It is usually developed for commercial profit and can include open source code bundled with private source code. When commercial software is installed, a product key or serial number is issued to certify that the software is original. Some commercial software is free, but upgrades and updates may cost extra, or the software may contain ads. Some examples of commercial software are Microsoft Office, Adobe Photoshop, and Intuit QuickBooks. Software licenses are also required for most open source software. Open source is also referred to as free and open source, or FOSS. Open source software is free and can be downloaded, installed, and used without limits or restrictions. Note that free software is not always the same as freeware, which is free to users but is not always open source. Open source software contains free source code, which can be freely copied, modified, and redistributed. It also gives developers and users open access to the functions of the software and source code without the cost or restrictions. A benefit of open source software is that developers and users can contribute to the source code and work together to improve the software and its functionality. Even though open source software is free and open, users are still required to agree to an End User License Agreement, or EULA, in order to use the software. Some examples of open source software are Linux, Mozilla Firefox, and Apache OpenOffice. There are some important differences in open source and closed source software. With open source software, the source code is available to be edited, modified, and redistributed. Users don't have to pay to download, install, or use the software. Open source code can sometimes be used in commercial software, which is usually developed for profit, but can also include freeware. With closed source software, developers keep private the source code and how it works. Additionally, with closed source, a company or individual owns the rights to the source code and software, like with Microsoft Edge web browser. Freeware, like the Edge browser, and commercial software can be closed source, regardless of whether it is available for free or for purchase. The Chromium web browser is an example of open source software, and the source code is free and openly available to everyone. The basis for the code in the Microsoft Edge web browser is from the open source code in the Chromium web browser. While some of the source code in Edge is open source, most of the source code is closed source and proprietary. The Microsoft Windows OS is both closed source and commercial, and users pay for the software. Note that for all software, whether it is open source or closed source, anyone who wants to use the software must agree to the end-user license agreement. So, how can you tell the difference between open source and closed source software? Most software has an About section located in the details of the software. If there isn't an About section, look for details or some terms that are similar. In this example from the Microsoft Edge web browser, you would select the 3 dots in the right corner. Next, from the list, you would select Help and Feedback to open more options. Then you would select About Microsoft Edge for more details. So how do you know if the application is open source or closed source? Once you select About Microsoft Edge, the details show that Microsoft Edge uses Chromium open source code and other open source software. While the steps for determining open source or closed source will not be the same for every application, you can follow similar steps to find more information, or you can search trusted websites for more information about source codes for most software. In this video, you learned that commercial software is also known as proprietary or closed source software. Commercial software is copyrighted software. Individuals and companies can purchase commercial software as long as they comply with the specified conditions listed in the software license. Commercial software contains private source code that is often not accessible to users and competing companies. Users may not copy, modify, or redistribute private source code from commercial software. Additionally, you learned that open source software is also known as free and open source software, or FOSS, and it can be downloaded, installed, and used without limits or restrictions. The source code in open source software is free and can be copied, modified, and redistributed. Users and developers have open access to the software functions and source code. There is overlap between open source and commercial software because open source code can be used in commercial software. All open source software is available for free, and some commercial software can be available for free. And finally, you can find out whether software is open source or closed source in the About details of the application or program. Welcome to Software Licenses. After watching this video, you will be able to define software licenses, identify types of software licenses, and identify product keys for activating software licenses. What is a software license? A software license states the terms and conditions for software providers and users. It is a contract between the developer or group who created the source code and the end user of the software. It specifies who owns the software, outlines copyrights for the software, and specifies the terms and duration of the license. It states where software can be installed, how many copies can be installed, and how it can be used. It can be lengthy and full of definitions, restrictions, and penalties for misuse. Agreeing to the licensing terms is required for use of most software. If you want to install and use software, you must agree to the terms and requirements, which is called an End-User License Agreement, or EULA. Agreeing to the EULA means that you accept the terms of the license, such as how many computers the software can be installed on, how it can be used, and what the limitations on developer liability are. Different software programs and applications have various ways of presenting their EULAs. Let's look at some common examples of types of licenses. Single-use licenses allow a single installation on one computer, or, depending on the software, the license may allow a single user to install the software on any machines that belong to the user. A group use, corporate, campus, or site license allows multiple installations for a specified number of users. It also allows installation on many computers or devices. This kind of license is ideal for use with computers and devices that are registered to a group, such as a computer lab on a college campus or a writing team at a newspaper. Concurrent licenses allow installation on many computers, but they can only be used concurrently, meaning at the same time by a lower number of users. It allows many users to have access to the software, but it is not used often by a lot of people at once. Concurrent licenses are ideal for companies that do not have all workers using the software at the same time, such as nurses and doctors who work different shifts. Now, there are some differences between open source and proprietary software licenses. Open source licenses, also referred to as free and open source, or FOSS, are still necessary for open source software to protect developers and contributors. Proprietary software licenses are more restrictive and are designed to strictly protect the software developer and those who invested in the software. An open source license means free software which can be downloaded, installed, and used without limitations or restrictions. Free source code which can be freely copied, modified, and redistributed. However, open source software will still require users to sign a licensing agreement, even though there are no limits or restrictions. Proprietary software licenses aim to protect the developers and the companies who own the software. Proprietary licenses cover copyrighted software with specified conditions listed in the license. Proprietary licenses also protect private source code, which users are not allowed to copy, modify, or redistribute. Users are also required to sign an End-User License Agreement, or EULA. How much does a software license cost? Costs vary depending on the type of software, how it will be used, and how much was spent to develop the software. Remember that the cost is for the software license, which allows you to use the software. Several options are available, such as trial, subscription, and one-time purchase. Trial licenses are available, usually for free and for a limited time, to allow a user to decide if they like it and want to purchase the software. Subscription and one-time license purchases are also available. The software description will identify whether it is either subscription or one-time. Subscription licenses require recurring payments, and users are billed regularly on a set schedule such as monthly or yearly. Software developers and companies often prefer subscription-based models because they generate more income, and they allow developers and companies to control the cost and updates for the software licenses. Subscription-based licensed software can be used offline, but online access is needed from time to time for updates and upgrades. Also, online access allows users to verify with the vendor that the subscription is still active. Users can access the software for a limited time as long as their subscription is valid. If users do not verify their subscription, the software might not be available to them. Conversely, with one-time license purchases, users pay just once for the software. A one-time purchase of a software license also means that the application or program can be used without interruption for the life of the software. However, a drawback to a one-time purchase is that updates or upgrades to the software may not be available, and the user will need to purchase newer versions or upgrades separately. Both have their advantages and limitations. It is up to the user to determine which purchase is the most appropriate. To ensure that the software that you are using is licensed, developers and vendors will issue a product key when software is purchased. Product keys are unique long sequences of numbers that certify that the copy of the software is original. Product keys are usually included on a physical copy of the software or sent through email when the software is downloaded. Some programs and applications automatically register the product key when you install the application. For subscription software licenses, serial numbers or license IDs may be used. When software is activated, the product key is locked to a specific computer, which helps prevent piracy of software. In this video, you learned that a software license states the terms and conditions for software providers and users. It states where software can be installed, how many copies can be installed, and how it can be used. When installing software, users are asked to agree to the End User License Agreement, or EULA. Single-use licenses allow a single installation on one computer. A group-use, corporate, campus, or site license allows multiple installations for a specified number of users. Concurrent licenses allow installation on many computers, but the number of users at the same time is limited. Additionally, open source software or free and open source software, otherwise known as FOSS, is free software which can be downloaded, installed, and used without limits or restrictions. Open source software contains free source code, which can be freely copied, modified, and redistributed. Proprietary commercial or closed source licensed software indicates that the software is copyrighted with specified conditions listed in the license. Proprietary software source code is private, and the license prohibits users from copying, modifying, or redistributing the software or any part of the source code. Costs for software licenses vary depending on the type of software, how it will be used, and how much it costs to develop the software. Product keys are unique sequences of numbers that certify the copy of the software is original. Software licenses and product keys are in the program or application after it is installed on your computer. And a product key locks with a specific computer, which helps prevent piracy of the software. Welcome to Software Installation Management. After watching this video, you will be able to discuss installing and uninstalling software on various computing platforms, and identify software installing and uninstalling best practices. Consider the following before installing software. Read the application details and be selective about what you're installing. Be aware that some software may also install ads or other unwanted software. Avoid downloading software that contains malware designed to steal personal information on your device, encrypt your files, require you to pay a ransom for decryption, or monitor your device. Review permission requests to access other apps and hardware on your device. And be selective when allowing application privileges to items such as your device's camera, contact lists, location data, and similar sensitive information. Before installing software, you should consider what will work best with your project and what will work optimally on your device. You should consider minimum system requirements such as minimum processor speed, minimum amount of RAM, the minimum amount of hard disk space available, and compatible operating system versions. Additional requirements may be a specific display adapter, the amount of display adapter RAM, and an internet connection to use the software. Windows desktop software will usually have an installer. To install software from physical media, such as a USB or CD, insert the disk or drive and wait for a prompt to run the installer. Sometimes the installer will run automatically. If the installer does not start automatically, browse the file system for the software. Locate the installer, usually an EXE or MSI file, and then double-click to start the installer program. When installation is complete, the application should start. You can also download and install software for Windows. Software downloads are available through Windows-compatible websites or from the Microsoft Store. When installing software from a website, be sure to verify that the site is trustworthy and read installation prompts. Do not install any software from a site that looks suspicious. Many installers, when started, will automatically begin installing the program or will guide you through the installation process. And programs available for download are available as compressed files, EXE files, or ISO files. You can also install software from a disk in Mac OS. To install software from a disk, insert the disk in the computer, and the setup utility should start automatically. If setup does not start, you can use Finder to browse for the disk to start the setup. In Finder, locate the setup file. To start the setup, select the file and then follow any prompts. To install macOS software that you have downloaded from online, open the downloaded file and then follow the installation prompts. Locate the file you have downloaded, which may sometimes appear in the bottom corner of your browser after the download is complete. If you did not download the software from the Apple App Store, you might receive an alert that says the application cannot be opened. If you're sure the software is safe, then select Open to continue the software installation. Mac installation files have several different file formats, including zip, PKG, and DMG. For a zip file, double-click the file to install it into its own folder. Within that folder, you will find a PKG or DMG file. PKG files will install the software automatically, and DMG files may need to be moved into the applications folder. Most operating systems have their own online store from which you can download and install programs. In the vendor store, you can browse for applications, select one, and then select Install, and the application will start downloading from the online store. Be sure to read the prompts from your device before uninstalling any programs and applications. Here are some reasons you might want to uninstall software. The software slows down your device. The software version on your device is outdated, or there is not enough available storage space on your device. Follow these steps to uninstall software in Windows. Navigate to Settings on your computer and then select Apps. From the Apps and Features list, select the application and then select Uninstall. And if prompted, verify that you want to uninstall the program. If you are using a more modern version of the Windows OS, such as Windows 10, you can uninstall a program or application from the Start menu by selecting the app tile and selecting Uninstall from the menu. Be sure to read any warning messages or prompts about uninstalling the software. Steps for uninstalling software on Mac OS devices depend on which version of Mac OS you are using. However, most uninstalling processes require the same or similar steps. To uninstall software in Mac OS, move the file or icon from the Applications folder to the trash, which is located on the dock, and be sure to empty the trash to make sure the application is removed. In this video, you learned that you should read the application details and be selective about what you're installing. You should view your minimum system requirements to determine which software and versions will work best for your project and what software will work optimally on your device. The process for installing software varies depending on your devices and operating systems. You should read and follow the setup instructions when installing new software. And for some software, you might need to perform several steps before uninstalling the software. For most modern software, you might only need to select the app and then uninstall. Welcome to Software Versions. After watching this video, you will be able to discuss software versions on computing platforms and identify software versions and numbering. Software versions tell us a lot about programs and applications. Users can determine what software version they are using, and developers can provide useful information with version numbers. Software version numbers vary in length and meaning. However, most version numbers follow a similar format and represent similar information. Version numbers indicate when the software was released, when it was updated, and if any minor changes or patches were made to the software. Software versioning is how software developers keep track of new software, updates, and patches for programs and applications. Version numbers can be displayed in several ways. Version numbers can be short or long depending on the software and the preference of the developer with 2, 3, or 4 number sets. Each number set is divided by a period. The first release of an application or program might have a 1.0 as the version number to indicate no updates, patches, or fixes to the software. Note, a version still in beta or testing could have a version number lower than 1, such as 0.9. A program or application with many releases and updates will have a longer number, sometimes 4 different number sets within the version number. Some software developers may use dates for their versioning. For example, Ubuntu Linux version 18.04.2 was released in 2018 April. The third number set, .2, designates an additional change or update. What do these numbers mean? Some version numbers follow the semantic numbering system and have 4 parts separated by a period, but not all numbering systems follow this 4-part example. In semantic numbering, the first number indicates major changes to the software, such as a new release. The second number indicates that minor changes were made to the software. The third number in the version number indicates patches or minor bug fixes. And finally, the fourth number indicates a build number or build date, and it can indicate less significant changes made. Software version numbers are identified in the About or Help section of software. You can practice identifying your version number in a web browser. This example illustrates how to view the version number in the Google Chrome desktop web browser. However, if you are using a different web browser, you should be able to follow the same or similar steps. To view the web browser version, first select the 3 dots or 3 lines in the top right corner of your browser. Next, select the menu item, Help, then select About to view the version information. The version of your web browser will display. Are newer versions of software compatible with older versions? Lack of compatibility between old and new versions of software is a common problem. You can troubleshoot compatibility issues by viewing the software version to determine if you are using an outdated version of the software. Sometimes updating software to a newer version will resolve compatibility issues. Some software is backwards compatible. If a program or application is backwards compatible, then the older versions of files, programs, and systems will work properly with newer versions. In this video, you learned that version numbers indicate the history of changes, updates, and patches to software. Some version numbers follow the semantic numbering system and have 4 parts separated by a period. Compatibility with old and new versions of software is a common problem. And you should view the version of the software you are using to determine software compatibility. Welcome to Productivity, Business, and Collaboration Software. After watching this video, you will be able to identify productivity software, define business software, and recognize collaboration software. 4 of the main types of software are as follows. Productivity software enables users to be productive in their daily activities. Business software is related to work tasks and business-specific processes. Collaboration software enables people to work together and communicate with each other. And utility software helps manage, maintain, and optimize a computer. It's important to note that a program or application can be categorized as multiple types of software. For example, most business software also falls into the productivity and the collaboration software types. What is productivity software? Productivity software is made up of the programs and applications that we use every day. This software can help manage activities and complete daily tasks. There are many types of productivity software, and here's a list of a few of them. Word processing software is employed to create, use, and edit documents. Some common examples are Microsoft Word, Pages on the Mac OS, and Google Docs. Spreadsheet software is used to create worksheets that perform calculations on data, such as statistics and financial information. Some common software examples are Microsoft Excel, Numbers on Mac OS, and Google Sheets. Presentation software helps users create slides for presentations, meetings, and gatherings. Most people are familiar with Microsoft PowerPoint, but Keynote and Google Slides are also common. Web browser software includes Google Chrome, Microsoft Edge, Mozilla Firefox, and Safari. Web browsers connect users to content on local networks or on the internet. You're probably watching this video, taking this course on a web browser right now. And finally, visual diagramming software helps users with creating, using, and editing visual files such as drawings, artwork, and photos. Examples of visual diagramming software are Adobe Photoshop, Adobe Illustrator, and Microsoft Visio. What is business software? Programs and applications that help businesses complete tasks and function more efficiently are considered business software. Some business software is uniquely designed to meet industry-specific needs. Some of the common types of business software are as follows. Database software can help businesses create, manage, and maintain databases. Some examples of database software are Microsoft SQL Server, MySQL, IBM DB2, Oracle Database, and Amazon RDS. Project management software is useful to help build, implement, track, and manage projects. Examples are Microsoft Project, Oracle NetSuite, Rike, and ZenHub. Business-specific software applications are created for businesses depending on their specific needs. Some companies might need a special application to perform essential business duties. Examples are Salesforce and Oracle NetSuite, which are customer relationship management or CRM systems, and WorkWise and SAP HANA, which are both enterprise resource planning or ERP applications. Another business software type is accounting software, which is used to track and manage financial transactions and records. Examples are Intuit QuickBooks, Xero, and FinSync. What is collaboration software? Collaboration software helps people and companies communicate and work with each other. Some collaboration software can be classified as business software also, but the two are not interchangeable. The primary purpose is to help users create, develop, and share information collaboratively. There are 5 common types of collaboration software. Email clients are used to send and receive emails. Common examples are Microsoft Outlook, Mail for Apple devices, and Gmail. Conferencing software connects users through video call, chats, screen sharing, and file sharing. Cisco WebEx is a popular example, but recently Microsoft Teams and Zoom have become a lot more common. Instant messaging software connects 2 or more users in real-time texts and sometimes video. Examples are Facebook Messenger, Snapchat, and Skype. Online workspaces provide an online space for services and applications, for file saving and sharing, and for working together. Examples are Microsoft Office 365, Slack, and Google Docs. And document sharing software hosts private and shareable file storage by cloud-based services. Examples are Microsoft OneDrive, Google Drive, and Dropbox. What is utility software? Utility software runs continuously on a computer without requiring direct interaction with the user. These programs keep computers and networks functioning properly. Some types of utility software are as follows. Anti-malware software scans the computer and individual files for malwares like viruses, spyware, worms, and Trojans. Anti-malware looks for suspicious patterns of computer code. Once a threat is identified, the anti-malware software removes it or quarantines it. Examples are Bitdefender, McAfee, and Norton Antivirus. Firewall software protects users from streams of network traffic that could harm their computers and networks. Some of the methods firewalls use to control traffic in and out of a network are packet filtering, proxy service, and stateful inspection. Some examples are Windows Firewall, pfSense, and Cisco Secure Firewall. And preventative maintenance software runs scans, checks, and diagnoses hard disks for errors. Some software also optimizes the performance of the computer. Some examples are Windows Disk Management, Check Disk, and Optimized Drives. Software usability. Most software is cross-platform software that runs on Windows, Linux, and Mac OS machines. Software applications are installed from a disk, flash drive, or downloaded from the internet, and then they are activated using the product key. Some commercial software, like Adobe Photoshop, Oracle NetSuite, and Intuit QuickBooks, can be purchased from the vendor and activated via a product key or activation key. In this video, you learned that productivity software like Microsoft Word and Adobe Photoshop helps users manage tasks, email, documents, projects, and activities. Business software such as Oracle NetSuite and Intuit QuickBooks helps people and companies complete business tasks. Collaboration software like Slack and Microsoft Teams enables people to work together and communicate with each other. And utility software such as McAfee and Cisco Secure Firewall keeps computers and networks functioning properly. Welcome to Types of File Formats. After watching this video, you will be able to list common file format types and identify common types of files by their extensions. Knowing the format of a file helps you determine which application is needed to open or run the file. Some common file formats are executable files, compression files, audio and video files, also known as media files, image files, and document files. You can identify the file format quickly by the file extension. File extensions tell users more information about files and the applications that use those files. They can do several different things. File extensions are identified by a period followed by a 3- or 4-letter extension or suffix. The extension tells the operating system which applications will run the files. The extension appears after the file name. In Windows applications, the extension will usually indicate what application will run the file. And they can indicate the file type, such as executable, compressed, or image. Executable files run programs and applications. The executables may be part of the operating system, an installation package, or an application that runs on the computer. Being familiar with the types of executable file types is important so you understand what will be running on your computer. Some executable file formats and extensions are as follows. EXE are Windows applications that may have several files with them that help them run on the computer. BAT files are batch files or scripts and include a list of commands that the computer must execute in sequential order. SH files run shell commands and scripts that are executable on Linux or Unix, which are equivalent to Windows BAT files. CMD are command files for Windows. They are also script files and contain commands that are completed in order. They are similar to BAT files. App files are a type of Mac application bundle, and MSI files are installer packages in Windows. What are compressed file formats? Compressed formats, also called compression formats, are used as follows. Combining files to save disk space. The most popular compression format in Windows is zip, and file compression is often discussed as zipping files or as zipped folders. Storing archived files, like old emails that might not need to be accessed regularly but should still be kept. And condensing any type of file, including media files. Common compressed formats are as follows. ZIP or ZipX is a compression format for Windows computers. 7-zip or 7z is used for the 7-zip archiver. gzip or gz is the default format for the gzip compression utility. ISO is a file system that uses writable CDs and DVDs or USB flash drives to create an optical disk image. JAR is a format for compressing Java class files and data. RAR is a format for the WinRAR file archive program. And TAR is a tape archive. What are audio and video formats? Audio and video formats are media files that can contain sound recordings, video recordings, or both. Audio files such as voice recordings, podcasts, music, and audiobooks are saved in audio formats. Video files such as movies, TV shows, video presentations, and music videos are saved in video formats. And because different media players support different media format files, it's important to know which format you have. Audio and video formats are sometimes listed together and sometimes share the same extensions. This is because they often share the same properties or have both video and audio data in them. Common audio files include WAV, MPEG, which includes MP3 and MP4 file types, AAC, and MIDI. Common video files include AVI, FLV, MPEG, which includes MP4 and MPG, and WMV. Images, photos, digital paintings, and pictures can be stored as image files. The BMP format is an older file format, but it is not used as often due to large file size. The GIF format can store and cycle through several graphics in one file. JPG or JPEG have smaller file sizes, but also have lower image quality. PNG has higher image quality than its predecessor, GIF. And TIFF, or TIF, saves images in a high-quality format, but the images do have a larger file size. While these are not all of the image formats, these are the most common. Files that rely on mostly text are saved as document files. Some document formats are as follows. TXT, or text files, are plain text with no formatting. RTF, or rich text format, is a word processing format used by most of the common word processing applications. It includes basic text formatting, headers and footers, and margins. DocX and Doc are used for Microsoft Word documents. XLSX and XLS are file formats for Microsoft Excel, a spreadsheet application. PDF format is primarily used by Adobe Acrobat and Adobe Reader. This format preserves document formatting so that no matter what device you open the file in, the file will look the same. And PPTX and PPT format are used for creating PowerPoint slides and decks for presentations. In this video, you learned that common file formats are executables, compressed, audio and video, image, and document. File formats are classified by name and extensions. Executable files run programs and applications. Some examples of executable files are exe, cmd, sh, bat, and msi. Compression files save disk space and are commonly used for archiving files or bundling large files. Common compression file types are zip, gzip, ISO, and jar. Audio and video files are media files. Some examples of audio and media files are WAV, MPEG, MP3, MP4, AVI, and WMV. Pictures, photos, and digital drawings can be stored as image files. Examples of common image files are BMP, GIF, JPEG, and PNG. And finally, document files are mostly text-based files, like DocX, PPTX, PDF, and RTF. Welcome to Common Web Browsers. After watching this video, you will be able to identify common web browsers and identify the components of a web browser. A web browser is the software interface that accesses resources on the internet, including text, images, music, video, and online games. As an internet user, you use a browser to request access to web pages on various websites. And it's the browser's job to request and retrieve that web-based content stored on a web server and display that content on web pages in the browser window on your device. You can use a web browser on several different types of devices, including desktop PCs, laptops, notebooks, tablets, smartphones, game consoles, and even smaller wearable tech devices such as smartwatches. It is estimated that in 2021, just over 5 billion people around the world used some type of web browser. According to statistical information provided by StatCounter Global Stats, as of October 2021, the most commonly used web browsers, according to worldwide market share across all platforms, are Chrome by Google, which has approximately 65% of the market share, Safari by Apple, which has around 19% market share, Edge by Microsoft, which has just under 4% market share, which is closely followed by Firefox by Mozilla, which has an approximate market share of just over 3.6%, the Samsung Internet Browser, which has just under a 3% share, and finally, the Opera browser, which has just over 2.3% share of the web browser market. Apart from the 6 most popular web browsers, there are several other alternative browsers that you could use instead. This table summarizes which browsers each operating system supports. Note that most web browsers can be used on any platform, but there are cases where the browser can only be used on a restricted set of operating system platforms, such as Apple Safari browser, which can only be used on the macOS and iOS operating systems. And similarly, the Samsung Internet Browser can only be used on Samsung Galaxy devices running Android 5.0 or later. A typical web browser is made up of various components. The user interface is where the user uses common UI elements, such as a search bar and an address bar, to enter a uniform resource locator or URL to search for content on the web. It includes navigation tools such as home, back, forward, and refresh buttons, along with other features such as history, bookmarks, and favorites to visit previously viewed pages or save links to web pages for later reference. The browser engine is the piece of code that is responsible for querying and controlling the rendering engine in the layer below it based on user interactions coming from the user interface layer above it, such as requests to load the URL and back and forward navigation when browsing. The rendering engine is responsible for presenting or rendering the requested web pages and content on your browser screen. Primarily, it interprets the hypertext markup language or HTML code, XML documents, and images, and presents them in an easily digestible format on your browser screen. The rendering engine can also display other kinds of data by virtue of plugins or extensions. The networking component retrieves the entered URLs by using Internet Communication Protocols, namely Hypertext Transfer Protocol, or HTTP, and File Transfer Protocol, or FTP. This component is also responsible for handling a cache of recently retrieved content, which it can reissue when requested. This reduces network traffic by eliminating the need to constantly retrieve files from a web source that have been previously retrieved and have not changed since the last retrieval instance. The JavaScript interpreter, as the name suggests, interprets and executes any JavaScript code embedded in viewed websites. The interpreted results are directed to the rendering engine to be rendered on your browser screen. The user interface, or UI backend, is responsible for drawing basic widgets, such as windows and combo boxes, by using underlying operating system UI methods to expose a generic interface that is not platform-specific or dependent. And lastly, there is the data persistence or data storage component, which is essentially a small database located on the local device that stores user data such as cache, session storage, cookies, bookmarks, and user profile preferences. These components work together to give a web browser its core functionality. In this video, you learned that a web browser is the software interface to access resources on the internet, including text, images, music, video, and online games. You can use a web browser from desktop PCs, laptops, tablets, smartphones, game consoles, and wearable tech devices, such as smartwatches. The 6 most widely used web browsers are Chrome, Safari, Edge, Firefox, Samsung Internet, and Opera. Most web browsers can be used on any platform, but some can only be used on a restricted set of operating system platforms. And finally, web browsers consist of several integrated software components. Welcome to Browser Installs and Updates. After watching this video, you will be able to identify how to obtain web browsers, and understand the need for web browser updates. So, how do you obtain a web browser? Well, there are really two options. It will either be provided as a part of an operating system, as is the case with Microsoft Edge on the Windows operating system, Safari on Apple devices, and Samsung Internet on Android devices. Alternatively, and in addition, you can download a web browser from a vendor's website or app store, but of course, for that you will first need a web browser to initially browse to the site or store. There is a huge amount of debate about which browser is better than the other, which is more secure than the other, which performs faster than the other, and so on. But as these web browsers are all free to obtain and use, you are also free to make your own decision about which one or more best suits your needs. So, there is absolutely nothing wrong or uncommon with having several different web browsers installed and running on your device. In any case, you will likely be asked by the operating system at some point to define your default browser. And this is the one the operating system will automatically use when you click a link in an app or an email, for example. You are probably already aware that it is important to keep your operating system and software applications up to date. Well, the same is true for your web browsers too. Here are some key reasons for keeping your web browsers updated. Compatibility with websites. As new web-based technologies emerge, websites start to use them, and therefore web browsers need to be improved and updated to support those new technologies. Any older versions of browsers that have not been updated may not be able to display or use some areas or features of a website. Security. If you don't keep your web browser updated to its latest version, it can lead to security vulnerabilities that expose your browser to the possibility of being compromised by some form of malicious software attack, such as a virus, keylogger, or spyware. These attacks can lead to the leakage of personal and/or financial information. New features. As developers add new or improved features to their browser software, or just generally improve its performance, your web browsers need to be updated to gain the benefits those improvements provide. Most of the top desktop web browsers provide standard fast release updates at the same release rate, which typically releases major updates every 4 weeks, but releases minor updates such as security fixes, crash fixes, and updates to policies on an as-needed basis within the 4-week period. This is currently the case for Google Chrome, Microsoft Edge, and Mozilla Firefox browsers. Aside from the standard fast release update frequency, some vendors also offer an extended release for updates, which provides updates at a much reduced frequency to help more structured environments such as large corporations, educational establishments, and government departments maintain browser stability over a longer period. Regardless of which flavors of web browser you use, updating them is relatively quick and simple. Most browsers have an automatic updates option that is often the default setting, which typically checks for updates every hour or so and on every browser restart. However, if needed, you can manually initiate a browser update too. For example, in Google Chrome, you select the Customize and Control Google Chrome icon in the top right corner of the browser window, point to Help, and then select About Google Chrome. Chrome will check for any available updates and download and install them. In Mozilla Firefox, click the Open Application menu icon in the top right corner of the browser window, then click Help, and then click About Firefox to check for updates. Firefox will check for any available updates, and you restart the browser to install the updates. In Microsoft Edge, click the Settings and More icon in the top right corner of the browser window, then point to Help and Feedback, and then click About Microsoft Edge. Edge will check for any available updates and download and install them. Once the update has been downloaded, you will need to restart Edge in order to complete the update process. Devices that run macOS regularly and automatically check for updates to the Safari browser and any other software installed via the App Store, and will prompt you to install updates as and when they are discovered using on-screen notifications. In the App Store, you can either update Safari alongside other applications as part of a single mass update process, or you can check for Safari updates only. If you want to manually check for and install updates to Safari only, select the Apple logo icon in the top left corner of the window, point to App Store, and then select the Updates tab. On the Updates tab, next to Software Update, select the More link. This will expand the System Applications list and enable you to select Safari from the list of applications. Next to the Safari version number, select Update, and the latest available version of Safari will then download and install. In this video, you learned that web browsers can be obtained as part of an operating system or via a download. The key reasons for keeping your web browsers updated are website compatibility, security, and new features. The top desktop web browsers provide major updates every 4 weeks and minor updates on an as-needed basis within the 4 weeks. And web browsers usually update automatically, but you can also update them manually if required. Welcome to Browser Plugins and Extensions. After watching this video, you will be able to define browser plugins, define browser extensions, and install and configure browser plugins and extensions. A web browser typically allows users to not only view HTML content, but also some other web-based content such as images, video, audio, and XML files. However, in most cases, to view other, more advanced types of content, you need additional software. A browser plugin, also sometimes referred to as an add-in or add-on, is essentially a small piece of software that provides some specific bit of additional functionality to a web browser. In this way, you can use plugins to customize your browser, and therefore your browser experience. So, a plugin extends the capabilities of your web browser. Common examples of a plugin are the Adobe Reader plugin that enables you to view PDF content, the Adobe Flash Player that lets you view FLV formatted videos, or the Java plugin that allows you to run applications written in the Java programming language. Typically, when you browse to a website that has this type of content available, and you do not already have the appropriate plugin installed, you will be prompted with a link to download it. It is also worth noting that as plugins are improved to support new features or are updated to increase security, you will need to update your installed plugins too. Many web browsers now update their plugins automatically, but some older browsers may not. A browser extension is an application that provides extended functionality for a web browser and allows users to customize their web browsers. Extensions and plugins may seem similar, and although they do provide seemingly similar benefits to a web browser, they actually work quite differently. A browser plugin is an executable piece of software code that gives you added functionality on a specific web page or website, whereas browser extensions typically consist of source code that is not executable, but they extend the core functionality and features of the web browser itself, hence the term extension. So, a browser extension can customize a web browser's context menus, add buttons and toolbars, manage cookies, and block pop-up ads, for example, but a browser plugin cannot. Browser extensions are widely used, but in the last few years, browser plugins have largely been deprecated by most popular web browsers, and they no longer support them. As mentioned previously, some modern browsers do not support plugins at all. So, in Google Chrome, for example, there is no longer a plugins page available to view or the option to disable installed plugins. In browsers that still provide some support for standard plugins, such as Mozilla Firefox, you can configure the plugin settings. In Firefox, you open the application menu, select add-ons and themes, and select plugins in the left menu, which then displays the installed plugins. Select the ellipsis button next to the name of the plugin and select Manage. Here, you can configure the individual plugins settings, such as allowing automatic updates. You can also configure general plugin settings in Firefox by selecting the Tools for All Add-ons button. Here you can check for updates, view recent updates, install add-ons from a file, and configure the automatic updates setting. To configure browser plugins in Internet Explorer, you open the Tools menu, then select Manage Add-ons. Select toolbars and extensions in the left menu, which then displays the installed plugins and extensions. By default, it shows all currently loaded add-ons, but you can change this to display all add-ons instead. Then you can configure an individual plugin, such as enabling or disabling it. The method for installing browser extensions varies slightly between different web browsers. For example, to install web browser extensions in Microsoft Edge, you select the Extensions button on the toolbar, select Open Microsoft Edge add-ons, search for the extension you want to install, select Get, and then select Add Extension. Your new extensions toolbar will now be visible in your web browser. Whereas, to install browser extensions in Google Chrome, you browse to the Chrome Web Store, then, in the Extensions section, you search for the extension you want to install. Select the extension from the suggested list, select Add to Chrome, and then select Add Extension. And your new extensions toolbar will now be visible in your web browser. To configure browser extensions in Microsoft Edge, select the Extensions button on the toolbar, select Manage Extensions, and then either select Details to configure the extension, or select Remove to delete the extension from the web browser. To configure browser extensions in Google Chrome, select the Customize and Control Google Chrome button, point to More Tools, and then select Extensions. Here you can either configure the extension by clicking Details, remove it, or simply turn the extension on or off using the toggle switch. You may have noticed that some browser settings only allow you to disable a plugin or extension, but they do not allow you to remove them. In these cases, you need to use the Uninstall feature on your computer. For example, in Windows 10, from the Start menu, you select the gear icon to open Settings, select Apps, and then select Apps and Features. From this list of apps and features, you select the plugin or extension you wish to remove and select Uninstall, then follow the instructions. You may also find that malicious plugins and extensions will typically not appear in the list of installed apps and features on your operating system, and they will require more work to remove. The simplest way to do this is to run some form of trusted anti-malware program, which will help you to remove the offending item. Genuine plugins and extensions developed by reputable organizations can be very useful additions to your web browser and are safe to download and use. So, to avoid malware, ensure you trust the source of a plugin or extension before you install it. In this video, you learned that a browser plugin is a small piece of software that provides some specific bit of additional functionality to a web browser. You need to update your installed plugins. Most modern web browsers update plugins automatically. Plugins are largely deprecated by the major web browsers. Extensions enable users to customize a web browser. Extensions can customize a browser's context menus, add buttons and toolbars, manage cookies, and block pop-ups. Extensions are widely used by all web browsers. And you should ensure you trust the plugin or extension source before installing it. Welcome to Basic Browser Security Settings. After watching this video, you will be able to identify and access basic browser security settings, manage proxy server settings, and manage cookie and cache settings. The method for accessing security settings in each web browser is slightly different, but most of them offer similar kinds of settings to enforce security and privacy. For example, in the Google Chrome web browser, to access these settings, you select the Customize and Control Google Chrome button, that's the vertical 3 dots in the top right corner, and select Settings. Then you select Privacy and Security from the left navigation menu, and from here you can configure several settings, including clearing browsing data, configuring cookies and site data, configuring safe browsing options and managing certificates, and site permissions. You can also navigate directly to this settings page by browsing to Chrome://settings/privacy in the address bar. And in Microsoft's Edge web browser, you can access security and privacy settings by selecting the Settings and More button, that's the horizontal 3 dots in the top right corner, and select Settings. Then, for most security settings, you select Privacy, Search, and Services from the left navigation menu. Here, you can configure several security settings, including tracking prevention, clearing browser data, privacy settings, managing certificates, blocking unwanted apps, secure browsing options, and services settings. You can also navigate directly to this settings page by browsing to Edge://settings/privacy in the address bar. In the left navigation menu, there is also a Cookies and Site Permissions option. Here you can manage and delete cookies and site data, as well as view and configure all your site permissions. You can also navigate directly to this settings page by browsing to Edge://settings/content in the address bar. Other security settings you need to consider are the proxy server settings. A proxy server acts as a go-between when you browse the web, so that to the websites you are browsing, the site visitor appears to be the proxy server rather than your computer. There are several advantages to using a proxy server. Firstly, it can help protect your privacy when browsing the internet or bypass certain content restrictions. It can also help organizations and educational establishments to maintain web security, web monitoring, and content filtering when their employees are browsing the internet. This helps organizations control what web content is being accessed, when it is being accessed, and by whom, typically to comply with organizational security policies. Using a proxy server can also help reduce an organization's bandwidth usage and improve the speed of web requests. Proxy servers essentially work by modifying the IP address information in a web request to web servers to make the request appear to be coming from the proxy server rather than from the original requesting client computer on the proxy server's network. So, the proxy server makes the request on the client computer's behalf. The response from the web server is sent back to the proxy server, and the proxy server then forwards the information onto the original requesting client computer. While retrieving the information on behalf of the requesting client PC, the proxy server will typically change the source IP address data and may also perform other tasks such as encrypting data and blocking access to certain categories of web content. To configure proxy server settings in Google Chrome, Microsoft Edge, and the Opera browser, you use the proxy settings defined by the operating system. For example, in Google Chrome and the Opera browser, you open Settings, then in the left navigation menu, expand Advanced, and select System. From here, you can select Open your computer's proxy settings. Similarly, in Microsoft Edge, you open Settings, then in the left navigation menu, select System and Performance, and again, you select Open your computer's proxy settings. In all cases in Windows 10, this action opens the proxy settings page. From here, you can either configure auto-detect proxy settings, or you can manually specify the proxy server address and port to use. Some other web browsers allow you to configure proxy settings that differ from those defined and controlled by the operating system. For example, in Mozilla Firefox web browser, you open Settings, then scroll down to Network Settings and select Settings. From here, you can either choose to use the operating system settings, which is the default, or you can choose Auto-Detect or manually configured proxy server settings. Other devices, such as tablets and mobile phones, also allow you to configure proxy settings. For example, on an iOS device, such as an Apple iPhone or iPad, you open Settings, then navigate to Wi-Fi and select the name of your wireless network. Then scroll down to the HTTP proxy section and select Configure Proxy. And just like for other web browsers, you can choose between Off, Manual, and Automatic for your proxy server settings. Cookies are small pieces of text-based data that contain information about your computer when browsing a website. This information can be used to save session information for when a user revisits a website and to provide a more customized and targeted experience for the user. A classic example of a session-based cookie would be one that retains data about items in an online shopping basket when you are purchasing goods on a website. While most cookies can be useful, you should also be aware of the risks they bring, such as invading your privacy by tracking your browsing activities and targeting you with unsolicited online ads, and potentially more seriously, using cookie fraud to falsify your identity on the internet or use your legitimate identity to carry out malicious activities. Cookies can be viewed and managed in your web browser settings. In Google Chrome, you navigate to Settings, Privacy and Security, and then select Cookies and Other Site Data. Many websites require cookies to be enabled on your browser in order to provide their online services, but there may be occasions when you wish to disable cookies, or at least be able to control whether they are created when you visit a website. You can allow all cookies, block third-party cookies, or block all cookies. Additionally, you may want to delete cookies when you no longer need them. You can also view the cookies currently saved by your browser. In the list of cookies, you can use the icons to either view the details about a cookie or delete it. Cache is the temporary area used by your web browser to store web data that can be quickly reused when requested, instead of needing to go back to the original source content. So, in this situation, if the web content hasn't changed since it was last retrieved, it can be served from the local disk rather than from the internet, and in this way, the cache can vastly improve the web browser's speed and performance and can help reduce bandwidth usage. If you want to ensure you are retrieving the latest content from the internet or are concerned about storing some data locally, you can clear or purge the cache from the disk. To manage cache in Google Chrome, navigate to Settings, Privacy and Security, then select Clear Browsing Data. In the Clear Browsing Data dialog box, you need to select the time range, which can be from 1 hour up to all time. Then select the cached images and files checkbox and select Clear Data. In this video, you learned that a proxy server acts as a go-between when web browsing. Proxy servers help organizations reduce bandwidth usage, improve speed of web requests, and maintain security. You can configure either manual or automatic proxy server settings. Cookies are the small text-based files containing information about your computer when browsing. Cookie settings can be configured to allow all cookies, block third-party cookies, or block all cookies. Cache is a temporary storage area, so data can be quickly reused when requested. And you can clear the cache from the disk when it's no longer required. Welcome to Browser Security Certificates and Pop-up Settings. After watching this video, you will be able to identify and access advanced browser security settings, verify security certificates for websites, and configure pop-up settings. The method for accessing security settings in each web browser is slightly different, but most of them offer similar kinds of settings to enforce security and privacy. For example, in the Google Chrome web browser, to access these settings, you select the Customize and Control Google Chrome button. That's the vertical 3 dots in the top right corner, and select Settings. Then you can select Privacy and Security from the left navigation menu. And from here, you can configure several settings, including configuring safe browsing options, managing certificates, and configuring site settings such as site permissions and pop-ups. You can also navigate directly to this settings page by browsing to Chrome://settings/privacy in the address bar. And in Microsoft's Edge web browser, you can access security and privacy settings by selecting the Settings and More button, that's the horizontal 3 dots in the top right corner, and selecting Settings. Then, for most security settings, you select Privacy, Search, and Services from the left navigation menu. Here, you can configure several security settings, including tracking prevention, managing certificates, blocking unwanted apps, and secure browsing options. And again, you can also navigate directly to this settings page by browsing to edge://settings/privacy in the address bar. When you are browsing websites, especially those that you have never visited before, and even more crucially, if you are using the website of a financial institution, such as an online bank, it is a good security practice to check the authenticity of those websites. You can identify a secure website by looking for the padlock icon next to the URL in the browser's address bar. And when you click the padlock, you should see the message, "Connection is secure." If you don't see the padlock icon and instead see a warning icon and the words "not secure" to the left of the URL, then this site is not using the Secure Sockets Layer or SSL protocol. So, in other words, you are accessing it by using the HTTP protocol rather than the more secure HTTPS protocol. SSL, or more accurately, SSL over TLS, or Transport Layer Security, is a protocol standard for secure communications between two systems over the Internet by virtue of encryption algorithms. When you see the not secure message to the left of the URL, it means that either the SSL security certificate on the website you are visiting has expired and therefore needs renewing by the hosting website, or the security certificate has been signed or authorized by an issuing authority that is not trusted by the browser. In other words, the certification authority, or CA, is not on the browser's built-in list of trusted certificate providers. If you click the Not Secure message, you will see a dialog box that informs you that the connection to the website is not secure, and the message also warns you about entering sensitive information on this site. Even when you are browsing a website that is displaying the padlock icon, if you are unsure about its authenticity or just want to dig a bit deeper into the security information behind that website, you can view the security certificate that has been issued to the web server hosting the website. The certificate is issued by a certification authority, or CA. To view a website security certificate in Google Chrome, browse to a website using the HTTPS protocol and click the URL address in the address bar to display the full URL. Select the padlock icon to the left of the URL and select Connection is secure. Then select Certificate is valid, and the web server certificate will open in a separate dialog box. Here you can view general certificate information, such as the issuing CA and the validity dates. On the other tabs, you can view detailed information about the certificate, such as its serial number, security algorithms, and its certification path back to the issuing CA. Many websites contain pages that host third-party scripts or pop-up ads, also known simply as pop-ups, which are typically used to target you for online marketing purposes. They can sometimes be a little annoying as they might distract you from your intended purpose and can literally get in the way of what you are trying to view on a website. But while they may be simply annoying, there is also the potential for them to be malicious as well, and the developers of these pop-ups will usually associate them with some form of on-screen activity, such as clicking a button. The button could be labeled Close or Cancel, and therefore may appear to be totally legitimate. Another common type of malicious pop-up is ransomware that looks like a notification from a government agency, such as the IRS or the FBI. Ransomware is malware that can enable hackers to take control of a victim's computer if they click a link in the pop-up notification. So, to maintain security and for a better browsing experience, you should be very careful when interacting with these kinds of items. It is also important for you to know how to block these items when browsing a website. Most modern web browsers include built-in tools for blocking pop-ups, but there are many third-party pop-up blockers or ad blockers available on the market, such as AdBlock, AdGuard, AdBlock, Ghostery, and AdBlock Plus. And some of these include additional features, such as ad filtering. Today's modern web browsers block pop-ups by default. This is typically indicated in your web browser by an icon in the browser's address bar or a notification dialog box. To modify Google Chrome's behavior when encountering pop-ups, open Settings and select Privacy and Security. Select Site Settings and then scroll down to the Content section and select Pop-ups and Redirects. Here you can choose which default behavior to use for pop-ups. The options are either to allow all sites to send pop-ups and use redirects, or to not allow any sites to send pop-ups and use redirects. However, you can also customize this default behavior by adding sites to the allowed list and/or the blocked list. For example, here we have added the popuptest.com and amazon.co.uk sites to the blocked list, and the skillup.tech and bbc.co.uk sites to the allowed list. Note that you can use the syntax square bracket asterisk dot square bracket before the domain name, which will then include all subdomains as well. In this video, you learned that it is a good security practice to check the authenticity of websites you are visiting. You can identify a secure website by looking for the padlock icon next to the URL in a browser's address bar. Pop-ups are typically used to target you for online marketing purposes. And while pop-ups are annoying and distracting, they can also be malicious. Modern web browsers include built-in pop-up blocking tools, but you can also use third-party pop-up blocking apps. And you can modify your browser's default behavior when encountering pop-ups. Welcome to Private Browsing and Client-Side Scripting Settings. After watching this video, you will be able to enable private browsing mode in web browsers and manage client-side scripting settings. If you want to hide your browsing activity, then you can utilize private browsing, which is a web browsing mode that does not save the kinds of information about your activity that a standard browsing session would, such as the history of visited websites, passwords entered, data entered in web forms, cookies, and session cache. This data is deleted when you close the private browsing window. But please note that this only hides the information locally from people who might use the web browser on the device after you. It does not hide the information from your Internet Service Provider or ISP, or from the websites and web servers that you visit. Additionally, your place of education or your workplace might also be able to view this data. All the major web browsers have a private browsing mode, but they refer to it by different names. For example, in Google Chrome, it is called Incognito Mode. In Microsoft Edge, it is referred to as In Private. And in Firefox and Opera browsers, it is simply called Private Browsing. In Google Chrome, you can start a private browsing session by selecting the Customize and Control Google Chrome button in the top right corner, then selecting New Incognito window. In Microsoft Edge, you select the Settings and More button in the top right corner, then select New in Private window. And in Opera, you select the Customize and Control Opera logo in the top left corner, then select New Private window. Alternatively, in all three of these cases, you can use the shortcut key, which is Ctrl+Shift+N. But in the Mozilla Firefox browser, the shortcut is Ctrl+Shift+P. In the early days of the World Wide Web, most web pages were written in HTML, and they were fairly static pages. That is, the page looked the same to every user who visited it. This issue was resolved by the development of dynamic web pages that could adapt to the needs of different scenarios and different viewers of the web page. These dynamic pages are generally generated in one of two ways. Either the processing is done by the server that is hosting the dynamic content. This is referred to as server-side scripting. Or the client computer is responsible for the processing, which is referred to as client-side scripting. With client-side scripting, special code is embedded in the web page itself, and the user's web browser does the required processing to retrieve the data. By far, the most common example of this kind of client-side scripting code is JavaScript. These client-side scripts will generally provide a set of instructions to be performed by the browser. The key benefits of client-side scripts are that users can see the scripts on the front end. They do not need to rely on server resources, and therefore they can help reduce the load on servers. However, although client-side scripting can be very useful, it also brings its own dangers in terms of security implications. In theory, the instructions contained in the code that is processed by the web browser could instruct the browser to perform all manner of malicious actions, including accessing settings and data on the local computer. Fortunately, web browsers are designed with inbuilt security measures to mitigate against most of these kinds of security threat, such as restricting the code to only executing within the browser and therefore not allowing access to the local computer system. However, malware developers are constantly trying to find new ways to circumvent these security measures or detect flaws in them. Therefore, it is important for you to be able to control client-side scripting in your web browser. To help you decide whether or not you should disable JavaScript in your web browser, here are some pros and cons of disabling it. First, some of the pros. The major pro for disabling JavaScript is security. One of the biggest known potential issues with JavaScript is suspicious web pages, and the possibility and opportunity for malicious code to be run in your browser that could adversely affect your computer. Browsing speed could be improved by eliminating the dynamic content that JavaScript can provide. Not all browsers are capable of supporting and running JavaScript effectively, as they can each interpret the code in a different manner, which could lead to inconsistencies in functionality and the overall browsing experience. If you disable the JavaScript programming language, you can make sure that your browser successfully views and loads pages correctly, particularly in the case of older web pages and websites. Another major issue for Internet users is that companies can track their Internet usage and then sell that data onto other interested companies. If you disable JavaScript, a lot of the cookies that are responsible for the gathering of this personal information will no longer function correctly. And now, some of the cons. When you disable JavaScript, you lose the ability to view a lot of the useful dynamic content that is available on the Internet, such as images, videos, maps, and various types of media. Additionally, many of the features that create the user interface will disappear, which can look very confusing and hard to read on a website that contains a lot of JavaScript-based content. With JavaScript disabled, it can be much harder and take much longer to search for and scroll through the content on dynamic web pages, and you may find yourself needing to continually click on next links to progress through the content. If you want to stop JavaScript scripts being run in your web browser, you can disable them in your web browser settings. For example, in Google Chrome, you select Settings, then Privacy and Security, then Site Settings, and then under the Content section, you select JavaScript. Here, you can set the default behavior to either allow all sites to run JavaScript or to not allow any sites to run JavaScript. The default for this setting is to allow all sites to run JavaScript. If you want to set a custom behavior for some sites, you can either block specific sites from running JavaScript scripts, or you can allow specific sites to run them. As before, you can use the syntax **** in front of the domain name to include all subdomains as well. When deciding whether to block these client-side JavaScript scripts or not, you need to balance between the additional functionality they provide on a website against the potential security risks they might pose. This is what you might see when you visit a website that you have added to the list of sites that are not allowed to run JavaScript code. You then have the option of continuing to block JavaScript on this site or allowing it. In this video, you learned that you can hide your browsing activity by using private browsing, which does not save historical information about your activity. Private browsing only hides the information locally from people using the web browser on the device after you. Dynamic web pages can adapt to different situations and different users. With client-side scripting, code is embedded in the web page and the user's web browser performs the required processing. And you can stop JavaScript scripts being run in your web browser or on specific sites. Welcome to Introduction to Cloud Computing and Cloud Deployment and Service Models. After watching this video, you will be able to describe cloud computing concepts, define cloud deployment models and cloud service models, and identify the characteristics of cloud computing. Cloud computing, also referred to as the cloud, is the delivery of on-demand computing resources such as networks, servers, storage, applications, services, and data centers over the internet on a pay-for-use basis. The term cloud computing can be used to describe applications and data that users access over the internet rather than on their local computer. Examples of cloud computing include users using online web apps, employees using secure online business applications to conduct their work, and users storing personal files on cloud-based storage platforms such as Google Drive, OneDrive, and Dropbox. One of the main user benefits of cloud computing is that instead of users needing to purchase their own applications and install them locally on their computer, they can use online versions of those applications and pay a monthly subscription. Not only is this typically more cost-effective initially, but users can also access the latest version of the application without having to purchase a full retail copy of the newer version. A side advantage of this is that the user also saves lots of local storage space as the application is hosted online. And the beauty of most cloud-based applications is that they also enable users to work collaboratively with their colleagues working on the same files in real time and being able to see each other's edits and updates. Cloud computing is composed of 5 essential characteristics, 3 deployment models, and 3 service models. Let's start with understanding the 5 essential characteristics of the cloud. On-demand self-service means that you get access to cloud resources such as the processing power, storage, and network you need using a simple interface without requiring human interaction with each service provider. Broad network access means that cloud computing resources can be accessed via the network through standard mechanisms and platforms such as mobile phones, tablets, laptops, and workstations. Resource pooling is what gives cloud providers economies of scale, which they pass on to their customers, making cloud cost-efficient. Using a multi-tenant model, computing resources are pooled to serve multiple consumers, and cloud resources are dynamically assigned and reassigned according to demand, without customers needing to know the physical location of these resources. Rapid elasticity implies that you can access more resources when you need them and scale back when you don't, because resources are elastically provisioned and released. And measured service means that you only pay for what you use or reserve as you go. If you're not using resources, you're not paying. Resource usage is monitored, measured, and reported transparently based on consumer utilization. As you have seen, cloud computing is really about using technology as a service, leveraging remote systems, on demand, over the open internet, scaling up and scaling back, and paying for what you use. And it has changed the way the world consumes compute services by making them more cost-efficient, while also making organizations more agile in response to changes in their markets. Cloud deployment models indicate where the infrastructure resides, who owns and manages it, and how cloud resources and services are made available to users. There are 3 types of cloud deployment models: public, private, and hybrid. Public cloud is when you leverage cloud services over the open internet on hardware owned by the cloud provider, but its usage is shared by other companies. Private cloud means that the cloud infrastructure is provisioned for exclusive use by a single organization. It could run on premises, or it could be owned, managed, and operated by a service provider. And when you use a mix of both public and private clouds working together seamlessly, that is classified as the hybrid cloud model. Now, let's look at the 3 cloud service models that are based on the 3 layers in a computing stack: infrastructure, platform, and application. These cloud computing models are aptly referred to as infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. In an IaaS model, you can access the infrastructure and physical computing resources, such as servers, networking, storage, and data center space, without the need to manage or operate them. In a PaaS model, you can access the platform that comprises the hardware and software tools that are usually needed to develop and deploy applications to users over the Internet. And an SaaS is a software licensing and delivery model in which software and applications are centrally hosted and licensed on a subscription basis. It is sometimes referred to as on-demand software. In this video, you learned that cloud computing is the delivery of on-demand computing resources over the Internet on a pay-for-use basis. Cloud computing is composed of 5 essential characteristics, 3 deployment models, and 3 service models. The 5 essential characteristics of cloud computing are on-demand self-service, broad network access, resource pooling, rapid elasticity, and measured service. There are 3 types of cloud deployment models: public, private, and hybrid. And the 3 cloud service models are based on the 3 layers in a computing stack: infrastructure, platform, and application, and they are referred to as infrastructure as a service, or IaaS, platform as a service, or PaaS, and software as a service, or SaaS. Welcome to Application Architecture and Delivery Methods. After watching this video, you will be able to define application architecture models and define application delivery methods. When developers create an application, they must ask, how will an application be used and how will it be accessed? Also, will the application be 1-tier, 2-tier, 3-tier, or N-tier? Depending on the size of the application, developers need to determine the application architecture that will work best. The 1-tier architecture is a single-tier model. It is also sometimes referred to as the monolithic model. All the components of an application run on one local computer. The 2-tier architecture model consists of 2 sides: a workspace-based client, like your personal computer, and a web server or a database server. It's a 2-tier model because the application is kept in 2 places: the hardware of the user and the hardware of the server. The 3-tier architecture divides applications into 3 tiers: the workspace-based client, the application server or web server, and another server like a database server. The benefit of a 3-tier architecture is that each tier can be individually developed and updated by a separate team, and each tier can be modified and upgraded without affecting the other tiers. The N-tier model has a number of tiers. The N in N-tier stands for number. Sometimes it is referred to as a multi-tier model. It has a workspace-based client tier, like a personal computer. It could also have a web server or a database server tier. It might have a security tier. And it has several other tiers with additional servers. And the N-tier model is more popular than the 1-tier monolithic pattern because it is more in line with the microservices pattern and the agile model. There are some advantages and disadvantages of N-tier applications. Some of those are: code changes and updates can be made to specific tiers, which takes less time than changing all tiers. Each tier can have its own security settings. Different tiers can be load balanced, distributing application activity in the least busy server in a group of servers where the application is hosted. Tiers can be individually backed up by IT administrators. And changes, updates, and backups may take longer because there are more tiers. There are several different ways that applications can be available to users: local installation, hosted on a local network, and cloud hosted. A user can locally install an application, such as a game, on their computer. The application exists on their local computer and a network connection is not required. Files for the application are saved locally on the user's personal device. Some applications are local network hosted. Applications are used over a hosted network, such as over a local area network or LAN, or a wide area network, WAN. Users can access the applications on the server's local storage. An internet access is not required, however, a network like a LAN or WAN is required. Cloud-hosted applications are available over the internet. To use the application, internet access is required and normally paid access or a subscription to the service that provides the application is required. And files are saved in the cloud, so they do not need to be saved locally to your computer or device. In this video, you learned that application architecture models are made up of 1-tier, 2-tier, 3-tier, and N-tier models. The benefits of a 3-tier architecture are that each tier can be individually developed and updated by a separate team, and it can also be modified and upgraded without affecting the other tiers. N-tier models are currently the most used because changes can be made quickly to individual tiers. Each tier can have its own security settings. Tiers can be load balanced, and each tier can be individually backed up. And finally, application delivery methods are local installation, hosted on a local network, and cloud-hosted. Welcome to Software Development Lifecycle. After watching this video, you will be able to describe the Software Development Lifecycle or SDLC framework, explain the different phases of the SDLC, and identify the various SDLC models. The SDLC is a structured framework that defines the steps in creating and developing software. Organizations follow a detailed plan to develop, maintain, or enhance specific software. The SDLC framework details a methodology for consistent software development that ensures quality software production. There are 6 major steps in the SDLC process: requirement analysis and planning, design, coding, testing, deployment, and maintenance. In the first stage of the SDLC, the requirement analysis and planning phase, all relevant information is gathered from the customer. As part of the planning process, labor and material costs are calculated, targets are estimated, and project teams and leaders are proposed. Feedback is also gathered from stakeholders on the requirement analysis document. When planning a software solution, several factors must be considered: users of the solution, overall purpose of the solution, data inputs and outputs, legal and regulatory compliance, risk identification, quality assurance requirements, allocation of human and financial resources, and project scheduling. These specifications are combined into a document called a Software Requirement Specification, or SRS document. The SRS document needs to be clearly understood and approved by the stakeholders. The developers are also involved at this stage for a clear understanding of the requirements. In the design phase, the requirements gathered in the SRS document are used as an input, and a software architecture is developed and reviewed by the stakeholders and team. The document created in this phase is called a design document, and it is used by developers for the coding process. The coding or implementation phase is when the developers start the coding process once the design document is baselined. The project planners assign code development tasks to the developers, and teams in turn start coding. A modular or microservices approach is often used, and code chunks are created as outlined in the design document. This is one of the longest phases of the SDLC process. The testing phase is next in the process once coding is complete. Some large projects have dedicated testing teams. Created code needs to be thoroughly tested to ensure it is stable, secure, and performs the necessary functions. Testing can be manual, automated, or a hybrid of both. Product bugs are reported, tracked, and fixed, and code is retested until the software is stable. Some common testing types are unit testing, regression testing, integration testing, and stress testing. The deployment phase is where the application is released into the production environment and made available to users. This can also happen in stages. First, it is released onto a user acceptance testing or UAT platform, and once the customer signs off on the functionality, it is released to production. This approach can be used for making software available on a website, mobile device app store, or a software distribution server on a corporate network. The maintenance phase, once the code has been deployed into the production environment, is required to fix any issues as they come up, or to enhance the code as needed. If bugs are discovered in this phase that were missed during testing, then these errors are fixed or planned as part of a future software release. At each phase of the SDLC cycle, documentation is maintained and metrics are recorded and evaluated for compliance. There are various models that implement the SDLC methodology. Some of the popular ones are waterfall, iterative, spiral, V-shaped, agile, and lean. A waterfall model is also called a linear sequential model. The output of one phase is the input for the next phase in the cycle. Development and work on the next phase start only after the completion of the previous phase. The iterative model is also called an iterative incremental model. Product features are developed iteratively, and once all iterations are complete, the final product build includes all the features of the product. The spiral model uses both the waterfall and prototype models. It is best suited for large projects, and it reduces risk to a large extent. The spiral model has 4 phases: planning, risk analysis, engineering, and evaluation. The spiral model phases are followed iteratively. The V-shaped model is also called a verification and validation model. Development and testing are concurrent, that is, testing is implemented parallel to the development phase. The Agile model focuses on a collaborative software development process over multiple short cycles rather than a top-down process. Teams work in cycles or sprints, which are 2 to 4 weeks long. Testing happens in each sprint to minimize the risk of failure. Agile is a form of an iterative approach to development. At the end of each iteration, a minimum viable product is developed that can receive user feedback, and this process is repeated for every sprint cycle. The 4 core values to Agile development are individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. The lean model is the application of lean principles to software development. Like Agile development, the lean model also focuses on delivery speed, continuous improvement, and reducing waste in every phase. The lean methodology is based on 7 principles: eliminate waste, build in quality, create knowledge, defer commitment, deliver fast, respect people, and optimize the whole. DevOps methodology evolved from application of Agile and lean practices to operations work, wherein development and operations teams work collaboratively to accelerate the deployment of software products. There are some differences between a traditional SDLC and the Agile method of software development. Traditional SDLC centers around the whole product being developed before being sent to the customer, and the Agile focuses on short, quick bursts of development. Research and planning are often completed at the beginning of a project in a traditional SDLC. The Agile development is different, relying on ongoing research, planning, and testing during product development. When adding new features into a project, development must go through the same waterfall process of a traditional SDLC, but in Agile, new features are handled quickly and easily. In this video, you learned that the SDLC is a framework for software development in a systematic manner. The SDLC phases are broadly classified into 6 steps: requirement analysis and planning, design, coding, testing, deployment, and maintenance. And there are several SDLC models. The most popular ones include waterfall, iterative, spiral, and agile. Welcome to Interpreted and Compiled Programming Languages. After watching this video, you will be able to identify interpreted programming languages and identify compiled programming languages. What are programming languages? Programming languages help us tell computers what to do. Computers don't use human language, they use their own language called machine code. Machines understand binary code, that is, ones and zeros, so to make communicating with computers easier, we have human-readable programming languages. Two common categories for programming languages are interpreted and compiled. These are broad categories, and there are many programming languages that are classified under compiled languages and interpreted languages. The purpose of the project helps a developer determine which programming language is best. Interpreted language is also commonly referred to as scripted or scripting language. Programs written in interpreted or scripted language, like Python and HTML, run through the programming interpreter on your computer's operating system or in your web browser. Remember that programming languages are in human-readable code, so the interpreter takes the human-readable scripted code and then translates it into machine code, enabling the computer to complete the requested task. As computers and web pages have changed and advanced, some interpreted programming languages are outdated, and they are not as useful or relevant. Some other languages are more versatile and easier to learn, which means they are preferred over other scripting languages and are used more often. All interpreted programming languages need an interpreter to translate the source code. Translators are built into your web browser, or they require a program on your computer to translate the code. Several different interpreted programming languages exist. Some examples of common interpreted programming language types are JavaScript, a simpler scripting language that runs through the web browser interpreter. Python, a language that is popular because it is easy to learn and use for developers. Lua, a general-purpose, lightweight game scripting language that is easy to learn and use. And HTML, a markup language used for formatting web pages. Another category of programming languages is the compiled programming languages. Compiled programs are applications and programs, like your music app or your operating system, that you run on your computer or device. The programs are packaged or compiled into one executable file. They are usually larger programs. Compiled programs are used to help solve more challenging problems like interpreting source code. Compiled programming languages are often referred to more simply as programming languages. A compiler program creates a program file, which runs the software. Simply put, it piles the code into one file that runs when you double-click on the app on your device. The program runs faster, and it can be done repeatedly. The source code is converted from the programming language to machine code. Then it is compiled into one executable file. Finally, the program runs when you select the icon or file on your device. Some examples of compiled programming languages are C and its variations, C++ and C#, which are used in many operating systems like Microsoft Windows, Apple's Mac OS, and the open source operating system, Linux. Java is another compiled programming language. It shouldn't be confused with the interpreted language JavaScript. The Android OS is written in Java because it works well across computing platforms. Let's look at this process. When you update to a new version of your operating system, like Microsoft Windows, your device might download an installation program. That program is made up of many files. The files are written in a compiled programming language. These files give instructions to your device in machine code. The compiled program is running on your device. A compiled program that you commonly use is your device's operating system, such as Linux, Microsoft Windows, Apple's Mac OS, or Android. Your operating system is written in a compiled programming language, like C, C++, C#, or Java. In this video, you learned that interpreted programming languages run scripts that are repetitive and need to be run often. Interpreted programming languages are more versatile and can be used across platforms as long as there is the correct interpreter. Some examples of interpreted programming languages are JavaScript, Python, and HTML. Compiled programming languages are for more complex programs that complete larger tasks. Compiled programming languages are used for creating executable files that can run directly from your device. And some examples of compiled programming languages are C and Java. Welcome to Comparing Compiled and Interpreted Programming Languages. After watching this video, you will be able to compare interpreted and compiled programming languages and discuss interpreted and compiled programming languages. How do developers choose a programming language? Developers choose which programming language is best to use depending on what they have the most experience with and what they trust, what is best for their users, and what is the most efficient to use. What are interpreted and compiled programming languages? Interpreted programming languages are used to create a scripted source code for smaller tasks. The source code goes through an interpreter. The interpreter is built into the operating system on a computer or on a web browser. Compiled programming languages are used to create files. The files are executable files. They are then grouped in programs that you can run on a computer or device. Interpreted programming languages are also called script code or scripting because they are used to automate tasks. Interpreter programs read and execute the source code line by line like someone would read a script. Each time the program runs, the source code needs to be executed to receive the desired output. And source code written in one of the interpreted programming languages runs on almost any operating system with the right interpreter. For example, imagine you have a client requesting information about web page views for last month. Which type of programming language would be the most appropriate and efficient to create a program for this task? You would use one of the interpreted programming languages to write code for a script. The script would retrieve the web page views data and then put it into a table for the client to read. Compiled programming languages are also called programming languages for short. They are used for more complex programs that complete larger tasks like running a spreadsheet program on your computer. A compiled programming language is used to write a larger program, usually installed on your device as an executable file. Writing code in a compiled language does take longer, but the payoff is that the program's code runs faster because compiled programs are installed on the device. And once the program is coded, the compiled program is grouped into one downloadable file. Remember that client who wanted information about web page views? Now they want a spreadsheet program to view and manage the data. A programmer could use the C programming language to create a compiled program like Microsoft Excel. So, what are the major differences between interpreted programming languages and compiled programming languages? First, there's interpreted programming. These programs are available across multiple platforms or in the cloud. The scripting languages are easier to learn and use, and they're better for websites because they tackle smaller, repeated processes. Then there's compiled programming. These programs are available to users with the same operating system coded in the same language. However, compiled programming languages are more difficult to learn and use because they are larger programs with more parts. And they're better for larger tasks like running the operating system on your computer. To better understand more of the similarities and differences of programming languages, let's take a look at some examples. A few of the most common programming languages are C, C++, and C#. C is a compiled programming language. C is the original language, and C++ and C# are variations. C and its variations are case-sensitive languages. The C programming language is the basis for Windows and other common operating systems. and it takes more time to learn and use for coding, but requires less memory and the code runs faster. Another common programming language is Java. It is a compiled programming language. It is also a case-sensitive, object-oriented programming language. The Java Virtual Machine, or JVM, is required to run the code written in Java. It is the primary programming language for some operating systems, like the Android OS. And a benefit of Java is that it is a cross-platform language, which means it runs the same code on Mac OS, Windows, and Linux. Python is an example of an interpreted programming language. It is also referred to as a scripting language. Python is a popular general-use case-sensitive programming language. It is used with Windows, Mac OS, and Linux operating systems, and with server-side web app code. And it requires the Python engine to interpret code. JavaScript is another interpreted programming language. It is a scripting language that runs on the client side in web browsers. JavaScript is case insensitive. Simple scripts are run with HTML. Complex scripts are run in separate files. And while it sounds similar, it shouldn't be confused with Java, the compiled programming language. Another example of a common programming language is HTML. It is an interpreted programming language. HTML stands for Hypertext Markup Language. HTML is mostly case insensitive with some exceptions, and it uses tags to format web pages on client-side web browsers. In this video, you learned that interpreted programming languages create source code that runs through an interpreter in your device's operating system or on your web browser. Compiled programming languages create executable files that are grouped in programs on your device. Compiled programming languages, like C and Java, are used to write larger programs like operating systems and other executable files. And interpreted programming languages, like Python and HTML, are used to write code that can complete repetitive tasks within a web browser or a computer. Welcome to Query and Assembly Programming Languages. After watching this video, you will be able to compare high-level and low-level programming languages, describe query languages, and describe assembly languages. Let's explore query and assembly programming languages. But first, we need to categorize programming languages into two levels, high-level and low-level. A high-level programming language is more sophisticated and uses the common English language to make its code more understandable and to increase the speed of coding and debugging programs. Examples of high-level programming languages include query languages, such as Structured Query Language or SQL, structured programming languages, such as Pascal, and object-oriented programming languages, such as Python. In contrast, a low-level programming language uses a set of symbols to represent machine code. Examples of low-level programming languages include assembly languages such as ARM, MIPS, and x86. A query is a request for information from a database. The database handles the query and searches its tables for the information requested and returns the results to the querying entity. When querying a database, it is important that both the user application making the query and the database handling the query are speaking the same language. In programming terms, writing a query means using predefined and understandable instructions to make the request to a database. This is achieved using programmatic code, and this is what we refer to as a query language. A query language may also be referred to as a database query language. By far the most prevalent query language for database queries and database management is SQL. However, there are other query languages available, such as AQL, CQL, Datalog, and DMX. In addition to SQL databases, there is another type of database called NoSQL, which stands for Not Only SQL. The key difference between these two types of databases is their data structures. While SQL databases are relational and use structured, predefined schemas, NoSQL databases are non-relational in nature and have dynamic schemas for unstructured data. A query language is predominantly used to request data from a database or to create, read, update, and delete data in a database. You will likely see the term CRUD used to refer to these last four key database operations. Typically, a user enters a command to either make a query or perform a CRUD operation using syntax that is understandable to the database management system hosting the database. And a database typically consists of structured tables made up of multiple rows and columns of data. When a user performs a query, the database retrieves the data from the relevant rows and columns in the table and arranges it into some sort of order ready to be returned and presented in the query results. Database queries are either a select command or an action command such as create, insert, update, or a mixture of both. The term statement is more commonly used to describe these commands. Select queries request data from a database, whereas action queries manipulate data in a database. Query statements can also be used to perform other administrative functions, such as creating users and modifying permissions. This table lists some of the most common SQL query statements. And here are some simple syntax examples of common SQL statements. As mentioned earlier, assembly languages are less sophisticated than query languages, structured programming languages, and object-oriented programming languages. As an assembly language uses a simple set of symbols to represent the zeros and ones of machine code, it is categorized as a low-level programming language. Assembly languages are closely tied to the processor architecture from hardware manufacturers, and therefore each CPU type will typically have its own assembly language. For this reason, there are a large number of assembly languages in use today, which vary among hardware manufacturers. Assembly languages use a simple, readable format for their statements, and they are entered one line at a time with one statement per line. Assembly language statements use the standard format shown here. In this syntax, all fields in curly brackets are optional, and the statement has two main parts. The first part is the instruction, or the mnemonic, and the second part includes the parameters, or the operands. There may also be optional useful comments added on the end of the statement. One other key difference with assembly languages is that they are translated using an assembler instead of a compiler or interpreter, and one statement translates into just one machine code instruction, as opposed to high-level languages where one statement can be translated into multiple machine code instructions. Assemblers translate assembly language into machine code using mnemonics such as input, INP, output, OUT, load, LDA, store, STA, and add, ADD. The statements consist of opcodes that tell the processor what to do with the data and operands that tell the processor where to find the data. In this video, you learned that query languages, structured programming languages, and object-oriented programming languages are categorized as high-level programming languages. Assembly languages are categorized as low-level programming languages. A query language is predominantly used to request data from a database or to manipulate data in a database. The most prevalent query language for database queries and database management is structured query language, or SQL. Select queries request data from a database, whereas action queries manipulate data in a database. You also learned that assembly languages use a simple set of symbols to represent the zeros and ones of machine code. Assembly languages are closely tied to the processor architecture from hardware manufacturers. Assembly languages are translated using an assembler instead of a compiler or interpreter. And assembly language instructions have a one-to-one association with their machine code counterpart. Welcome to Understanding Code Organization Methods. After watching this video, you will be able to explain why code organization methods are important when programming, define the different code organization methods, and identify the benefits of using code organization methods. Organizing is very important when it comes to reading, maintaining, and configuring code. Well-planned out software design, usually using one of several methods, helps programmers write cleaner and more reliable code. Planning out code in a visual format helps improve the code base once it is written and reduces the chance of bugs and errors throughout the lifespan of a project. Organizing code before programming has a positive impact on the quality of the program and helps provide a consistent and logical format to use while coding. There are two main methods of organizing code, flowcharts and pseudocode. The main difference between pseudocode and a flowchart is that the former is a basic high-level description of an algorithm. An algorithm is a step-by-step sequence of solving a given problem. A flowchart is a pictorial representation of an algorithm, showing the steps as boxes of various shapes and colors connected by arrows that indicate their order. Flowcharts are used in designing or documenting a process or program. Pseudocode provides a beneficial bridge to the project code because it closely follows the logic that the code will. Pseudocode also helps programmers share ideas without spending too much time creating code, and it provides a structure that is not dependent on any one programming language. Flowcharts are especially beneficial for smaller concepts and problems, while pseudocode is more efficient for larger programming projects. And flowcharts provide an easy method of communication about the logic and offer a good starting point for the project because they are easier to create than pseudocode in the beginning stages. A flowchart is the graphical or pictorial representation of an algorithm using different symbols, shapes, and arrows in different sizes and colors to demonstrate a process or a program. The main purpose of using a flowchart is to analyze different methods of solving a problem or completing a process. Several standard symbols are applied in a flowchart, and you can easily highlight certain elements and the relationships between each part in the process. Some traditional flowchart shapes used for programming concepts are start-end, a capsule, process, a rectangle, decision, a diamond, data, a parallelogram, and connectors as arrows. A simple flowchart to represent how to add two numbers is easy to create. The procedure starts with the capsule and has a connector or arrow progressing to the next step, the data input, the parallelogram, in this case, input N1 and input N2. Then another connector or arrow goes to the process, the rectangle of adding the two inputs, sum equals N1 plus N2. Another connector or arrow moves to the data, the parallelogram, showing the result, in this case, print sum. And the last connector or arrow moves to the end of the process, the end capsule. Flowchart software is an application that provides various functionalities to create flowcharts by providing the ability to drag shapes into the desired order using an easy-to-use editor. Flowchart software also provides team collaboration for creating flowcharts. Some of the well-known flowchart software programs include Microsoft Visio, Lucidchart, Draw.io, and Draw Anywhere. Pseudocode is an informal type of programming description that does not require any strict programming language syntax or underlying technology considerations. System designers write pseudocode to ensure that programmers understand a software project's requirements and align code accordingly. Pseudocode is used for creating an outline or a rough draft of a program that summarizes a program's flow but excludes underlying details. Pseudocode acts as the bridge between the programmer's brain and the computer's code executor that provides the ability to plan instructions that follow a logical pattern without including all the technical details. Pseudocode is a great way of getting started with software programming as a beginner without worrying about coding syntax. Pseudocode helps both programmers and non-programmers agree about the program's goal and the basics of how the task should be done. Here's one example of pseudocode written to check if the user entered an odd or even number. The next example displays the pseudocode written in C++. There are many advantages of using pseudocode over flowcharts. The main benefit of pseudocode is that it's simple and explains exactly what each line of an application should do. The coder can focus more on logic than on program language syntax. Removing the distractions of coding when using pseudocode makes the code development stage easier. Words and phrases in pseudocode represent lines of basic computer operations that simplify translation from the pseudocode algorithm to the specific programming language. Pseudocode allows programmers working in different computer languages to interact with each other. Pseudocode can be reviewed by different development groups, easier than real code. Pseudocode is easier for non-programmers to read and enables quick and easy translation to any computer language. Writing pseudocode is more concise and easier to modify, so changes to the design can be easily incorporated. And lastly, unlike some flowcharts, pseudocode is usually less than 1 page. In this video, you learned that organizing and planning out software design enables programmers to write cleaner and more reliable code. And organized code is very important from a readability, maintainability, and scalability standpoint. Two main methods of organizing and planning software code are by developing flowcharts or writing pseudocode. A flowchart is a pictorial representation of an algorithm, showing the steps as boxes of various kinds, connected by arrows that indicate their order. And the main goal of pseudocode is to explain exactly what each line of a program should do, making the code construction phase easier for the programmer. Welcome to Branching and Looping Programming Logic. After watching this video, you will be able to describe the two types of programming logic, define Boolean expressions and variables, and list the differences between branching and looping. There are two major types of programming logic, branching and looping. Both types use Boolean expressions and variables. A Boolean expression is a type of programming statement with only two values, either true or false, and variables have assigned values that are passed into a function or subroutine within a more extensive program. Computers use Boolean logic to make decisions. The computer takes one action if a Boolean expression is true and a different action if the expression is false. Typically, a program consists of instructions that tell the computer what to do and data that the program uses when it is running. A variable has a value that can change depending on conditions or information passed to the program. Boolean logic, along with variables, form the basis of programming. Branching logic is where a computer makes a decision following a different set of instructions depending on whether certain conditions are met during the program's execution. Each possible code pathway creates another branch. The branch of code that runs depends on the values assigned to the parameters of the branching procedure, and there is no limit to the number of branches to implement complex logic. The values of these parameters may be input by the user or generated by the output from a previous procedure. Branching contains constructs that occur and are processed to determine the path a program takes when running. Branching statements, also known as constructs, allow the execution flow to jump to a different part of the program. The common branching statements used within other control structures include if then else, switch, and goto. The if statement is a decision-making construct that guides a program to make decisions based on specified criteria. The if statement executes one code set when a specific condition is met, true, or another code set if the condition is not met, false. The if-then-else is a conditional construct that executes its substatement, which follows the then keyword. This only occurs if the provided condition is true. The if-else statement extends the if statement by specifying an action if the if, or true-false expression, is false. With the if-else statement, the program will execute either the true code block or the false code block, so something is always performed with an if-else statement. In computer programming languages, a switch statement is a type of selection control mechanism used to allow the value of a variable or expression to change the control flow of program execution via search and map. Goto is a statement found in many computer programming languages that performs a one-way transfer of control to another line of code. In contrast, a function call typically returns control. Now, let's look at the logic of looping programming. A loop is a sequence of instructions that continually repeats until reaching a specific condition. Typically, a particular process is performed, such as retrieving and changing data, and then some conditions are checked, such as whether a counter has reached a prescribed number. If it has not, the next instruction in the sequence is to return to the first instruction in the series and repeat the sequence. If the condition is reached, the next instruction falls through to the next sequential instruction or branches outside the loop. A loop is a fundamental programming idea commonly used in writing programs. There are three basic loop statements: while, for, and do while. In a while loop, a condition is evaluated before processing the body of the loop. If a condition is true, then and only then the body of the loop is executed. In a for loop, the initial value is performed only once. Then the condition tests and compares the counter to a fixed value after each iteration, stopping the for loop when false is returned. And in a do-while loop, the condition is always executed after the body of a loop. It is also called an exit-controlled loop. In this video, you learned that there are two major types of programming logic: branching and looping. Both types of logic use Boolean expressions and variables. Boolean expressions have only two possible values, either true or false, and variables have assigned values that are passed onto a function or subroutine within a more extensive program. Variables have values that can change depending on conditions or information passed to the program. And branching is deciding what actions to take, while looping is deciding how many times to perform a certain action. Welcome to Introduction to Programming Concepts Part 1. After watching this video, you will be able to describe the purpose and use of identifiers in programming, and describe the purpose and use of containers in programming. To fully understand software programming, there are some fundamental programming concepts you need to know first. The first concepts you will look at are identifiers. Software developers use an identifier to reference a program component, such as a stored value, a method, an interface, or a class, by assigning a custom named label to it. If the identifier stores data, then the data values in the program can be one of two types, either a constant or a variable. A constant is a data item whose value does not change within a program. This could be a numerical constant, such as the mathematical value of pi, or it could be a text string that remains constant, such as a player's name within a game. Constants are also referred to as named constants. You assign a value to a constant when you define it. For example, you might want it to refer to a numerical value within your program, such as pi, or a cost price, or a rate of tax. And then, rather than repeatedly retyping the same numerical value, you can just declare a constant for the value instead and name it something meaningful like pi_value or cost_price or tax_rate. There are a couple of major benefits to using constants in your programs. One is for ease of readability in your code, and the other is that if the specified value changes in the future, you only need to change it once on the constant, rather than finding every instance of that numerical value within your code and changing it. The other type of identifier used in programming is a variable. As the name suggests, this kind of identifier is not constant. Its value can change during the program's execution. such as a user entering their age in an application or a high score in a game. Variables can be strings of text, numerical values, or any other type of data. Using a variable as an identifier is a useful way to refer to program items that are unknown to you, such as a username, a service, or a file name, for instance. If you don't use a variable, then you will need to hard code all the names and values in your program, which is not considered best practice. Variables can be declared and assigned a data type and initial value as they are defined, or you can decide not to assign an initial value when you define a variable and instead have the value assigned later by instructions within the program. In addition to the identifier data structures already discussed, there are also special kinds of identifiers that can reference multiple elements in a program, and these are referred to as containers. Being able to specify multiple elements means that you don't have to create a variable for every individual element. This makes it faster and more efficient. For example, if you only want to store 6 numerical integers, then you could argue that you could just create 6 variables, one for each. But what if you need to store 1,000 integers or more? In such a case, defining 1,000 variables would obviously be an unwieldy and inefficient programming technique. So in this case, you would use a container. There are 2 types of containers to specify multiple elements, arrays and vectors. The simplest of these container types is an array. In an array, a fixed number of elements of the same type are stored in sequential order starting from index 0. When you declare an array, you specify the data type of the values it contains, such as an integer, or Boolean, or a string, and then the maximum number of elements it can contain. The syntax for declaring an array is to specify the data type first, then the name of the array, then the maximum size of the array in square braces. In contrast to arrays that have a fixed size, vectors have a dynamic size, and they will automatically resize themselves as you add elements to them or remove elements from them. For this reason, you may also see them referred to as dynamic arrays. Because they are dynamic in nature, vectors take up more memory space than arrays, and their elements also take a little longer to access than elements in an array, as they are not stored in sequential memory locations. The syntax for declaring a vector is to specify the container type of the vector first, then specify the data type in angle brackets, then the name of the array. Note that because it is a vector, you do not need to specify a maximum number of values it can contain because the size is not fixed, it is dynamic. In this video, you learned that software developers use an identifier to reference a program component. If an identifier stores data, then it can either be a constant or a variable. A constant is a data item whose value does not change within the program. A variable is not constant, it can change during the program's execution. In an array, a fixed number of elements of the same type are stored in sequential order, starting from 0. And vectors have a dynamic size, and they automatically resize themselves as elements are added or removed. Welcome to Introduction to Programming Concepts, Part 2. After watching this video, you will be able to describe the purpose and use of functions in programming, and describe the purpose and use of objects in programming. Next, let's look at the fundamental concept of functions. Functions are a consequence of the modular programming software development methodology that encourages the separation of a program into multiple modular components, where each performs a specific task within a program. So, a function is essentially a piece of structured, standalone, and reusable code that will perform a single specific action. This enables software developers to take a substantial, complex program and divide it into smaller, more manageable, and focused pieces. Although some programming languages may refer to them as something else, such as subroutines, procedures, methods, or modules, most modern programming languages refer to them as functions. Functions take in data as an input, then process the data, and then return the result as an output. There are essentially two types of functions. Standard library functions are the built-in functions provided by the programming language. Common examples include the if, else, while, and print functions. But programming languages also allow you to write your own functions, and once you've written a function, you can use it over and over again. The way that the blocks of code that make up a function are identified is different across programming languages. Some use braces, some use begin and end statements, and others use indentations, for example. There are a few steps to using functions. The first thing you need to do is define or create a function. When you define a function, you provide a function keyword, then give the function a unique name, and you provide the statements that make up the body of the function. Once a function has been defined, it then needs to be called or invoked. When you call a function, the specified actions within the function are performed using any specified parameters. While defining and calling functions are common to all programming languages, some programming languages, such as C and C++, also require you to declare a function. Next, let's look at the concept of objects. Understanding what objects are is key to understanding object-oriented programming. Object-oriented programming, or OOP, is a programming methodology that is focused on objects rather than functions, which is what procedure-oriented programming is focused on. The objects themselves will contain data in the form of properties or attributes, and code in the form of procedures or methods. The key distinction between the two methodologies is that where procedural programming uses methods to operate on separate data structures, OOP packages them both together so an object operates on its own data structure. Consider the real-world objects in your life, such as your car, bike, TV, or your washing machine, and ask yourself the following two questions. What states can the object be in, and what behaviors can the object perform? When you think about your answers to these questions, you will find that the answers to these questions vary across the objects. More complex objects will typically have more potential states they can be in, and will be able to perform more behaviors. In programming, a software object is similar to a real-world object, conceptually speaking, in that they too consist of states or properties and behaviors or methods. Software objects can be anything, such as a Windows service, a user account, a database table, or a system folder. Objects store their properties in fields, referred to as variables in some programming languages, and expose their behaviors through methods, referred to as functions in some programming languages. In this video, you learned that a function is a piece of structured, standalone, and reusable code that will perform a single specific action. The defining and calling of functions is common to all programming languages. Object-oriented programming is a programming methodology that is focused on objects rather than functions. And software objects consist of properties and methods. Welcome to Types of Data, Sources, and Uses. After watching this video, you will be able to identify different types of data, recognize data sources, and list some of the ways to use data. Today's world is full of data, but how do we define data? Data is any set of characters that is gathered and translated for some purpose, usually research or analysis. Data can consist of facts, observations, perceptions, numbers, characters, symbols, images, audio, text, or any combination of these. There are multiple types of data, including these common types: single character, Boolean, true or false, text, string, number, integer or floating point, picture, sound, and video. Data can be classified as primary or secondary. Primary data is generated directly by the individual needing the information. Secondary data is information that has already been gathered for another purpose. Raw data, also known as primary data, contains numbers, instrument readings, and figures collected from sources. In the context of an examination, the raw data might be a raw score. When processed, this raw data output can be analyzed and studied. Data and information are collected on a computer using a hard drive or another storage device. Data is stored in binary form using zeros and ones. There are several forms of data. Personal data is anything specific to an individual, like name, demographics, location, address, and other identifying information. Transactional data is anything that requires an action to collect the information. Clicking online advertisements, making an online purchase, and visiting certain websites are all forms of transactional data. Transactional data is crucial for businesses, helping them to expose variability and optimize operations. Web data refers to any data pulled from the Internet for research or other purposes. Web data is a catch-all for public-facing information on the Internet. In other words, not stored in a private database. Companies can use this information to monitor competitors, track potential customers, keep track of channel partners, generate leads, and build applications. Sensor data is information produced by objects and is often known as the Internet of Things. This type of data covers everything from a smartwatch measuring heart rates and temperature to a building with external sensors that measure the weather or turn on lights when motion is detected. Currently, sensor data's primary use is to help optimize processes. The level and rigidity of the data's structure determine the information's classification. Data can be structured, semi-structured, or unstructured. Databases store and display structured data in rows and columns similar to an Excel or Word table. The information has a well-defined schema and a rigid structure. These characteristics make relational databases, which store data in tables, ideal for structured data. Microsoft SQL Server, IBM DB2, and Oracle databases are forms of structured data. Semi-structured data has some organizational properties. However, the information does not collect in the rows and columns required by a rigid tabular schema. Instead, semi-structured data is organized into a hierarchy using tags and metadata and is stored in non-relational databases. Unstructured data is information that does not have an identifiable structure or specific format, sequence, semantics, or rules, and is often stored in NoSQL databases. The most common examples of unstructured data include text like Word documents and emails. However, unstructured data also includes images, audio files, and log files. MongoDB, HBase, CassandraDB, and Oracle NoSQL DB are forms of semi-structured and unstructured data. A multitude of data sources are available today, including internal organizational data stored in a database, publicly available data like weather, financial, and government, APIs and web services, websites, data streams and feeds, social platforms, and devices with sensors. This data is stored, processed, and made available for analysis, providing businesses with insights into their performance. Data sources can be internal or external. When an individual collects data from reports and records supplied by an organization, group, or other entity, this is known as internal sourcing. Examples of internal sources include accounting information, order processing details, payroll, and shipping information. When users collect data from sources outside an organization, group, or other entity, this is known as external sourcing. Examples of external sources include social media feeds, weather reports, government information, and research. Companies use internal and external data to scale up businesses, understand customer purchasing trends, and increase overall productivity. In this video, you learned that data is information like facts, observations, perceptions, numbers, characters, and images that are processed to become meaningful. For example, upper and lower case letters, numerals, and special characters. Data can be structured, semi-structured, or unstructured depending on the level and rigidity of its organization. Different data sources offer different types of data. For example, data from social media can be unstructured or semi-structured. And data is essential to many organizations and is used to manage information from accounting to shipping and routing. Data is generated constantly in today's world, 24 hours a day, 7 days a week. Welcome to Database Fundamentals and Constructs. After watching this video, you will be able to describe the fundamentals of databases, recognize the need for databases, and identify database constructs. A database is a computerized record-keeping system that stores large quantities of information and provides tools for evaluating and manipulating data. Database users can search, research, analyze, compare, change, and manipulate information within a database with optimal speed and minimal processing. A database is built and maintained using a programming language. The most common is SQL, but SQL has multiple flavors, depending on the type of database. And there are two types of databases, relational and non-relational. A database has four main components. A schema is a collection of one or more tables of data. A database can contain one or more schemas. A table is one or more columns of data, like in an Excel spreadsheet. A table can have two or more columns depending on the type of stored data. A column is a pillar of information containing one or more data values, including dates, numeric or integer values, and alphanumeric values. And a row is horizontally formatted information, like rows in an Excel spreadsheet. Typically, there may be hundreds or thousands of rows of data in a table. Additional terms associated with a database are queries and constraints. A query can either be a request for data results from a database, action on the data, or both. A query can also provide an answer to a simple question, perform calculations, combine data from different tables, and add, change, or delete data from a database. Constraints are made up of primary keys, which are the rules enforced on the data columns, certifying that the values in any column row do not repeat. Constraints limit the type of data that can go into a table and ensure the data's accuracy and reliability in the database. When setting up a database, it is usual to define a set of queries used to answer questions from the data in the database. The output produced by the database is called a report. Queries are an important part of using a database. A query is a way of requesting information from a database, and there are two types of queries, select or action. A select query retrieves data, and an action query requests additional actions to be performed on the data, like deletion, insertion, and updating. A frequently used query is the create table statement that creates a new table in the database. The column parameters specify the names of the columns of the table. The data type parameter specifies the type of data the column can hold. For example, varchar, integer, date, and so on. Another common query is the select statement that retrieves records from a database table according to clauses. For example, from and where that specify criteria. The select clause specifies one or more columns to be retrieved. To specify multiple columns, use a comma and a space between column names. To retrieve all columns, use the wildcard star or asterisk. The from clause specifies one or more tables to be queried. Use a comma and space between table names when specifying multiple tables. And the where clause selects only the rows in which the specified column contains the specified value. The value is enclosed in single quotes, for example, where last underscore name equals Smith. The semicolon is the statement terminator, and if only one statement is sent to the back end, the statement terminator is not necessary. However, it is a best practice to include the statement terminator regardless. Some common relational database constraints are primary and foreign keys. A primary key is the column or columns that contain values that uniquely identify each row in a table. In this figure, the primary key is ID. A database table must have a primary key defined to insert, update, restore, or delete data from a table. A foreign key is a column or set of columns in a table whose values correspond to the values of the primary key in another table. In this figure, the foreign key is class ID. For each foreign key value, a row in the related table must exist with the same primary key value. A database management system, or DBMS, has the following characteristics. It provides security and removes redundancy, has the same self-describing nature as a database system, grants program data independence, meaning there is insulation between programs and data abstraction, supports multiple views of the data, shares data and multi-user transaction processing, allows entities and relations among them to form tables, follows the atomicity, consistency, isolation, and durability or ACID concept. And a DBMS supports a multi-user environment that allows users to access and manipulate data in parallel. Many industries use databases, including universities, banking, and telecommunications. A flat file database, also known as a text database, stores data in a single table and can be set in various application types, including HTML documents, simple word processors, or worksheets in spreadsheet applications. The tables within a flat file database can be sorted based on column values. Flat files serve as a solution for simple database tasks. A database is another method of storing information. A database uses multiple table structures, cross-referencing records between tables. A database can store information in multiple table structures with records organized in columns and rows, with each column containing a single piece of data. Finally, databases are faster, more efficient, and more powerful than flat files. Here is an example of a flat file database that stores information about students in a school, identifying their form and form teacher. There are two issues with trying to store this data in a flat file database. Redundant data. Some data can be stored more than once, wasting storage space and causing inconsistencies. And data inconsistency. Multiple tables within a database deal with the same data, but may receive it from different inputs. Data redundancy can compound data inconsistency. In a relational database, data is stored in multiple files linked by common fields. Here is the same data stored in two files in a relational database. Relational databases have two important advantages over flat file databases. Control over redundant data. Wherever possible, storing data once eliminates the wasting of storage space. And data consistency. Because each data item is stored only once, there cannot be two different values, so the data will always be consistent. Here are some of the many differences between flat files and databases. Flat files do not support multi-user access, while multiple users can access a database at one time. Databases with permissions and privileges are more secure than flat files. Flat files are usually one file, and databases can have a large amount of records. A database can contain multiple databases within it, unlike flat files. Searches and other transactions within flat files are faster than in databases. Most databases support complicated transactions, flat files do not. And flat files are easy to set up without needing specific expertise. Special training may be required to configure a database. In this video, you learned that a database is a computerized record-keeping system to store large quantities of information. A database provides tools that give the ability to search through stored data for specific bits of information. When creating a database, organize data so that the computer can analyze and search it automatically. Databases include schemas, tables, columns, and rows. Databases also contain queries and constraints. A query is a way of requesting information from the database, and constraints are the rules that apply on the type of data in a table. And there are two types of databases, flat files, and relational databases, and each has advantages. One of the main differences is a flat file has a single record, while a database can have multiple records. Welcome to Database Roles and Permissions. After watching this video, you will be able to describe how database permissions work, explain how permission commands enforce database security in a multiple user database environment, and identify the benefits of roles in a database. Permissions are authorizations enabling a particular user to access a specific database or database table. There are three main types of database permissions in decreasing scope: database, system, and object. Database permissions and privileges execute a specific type of SQL statement or access a second person's object. Database privilege controls the use of computing resources and does not apply to the database administrator or DBA. System permission is the right to perform an activity, such as to create, alter, or drop on a specific type of object. The ability to add or delete columns and rows of any table in a database is an example of system permission. Object privilege is the right to perform a specific action on a particular table, function, or package. For example, the right to delete rows from a table is an object privilege. This privilege allows the user to insert, delete, update, or select the data in the database object. An object's owner has all object permissions for that object, and those permissions cannot be revoked. The object's owner can grant object permissions for that object to other database users. A user with admin privileges can grant and revoke object permissions from users who do not own the objects on which the permissions are granted. Permission commands enforce database security in a multiple user database environment. There are three main permission commands: grant, revoke, and deny. The grant command provides user access rights or permissions to the database objects. This command also allows users to grant access rights to other users. Here is the syntax for the grant command. The revoke command removes user access rights or permissions to the database objects. Here is the syntax for the revoke command. And the deny command denies permission on an object and prevents the principal from gaining grant permission based on membership in a group or role. Here is the syntax for the deny command. Only a database administrator or the owner of a database object can provide or remove permissions on a database object. A database role is a collection of any number of permissions that can be assigned to one or more users. Roles allow you to grant and manage sets of permissions for various categories of users rather than grant those permissions to each user individually. The DBA maintains user roles and applies them to the entire server and not to an individual database file. The public role sets the basic default permissions for all users. Every user that is added to a SQL server is automatically assigned to the public role, so no additional actions are needed. Database roles are applied to an individual database. The table contains a list of some of the more common user roles and their associated access levels. Database roles can be granted to set system or schema object permissions to other roles. However, a role cannot be granted to itself and cannot be granted circularly. For example, role A cannot be granted to role B if role B has previously been granted to role A, to any database user, to a user as either enabled or disabled. A user's security domain includes the permissions of all roles currently enabled for the user and excludes the permissions of any roles currently disabled for the user. Roles can be enabled or disabled to provide selective availability of permissions. Indirectly to a role, this means that the role can be explicitly enabled or disabled for a user. However, by enabling a role that contains other roles, you implicitly enable all indirectly granted roles of the directly granted role. And roles can be granted or revoked at any time. In this video, you learned that permissions provide the authority to access a database, tables, objects, and other system resources in a specified manner to allow selection, insertion, or modification of data rows. A database role is a collection of any number of permissions that can be assigned to one or more users. Roles allow granting and managing sets of permissions for various categories of users rather than granting those permissions to each user individually. And roles can be granted and revoked at any time, allowing for more flexibility in maintaining a database. Welcome to Data Types. After watching this video, you will be able to define the different types of databases, identify relational databases, and describe non-relational databases. There are 3 types of data: structured, semi-structured, and unstructured. Structured data is generally tabular data that is represented by columns and rows in a database. The databases in this form are called relational databases. The mathematical term relation is specific to a formed set of data held as a table. In structured data, all rows in a table have the same set of columns. One example of structured data is structured query language or SQL programming language. Here is an example of semi-structured data. Semi-structured data has some structure to it and consists of documents held in JavaScript Object Notation or JSON format. This type of data also includes key value stores and graph databases. Unstructured data contains a lot of types of information and is not organized in a predefined manner or data model. This type of data is usually text-heavy but may contain numbers, dates, and other characters. Videos, audio, and binary data files might not have a specific structure and are considered unstructured data. Some specific examples of unstructured data types are text files and documents, server website application logs, images, video files, emails, social media data, audio files, and sensor data. There are 2 types of databases, relational and non-relational. A relational database is structured to recognize relations among stored items of information. A non-relational database stores data in a non-tabular form and tends to be more flexible than the traditional SQL-based relational database structures. A relational database, or a SQL database, stores data in tables that contain rows and columns. The rows in a database are called records. Relational databases store related data information with a defined relationship between database tables used with other datasets. A relational database works by connecting multiple data tables with unique identifiers known as keys, which allow for the connected relationship between tables. Relational databases apply to structured data sources and have connections within the database. Examples of relational databases include MySQL, IBM DB2, Oracle, SQLite, Postgres, and MS SQL. A non-relational database is a non-SQL database, also known as a NoSQL database, that stores unstructured data. Non-relational databases are not restricted to data being in tables and therefore differ from structured relational databases in that there are no tables, rows, or keys. Instead, a range of different types of data can be stored in different formats using specialized frameworks. Non-relational databases are ideal for storing and combining big data and unstructured data, offering more flexibility in working with this type of data over relational databases. Examples of non-relational databases include MongoDB, Apache Cassandra, Redis, Couchbase, and Apache HBase. Non-relational databases permit storing store data in a format that more closely meets the original structure. There are many types of data stores, but the following are encountered most often: document data stores, key value stores, column-oriented databases, and graph databases. A document data store handles a set of objects, data values, and name string fields in an entity referred to as a document. These data stores generally store data in the form of JSON documents. Here is an example of the document data store model. A key value store is a large hash table with each data value associated with a unique key to collect data by using a correct hashing function. The hashing function is preferred. It provides an even distribution of hashed keys across the data storage. Key value stores are highly suitable for applications operating simple lookup functions using the value of a range of keys. A columnar or column family data store constructs data into rows and columns. The columns are divided into groups known as column families. Each column family consists of a set of columns that are logically related and are generally retrieved or manipulated as a unit. Within a column family, rows can be sparse and new columns can be added dynamically. A graph data store handles two types of information, edges and nodes. Edges point out the relationships between these entities, and nodes represent entities. The aim of a graph data store is to allow an application to efficiently perform queries that traverse the network of edges and nodes, and to inspect the relationships between entities. In this video, you learned that there are three types of data. Structured data is organized in a relational database, semi-structured data is partially organized, and unstructured data is based on simple character and binary data. Relational databases store data in rows and columns, and non-relational databases do not have a predefined manner or data model. There are different NoSQL databases for storing non-structured data. And non-relational databases store different types of data in various formats using specialized frameworks. Welcome to Interfacing with Databases. After watching this video, you will be able to describe the working principle behind interfacing a database, and identify the four main ways of interfacing with databases. A database interface enables users to input queries to a database without using the query language itself. Interfaces are an electronic form that contains what kinds of queries users can make. Web-based forms are becoming increasingly common with the popularity of MySQL, but the traditional way to do it has been local desktop applications. Mobile applications can also be designed to provide a friendly way of accessing data. The application poses a query to the database system with the help of SQL. There, the corresponding result set or answer is prepared and with the help of SQL given back to the application. This communication takes place interactively or can be embedded into another language. There are two types of database interface: interactive SQL, which can be used from a terminal, and embedded SQL, which can be embedded into another language or host language, which might be used to create a database application. A database can be accessed in a variety of ways: direct or manual access, programmatic access, user interface or utility access, and query or report builders. Direct access or manual access is when a user enters SQL commands and selects a menu to access the tables in a database. Users can directly access database tables to view or change data. Direct access works well when it only needs to be accessed by a few users and with a database that is stored locally or on a local area network. The following figure is an example of editing a table directly in Microsoft Access database. Programmatic access uses a programming language to access a database that enables the data to be used in more ways. This type of access is safer than using direct access. Oracle databases support access from many languages, including Oracle PL/SQL, which combines a procedural language with SQL, Oracle JMS, a Java Application Programming Interface API, ProCC, C++, and others. Depending on the database and programming language, it might be necessary to perform a query using a supported language and then connect to the result with the language you prefer. This table showing product ID, product name, and price is an example of connecting to SQL Server from a Python program and extracting data and displaying information. The server name, database name, and table name are given in this code example. A database, like Microsoft Access, is designed to permit database access through its user interface. With SQL databases, an optional user interface may be needed to make usage easier. Oracle offers MySQL Workbench as a graphical user interface, or GUI, for use with MySQL. A database management system, or DBMS interface, is a user interface which allows for the ability to input queries to a database without using the query language itself. DBMSs provide the following benefits: web-based interfaces for web clients or browsing, form-based interfaces. A GUI displays a schema to the user in diagrammatic form. The user can specify a query by manipulating the diagram. GUIs utilize both menus and forms. Most GUIs use a pointing device, such as a mouse, to pick a certain part of the displayed schema diagram. And natural language interfaces have their own schema, like a database conceptual schema that accepts user requests and tries to interpret them. Search engines use a natural language interface to enter and retrieve information. This image is querying a table in MySQL using the MySQL Workbench interface. A query is used to find specified data in a database by using the select statement. Some databases, like Microsoft Access, have built-in query and reporting functions. Query Builder provides a GUI for creating SQL queries and is designed to enhance productivity and simplify SQL query building tasks. Users can drag multiple tables, views, and columns into a visual designer to generate SQL statements. The Query Builder can perform the following tasks: work with a graphical representation of a query or SQL code. Query Builder includes a pane that displays a query graphically and a pane that displays the corresponding SQL text. Join related tables. When adding more than one table to a query, Query Builder automatically determines how the tables are related and constructs the appropriate join command for data extraction. Query or update databases. Returns data using select statements to create queries that update, add, or delete records in a database. And view and edit results that are immediate. Some examples of query builders are Chartio Visual SQL, DBForge Query Builder for SQL Server, Active Query Builder, FlySpeed SQL, QueryDB-Viz, and Query Builder. This image displays a query built using FlySpeed Query Builder, where the user selects the tables and the columns he needs in each table. In this video, you learned that a database interface enables interaction between the user and a database management system. And there are many ways to access a database, but the common ones are direct access, programmatic, user interface, and query and report builders. Welcome to Database Management. After watching this video, you will be able to describe how databases are managed, identify the three major SQL command categories and what each one does, and explain how to input and extract database information. Databases are managed with structured query language, or SQL, commands and queries. A database query refers to the retrieval and management of data or information from a database. A database query generates data of different formats according to function. Query commands perform the retrieval and management of data in a relational database. With SQL commands, you can provide access to data in relational database management systems, describe the data, manipulate the data, create and drop databases and tables, view stored functions and procedures in a database, and set permissions on tables, procedures, and views. SQL commands can be grouped into the following categories based on functionality: data definition language, or DDL, data manipulation language, or DML, and data control language, or DCL. DDL consists of the SQL commands used to define the database schema. DDL commands enable you to create, modify, and delete database structures, but not data. Common DDL commands include the following: the create command that creates the database or its objects, such as tables, indexes, functions, views, store procedures, and triggers. The drop command that deletes objects from the database, the alter command that alters the structure of the database, and the truncate command that removes all records from a table, including all spaces allocated for the records. This is an example of a drop command where table is the name of the table to be deleted. DML includes most of the SQL commands that deal with the manipulation of data in the database. The DML command is the component of the SQL statement that controls access to the data and to the database. Common DML commands include the following: the insert command that inserts data into a database table, the update command that updates existing data within a database table, the delete command that removes records from a database table, and the select command that retrieves records from a database table according to clauses, for example, from and where that specify criteria. This is an example of the delete command. DCL includes commands which mainly deal with the rights, permissions, and other controls of the database system. DCL commands create and modify the structure of objects in the database. DCL commands include the following: the grant command that provides users with access permissions to the database, and the revoke command that withdraws users' access permissions given by the grant command. Here is an example of the revoke command. One way of inserting data into a database is through queries. Some of these query commands include create database, create table, and insert into table. Here is an example of inputting data into a relational database using these commands. The other way to input data is by importing it from external sources into a database using software tools and utilities. This example shows inputting an Excel data source into a SQL Server database. Importing multiple worksheets from an Excel workbook into a SQL Server database typically involves using one of the following software application tools: SQL Server Import and Export Wizard, SQL Server Integrated Services, or SSIS, or the Open Row Set function. Importing data directly from Excel files using the SQL Server Import and Export Wizard involves following a sequence of dialog boxes through a series of well-defined steps. The settings can be saved as an SSIS package that can be customized and reused later. The Open Row Set function imports data directly into SQL Server from Excel files by using the Transact SQL Open Row Set or the Open Data Source function. This process is called a distributed query. There are two ways to extract data from a database: queries and report builders. A query is a question defined and sent to the data source to retrieve the data. Here is an example of the select command to retrieve data from a table. Reports offer a way to view, format, and summarize the information in a database. A database report is the formatted result of database queries that contains useful data for decision-making and analysis. Reports can be a simple list of phone numbers of all contacts, or more complex, like a summary report on the total sales across different regions and time periods. There are many data reporting tools that are popular on the market today, including ClearPoint, SAP Crystal Reports, and Jaspersoft Reporting. In this video, you learned that SQL commands are the instructions used to communicate with a database to perform tasks, functions, and queries with data. SQL commands can be used to search the database and perform other functions like creating tables, adding data to tables, modifying data, and dropping tables. SQL commands are grouped into three major categories depending on their functionality: DDL commands that are used for creating, modifying, and dropping the structure of database objects, DML commands that are used for storing, retrieving, modifying, and deleting data, and DCL commands that are used for providing security to database objects. And data is input into a database using queries, create database, create table, and insert into table, and data is extracted by using queries and reporting software tools, such as ClearPoint, SAP Crystal Reports, and Jaspersoft Reporting. Welcome to Backing Up Databases. After watching this video, you will be able to define the two types of database backups and explain the differences between the two, describe why database backups are important, and identify the four main physical backup methods. Backing up a database protects data, whether it is a person's or an organization's, from disaster and allows for restoring information when necessary. A backup, usually performed by a relational database management system or database manager, replicates a database or database server that can be saved either locally or on a backup server. Database backups are categorized as either physical or logical. A logical backup is called a database dump, and a physical backup is completed through a type of backup software. Some examples of backup software include ScaleGrid, CyberShield, Backup Ninja, and SQL Safe Backup. Physical database backups are copies of directories and data files, including data controls, transaction files, and archived logs. This information is necessary to perform a full database restoration with minimal application errors and data loss. The backups, which can be full or incremental copies of the physical backup, should always be stored in separate, dedicated storage space, such as a disk, tape, or in the cloud. A logical database backup contains copies of information about a database, such as tables, schemas, and procedures. This data is commonly exported as binary files using export-import tools. Logical backups are helpful when restoring or moving a copy of the database to another environment. Physical backups are simple and fast, regardless of the data format. The physical backup is a mirror copy that is loaded to another device. The downside to physical backups is that this type is typically used only to recreate the system at restoration and cannot do a full restoration if there are any missing files. In logical backups, only a selected set of data is backed up, saving time and storage. The downside is that there is no file system information, which complicates the restoring process. There are 4 database backup methods available: full, differential, incremental, and virtual. A full backup stores a copy of all files following an automatic preset schedule. Typically, files are compressed to save space, but a lot of storage space may still be needed. A differential backup simplifies recovery, requiring only the last full backup and the last differential backup to create a complete database recovery. An incremental backup saves storage by backing up the files generated or updated since the last backup. And a virtual full backup uses a database to track and maintain backup data, helping to avoid the pitfalls of other methods. Having a backup system allows access to data without time or location constraints. Multiple copies of data are kept secure at different locations, ensuring all information is preserved. Online backup services, such as cloud storage, offer additional protection for emergencies, such as natural disasters. Automatic backup and detailed file management enhance processing and recovery without needing manual effort. Having an online server backup saves effort when setting up a system and shifts the focus to database security, allowing the efficient use of available resources that saves time and money. A prompt and reliable backup solution enables businesses to avoid a loss of reputation and legal action if valuable information is lost. After making a solid plan and completing initial work, the database administrator should properly manage backups by automating backups, monitoring backups, keeping backup logs and catalogs, maintaining the database catalog, setting up dependencies, and validating backups. There are a multitude of ways to store data. online, USB drives, external hard drives, and local area networks. In this video, you learned that a logical backup contains copies of information about a database, and physical backups are copies of directories and data files, including data controls, transaction files, and archived logs. Backup copies allow data to be restored from an earlier point in time to help the business recover from an unplanned event. Storing the copy of the data on a separate medium is critical to protect against primary data loss or corruption. And there are 4 main methods of backing up a database. Full, which is a copy of all files following an automatic preset schedule. Differential, which includes the last full backup and the last differential backup. Incremental, which saves storage by backing up the files generated or updated since the last backup. And virtual, which uses a database to track and maintain backup data.